we detected a highly sophisticated and targeted attack on our corporate infrastructure.
I didn't used to think that a foreign military would come after us, and now they obviously are.
This was something that we'd never seen before.
A new kind of problem. It's not just country versus country. All of us are somewhat on these front lines.
It's their job, 24/7, to try to break into places like Google.
Hope is not a strategy. You need a team of professionals with exactly the right knowledge and expertise.
It's mildly ominous.
To do the kind of work we do, you need to cherry pick the best of the best.
I might qualify it by saying I'm an ethical hacker, but yes, I'd say I'm a hacker.
Definitely consider myself a hacker.
Hacker.
I wear mostly hoodies for some reason.
This is very serious.
The attacker's after something, and you want to find out what they're after.
The attack happens over Christmas.
Santa may arrive late this year.
Someone is always rattling your doorknob to see if it's unlocked.
We're constantly testing our products.
Car companies crash their cars to make sure they're safe. So do we.
So much more is at stake now.
Human rights.
Privacy, professional life, personal life.
The entire ecosystem around an election.
It's not just securing Google, it's securing the internet.
I'm in this battle because I believe we can win.
Hunt them down, contain them, and then boot them out.
Burn it down.
If any attackers try to get in, I want them to have a very bad day.
Imagine a technology partner invested in your dreams, where we take the time to understand your aspirations and give you the opportunity to transform them into reality through disruptive innovation. We are Axiata Digital Labs. We are a team of IT professionals, data scientists, cloud solutions specialists, creative design engineers, spanning 7 global offices. We are enriching the lives of over 500 million people. We have successfully delivered projects globally, specializing in digital telco solutions, mobile money, fintech, IoT, AI, machine learning, data analytics, and self-care solutions. Using our expertise and domain knowledge, we have helped challenge the norms of industries and rewrite the rules of engagement. We provide our customers with agility. We provide them future-ready products now. Axiata Digital Labs, advancing digital life.
PayPal has reached people where traditional financial institutions have not been able to reach. In the US, there are close to around 30 to 35 million users who don't have access to banking.
Not only do we want to power every transaction that happens around the world, but we also want to support millions of people around the world who are underserved by the current financial system. Payment just should be so convenient it becomes like air.
We needed a partner who has those capabilities globally and can help us and scale with us fast enough.
Google scored well across all of these criteria.
I feel they are my team.
Everything starts with the customer. No two people are similar. It changes how you think of a problem, what problems you solve, and how you solve those problems. We want the agility to make sure that we can deliver to our customers the features that they desire the moment we actually come to know of it. Every millisecond matters. I've never been more excited about what technology can do for businesses. Google Cloud is safe, secure, reliable. We could leverage them and go from just being a repository of data to creating information from that we could use to take our business to the next level.
We are helping millions of customers, making them part of the economy. It's just amazing.
We are here to change the world. That's what we are trying to do with payments.
Good morning, everyone. Welcome to the second day of our Axiata Digital Labs AI Forum 2022. My name is Pragesh, and I'm here with my co-host Ridmi to bring you the future world of AI and Metaverse live from Axiata Digital Labs, Colombo, Sri Lanka. So today we are joined by pioneers and knowledge experts of the industry to mark our last but not the least step in this glorious summit journey. Before we get started, let us shed some light onto the purpose of this summit and who we are as Axiata Digital Labs.
Thank you, Pragesh. We, Axiata Digital Labs, is the technology hub of Axiata Group, Berhad, Malaysia, a leading group in telecommunication services in Asia with over 350 million subscribers in 11 countries. In pursuit of Axiata's vision to be a new generation digital champion, we at the lab position ourselves as a key driver to deliver a range of innovative telecommunication products and services. This is the second consecutive year of our AI Summit, which was designed by our analytics and AI team as a CSR initiative of Axiata Digital Labs, joined with innovative pioneers in the field of AI to share their expertise and knowledge to advance the digital life for an AI-powered future.
So in 6 days of our AI Summit journey, which commenced on 14th of November, we had our first podcast series at the lab addressing the question, what's next in AI? Day one of our AI forum explored on some of the key areas of Metaverse, gaming, 5G, and its specific industry-driven use cases. This was followed up by an interactive panel discussion on building an inclusive Metaverse for industries and role of artificial intelligence.
We had a very successful day one at our AI forum, and for those of you who have missed these sessions or want to revisit any of them, please head over to our Axiata Digital Labs YouTube page. Make sure to subscribe to our YouTube channel for more exciting videos of the ADL AI Summit 2022. So Pragesh, why don't we share the lineup for the day?
Well, Ridmi, it's definitely going to be an exciting day to look forward to with our esteemed line of guest speakers who will share their knowledge and expertise under our theme for this year's summit, Metaverse. Today, we will further explore and discuss on some of the key data architecture and privacy risk of Metaverse and how the convergence of Metaverse and AI would reshape the future of business growth.
The keynote sessions will be supported by another insightful panel discussion, which we have aligned today under the topic of virtual Homo sapiens, where will the human race end up with Metaverse. We will have our second Geeks Hangout sessions conducted by our experts at Google on next-gen customer experience with Google Cloud ML and AI. To all the registered users for Geeks Hangout, this will indeed be a session to look forward to in improving your skill set on machine learning and artificial intelligence.
And that's not all with me. We are also giving away incredible prizes courtesy of our AI forum sponsors Huawei and Google. Today's prizes come courtesy of Google, and we are giving away a brand new Google Pixel watch and a 256 GB Google Pixel 7 to the lucky winners of today's AI forum quiz. Our quiz portal opens very soon, so stay tuned to find out you can enter to win these exciting prizes.
Great. I am sure that you all can't wait to kickstart this amazing forum. So without further ado, let us have the pleasure to start the forum officially. To give a good energetic start to the day, let me welcome one of our distinguished invitees to address you all with the opening remarks. So ladies and gentlemen, it's my privilege to welcome the Group Chief Information Officer of Axiata Group Berhad, Anthony Rodrigo, to welcome you all with his official welcome address.
Good morning and welcome to day 2 of this summit. First, I want to thank all the great speakers and partners in this event. Thank you for your time and effort at this summit. Today as well, we have a great program lined up for you. I just want to say a few words on the topic of AI and Metaverse before we kick off. AI has indeed moved from being science fiction to reality in the last few years, as we all have seen. We are already using AI technology for customer engagement, experience, as well as operational excellence. The impact of AI is quite real, and indeed it can be much bigger with right level of scaling with concepts such as AI Factory. ADL has been working with Group IT over the last couple of years to co-develop the data lake architecture on all major clouds and have developed hundreds of AI models to support various use cases across our group. So we began the journey of developing an AI Factory to run our use cases much faster, with the aim of getting to ROI faster and getting much bigger impact. ADL has been a key architect of this blueprint, and we have now operationalized this across several opcos with a plan to run across the group next year. This is a key enabler for us, we believe, going forward, to have a fully automated AI pipeline running our use cases so we can experiment much faster and get to impact much faster. We already see material impact from AI use cases in areas such as customer experience, next best offer, next best action, churn, network planning and operations, and going forward, potentially energy management as well. Hence, we are looking at AI as a basic enabler, be it in the end user applications, the mid ends, the back ends. We need to have AI stitched into these pieces. So we are engineering AI Factory into Axiata's TM Forum compliant, ODA compliant architecture and software stacks. On the topic of Metaverse, telcos indeed have a play and can play a key role in locally bridging content and consumers. Axiata has been a leader in API monetization in the region, and in fact, our API software is powered by ADL. We have built this on years of experience and knowledge running APIs at scale. So these platforms are ready, prime time to take on Metaverse applications. So hence we see that it's a natural progression to support Metaverse with Axiata APIs. We believe combining telco APIs and APIs running on top of our AI engines create a unique set of enablers to power Metaverse use cases. So we are also contributing to GSMA Camara and Openverse program, and we feel between AI and telcos open APIs, telcos can really enrich the Metaverse experience for users. While we are working on exciting Metaverse services in the spaces of B2C and B2B, Metaverse technology can be really applied in our own existing digital channels, improving customer experience as well. Therefore, with ADL, we are building the Metaverse enabler building blocks and AI Factory into areas DTE middleware. Since this is running across our countries, we feel this engine can actually power the next generation digital telco of course. With that, thank you, and I hope you all have a great program today. Thank you.
Thank you, Anthony, for those insightful words. Now it's time to start the day 2 of AI Forum 2022. With that note, let's move over to our first keynote speech. Ladies and gentlemen, let us introduce you to our first guest speaker for today, Erwin Huizenga, who will take us through the topic From Research to Ready with Google.
Erwin is a staff developer relations engineer on the developer advocacy team at Google. In this role, he focuses on machine learning operations and large-scale machine learning. Previously, Erwin was responsible for leading Google's ML practices in Europe, Middle East, Africa, and the Asia-Pacific regions. In this role, he has worked with customers like Spotify, HSBC, Gojek, ShareChat, LG, and Woolworths. Erwin has a decade of experience in the field of machine learning, data science, and cloud computing. Erwin, we warmly welcome you to our AI forum, and thank you for joining with us today. The stage is yours.
Yes, thank you for unmuting me. Hi, everyone. Thank you for having me. I hope everyone can see the slide. So today I'll be talking about how to go sort of from research to ready and solving for the future in the context of artificial intelligence, the topic of today's event. And I want to talk through some of the groundbreaking research we've done at Google and how this fuels a lot of our products and how this is fueling a lot of the innovation that is happening these days. I want to highlight a few key areas around natural language processing, model generations, image processing, all topics also related to things like Metaverse and Web3. So already there was a short introduction of myself, but let me do it a short one again. So my name is Erwin. I am based out of Singapore, and where I work as part of the machine learning team, focusing on things like machine learning operations and large-scale machine learning. And also I'm a startup advisor, so I work with a lot of startups across Asia and advise them on their journey fueling innovation as well. Feel free to always add me on Twitter or LinkedIn if you want to have a chat about some of the topics that I'm discussing today. So there's a lot of things that I want to discuss today, so I'm suggesting that we dive into it right away. In the end of the talk, I'll also leave some time for Q&A. So if there's any questions that you have during my talk, feel free to ask them as well, and I can take some of the questions in the end as well, and we'll leave some time for Q&A as well. Okay, so research at Google. So you probably heard a lot about Google and research and how we think about research. Research is essential for us as a company. It's essential for our innovation. It has been in the past, but also it's essential for all of our innovations in the future. And the philosophy that we have across Google research is that we strive to create an environment conducive to many different types of research across many different timescales and levels of risk. So when doing research as a company, there's different timescales that we have. Some of this research is more short-term focus, others are more long-term. And also there's different levels of risk, of course, when doing research. Some things we're pretty sure that work, other things are more like a moonshot, where we're not sure where we're going to end, but still we believe that it can be groundbreaking and it can take us in directions that we maybe haven't thought of. And at Google, research is very important also because it drives a lot of the products and the technology that we have and that we use for on our platforms. So a lot of our products are powered by our research. So this goes from, of course, Google Search that we all are familiar with, to things like Google Maps, of course, but also more newer projects like Google Waymo, AlphaGo that you have maybe seen on Netflix, the documentary, but also, of course, Google Cloud. So a lot of this research sort of ends up in our products and fuels our products. And I think that's very important when we look at research and how it drives innovation, is that it's important to think about, so how can we take successful research, or how can we take research and embed it in our products and improve the experience that our customers, our users have overall. That's very important for us at Google. And how we tend to do this is, of course, our research teams work and collaborate very closely with our product team. So from Google Search all the way to Google Cloud. So research teams try to align and work with these product teams. But there's two different paths that you can follow, right? When you want to process through this research, is that first of all, it can end up in a product. So research can end up in a Google Cloud product, for example. So one paper we published is about Dremel, and Dremel has become Google BigQuery on Google Cloud. So this research then not only becomes available for internal Google teams, but it becomes available for the wider customers that Google Cloud works with. But also another path that we follow is the one in green in the top, is that where we take research and we open source it. And that was already during the opening talk, we heard about the importance of open source, and also in the Metaverse context, is that I really believe that open source enables developers, enables organizations to also innovate and progress. So a lot of this research then also can end up maybe in the open source space. And some examples of this is things like Hadoop, but also a very famous one, a very popular one as well, is TensorFlow, a machine learning library, a machine learning framework for building machine learning models, and also more recent open source work around Kubeflow and building these machine learning platforms at scale. So there's these different routes how things can drive innovation and how things can drive a product pipeline. I think this is always very important when you come from this research angle to think about how can we drive actual impact through open source or through landing this in products as well. And how this relates and why this is important. So AI, I believe, is going to be a very important enabler for innovation in the future, and in the short-term future, also for the long-term future. But also it's going to be an enabler for the Metaverse as well, as has been mentioned in the opening talk as well. Is that research and AI have been impacting the merging of virtual, augmented, and physical reality, and blurs the line between interactions in online and in real life. So AI is a very key enabler in this. And I want to talk about some of the core technologies, research, and actually products and tech that can help drive this innovation across the board. When it comes to use cases, I believe there's a lot of different use cases. And I think I always believe in thinking in the art of the possible, right? So there's use cases around natural language understanding. So how do we take language from a human? How do we understand and take action on that? We see a lot of development on large language models. I especially see this across the region where Axiata is also present, so in Asia. But also we see a lot of innovation on generative adversarial networks, so generating things like text or images, which is of course very important for the Metaverse as well. And there's a lot of research around the image models in general. So from a research perspective, from a use case perspective, you see that this research is heading in all of these directions. And I talked about the art is possible, right? And if I show you this painting, you'll probably think about this painting that this is something that a human has worked on for a very long time and gone through the creative process of creating this painting. But actually the mind-blowing thing about this is that this is not an actual painting. This is a painting that has been generated by an AI model. This is the Theatre de l'Opéra Spatial from Jason Allen. And it was submitted actually to a art contest, and it won the art contest. So it's a text-to-image diffusion model, so a model that takes text and generates an image, a painting in this case. It took 80 hours of work. There's a lot of images that were generated and used for training, and there's a lot of cutting-edge models that are being used to do this. If you would have asked me 10, 15 years ago, can an AI model generate a human-like painting, I would have probably been in doubt and not sure if that was possible. Now we see that this is even possible nowadays. So a lot of this groundbreaking research and AI is happening these days. But there's more than only with GANs generating these image art type of models. I want to talk about two topics today that I think are groundbreaking as well and can impact a lot of the innovation that's happening, if it's innovation within the telecom space or Metaverse or even, of course, things like Web3. I think this is a lot of groundbreaking things, and we see a lot of organizations looking and moving into these directions. And I want to talk about some of this research and how this led to actual products and actual use cases being implemented. So the first one I want to talk about is vector search. So vector search is important when you take an input from a human, could be a text input, and then you maybe want to use that input to search in a database of articles or in a database of news. And you want to search those articles based on the text query. So you could do this by doing just keyword matching. So take the input and try to match that to see if that keyword or that input matches to something to the articles in your database, to say so. But this is very slow and this is very basic technique. So what you actually want to do is you want to do something like semantic search. So this is the idea of taking a piece of text and finding another text that is sort of similar to it. Not exactly the same, but very, very similar. So not only because it contains the same words, but it's semantically similar. So to a human being, these two snippets of text are very, very similar. This basically is, by the way, the problem that Google search tries to solve, but also that YouTube tries to solve. When you enter a text query in Google search, which web page is the best match for you as a user? Or when do you search for a YouTube video, which one is most relevant for you? For many, many years, this problem was ridiculously difficult to solve. It's very difficult for computers to solve. For us humans, it's natural, right? But in the past decades, it's become solvable thanks to techniques like vector embeddings. So where we try to represent something like a text or an image as a vector, so as a numeric representation. Actually, one of the first groups that done some amazing research on this, with some very well-known Googlers like Jeff Dean and Craig Corrado, was on efficient estimation of word representations in a vector space. So this research was already done in 2013, so almost 10 years ago. And it introduces a way, it's called word2vec, which is a very famous paper, and a way to embed individual words as a vector. And how it looks like is what we try to do is we take these words and we put them in a multi-dimensional space. So if you build natural language processing models, you're probably familiar with word2vec. And here's what it looks like. So we map this, like I said, we map these words into a multidimensional space so that the words that are semantically similar, so not exactly similar, but semantically similar are clustered together in groups. So I'll give you an example. For example, computer and programmer, or computer and robot. So we know that these words are semantically similar. And this technology drives a lot of the natural language processing applications that we saw, right? For example, in the case of customer interacting with customers, understanding their questions and trying to give them an answer. But nowadays we can even do better, right? So yes, word2vec is still used, but there's techniques that are better. So research has progressed over time. This is actually a paper that has been published in 2008 by Google as well, where we can embed entire sentences or paragraphs, essays, into an individual vector. So we're not embedding a word, we're embedding maybe a paper like this, or we're embedding a full piece of text that a customer has wrote. This comes from Google Research as well, from, like I said, in 2018, and it has made it a lot easier to do applications like text search. So how do we know an article is similar? So we want to create these embeddings and see how articles or how results are similar to each other. And then we want to put them in that embedding space as well. So now it comes. So often this research is published, and what we try to do, as I mentioned, is we follow these different routes of making this research applied and making it available to the community. And one way we do this is through our TensorFlow libraries, and TensorFlow Hub is is part of the TensorFlow ecosystem. So this research, this universal sentence encoder, has been made available on TensorFlow Hub, so has been open source for folks to reuse. So we see a lot of organizations, a lot of teams reusing this research for their own use cases, applying it for their own use cases. So the way that we do this for text similarity search is with text embeddings, right? Nowadays, there are also embeddings for all sorts of data types, right? And a good example is image embeddings. Allows you to do sort of reverse search with images. So for example, in this case, if you've seen a shoe and you want to find a similar shoe, you can do image search. And the cool thing is we can now even nowadays embed not only images or text, but we can also combine these embeddings, so combine these vectors. So let's say we can take an image, combine it with the customer information, so that we know about the customer, and use those different embeddings to even improve the search for in this case if it's image search. So we're using other data types as well and other type of embeddings and combine them to provide better results as well. So we can embed different types of data, and with sort of the multimodal vector applications, as we like to call them, and we like to match that with the user. So the applications that we're seeing using these type of vector representations, these type of embeddings, is the use cases are, there's a lot. There's just it depends on how creative you can be, and you can apply them in many different scenarios as well. So, and where we see a lot of important research, and what I think, in my opinion, is very cutting edge at this moment in AI is what we call neural deep retrieval. And the process of neural deep retrieval works like this. Everything, of course, starts with data again, and data could be text, could be images, could be more structured data. And then we generate our embeddings, our vector representations through deep learning models. So probably all of you are familiar with deep learning models. They've been around for a long time, and they now are applied to many, many different use cases. But they generate these embedding representations where we take this data and put it in a multi-dimensional space and see if we can cluster them together. So embeddings are vectors that are similar. So images that maybe are similar, or text that is semantically similar. And then there's a two-step process. So first of all, there's similarity matching. So typically what we do is that when the problem that we have is that if me or you as a user are doing a search, or you're using an image, do an image search, is that we have to take that input from you and then have to map that to the enormous database that we have, or all the data that we have. And doing that is very, very challenging. So we have to find this, we have to do, first of all, similarity matching. So we have to take your input and match it to similar items. So let's say if you're searching for an article or for an answer on your question, you have a question about your phone, the Pixel phone was mentioned, you go to the website of the telecom provider, and you have a question about that phone. And then taking that question and finding the right answer, or answers that are close to your input, is very challenging. And then once you have a group of those options, you want to rank them, right? You then want to apply something like ranking or scoring to rank those options and provide the best option to the user, the actual prediction. So it's a multi-step process. Again, to sum it up, you generate the embeddings, and given those embeddings, you have to retrieve the best options, giving the input, and then you have to rank those options. Neural deep retrieval. Doing that is is complex already if you do it on a smart scale and on a smaller scale. Let's say you have this running on your laptop or in a notebook if you're a data scientist. That is already challenging to get working. But operating these systems at scale and maybe at the scale that Axiata has is something that is more complex, right? Because you have a lot of customers, you have a lot of users, you have a lot of data. So things become more and more complex. So given a query, a vector, so it could be a text search, how do we find its nearest neighbors as quickly and as efficiently as possible? Quickly meaning with low latency, efficiently as possible, is that we don't want to have a lot of compute running all the time and pay a lot of money to run these queries. So we have to balance accuracy, latency, and efficiency. And that is not easy to do, and that is especially not easy to do at scale. So in a research setting, things are nice, but now we're hitting the challenge like, oh, where are we, how and are we going to run these use cases in production? This is where vector similarity search comes in, also known as k-nearest neighbors or approximate nearest neighbors. So giving a input, a vector, we want to find its closest or its nearest neighbors. So if we have an image of a shoe or we have a search query, what are the closest results to that? So, because then we can take those results and rank them and show them to the user. This is a critical step in most neural deep retrieval architectures. And this is not an easy thing to do because you have all these options and how you're going to find the best results in a short period of time. This is where, again, the research to product comes into play, right? What we've done with this research that that Google has done, we've embedded that into a product that is used by Google teams internally and is even available on Google Cloud for folks to use. So it's a massively scalable vector similarity search capabilities. So the thing is that I talked about is that what we want to do is we want to find with low latency the nearest neighbors just in a few milliseconds, right? Because most of these applications that we have nowadays, users and customers are used to the things happen quickly with very low latency. In the metaverse, it will be the same. Things have to be fluent. Things have to be quickly. Of course, this needs to be highly scalable, right? So if the users grow, the number of users, if the number of search queries, or if the number of image search or grow over time, we have to be able to scale these applications as well. And of course, we want to do things cost effectively as well, right? So this is where we developed technology, we researched, we made it available on Google Cloud as well as a matching service. So and what we actually do here is leverage Google Cloud, Google research technology that we use internally for our services as well and make it available. So we try. So there's been this research on from 2020, which made significant headway in solving this problem. And what we've done is we designed a new algorithm which is called SCANN, S-C-A-N-N. So scalable approximate nearest neighbor search. So again, we're trying to speed up the calculation of the distance between vectors and do that at scale. So we have to approximate. So let me explain what that means. Is that if we, for example, do an image search, so you take the image of the shoe and you want to find similar shoes, is that we can't search through all of these shoe images that we have. So what we have to do is we have to calculate the distance. So the image that you use to search, we have to calculate the distance with all the images that we have in our database because we want to have the distance that is the closest, right? So the images that are most similar to the one that we're using for the search. And so we have to calculate what we call the distance between those vectors. So you remember the word cloud that I showed earlier. So we will want to find the words that are closest to the one that's our impact. And we can't do that for everything. So the way we try to do that is through approximation. And one of the most popular techniques to do this is with quantization. So we take these millions of options, millions of vectors, and we actually map them to a smaller set of points so that we can approximate the distribution of the entire set. So it's all about this approximation as well. What this research paper published in 2020 is that we introduced this, as I called it, scan algorithm. So the scan algorithm found a better way of mapping. So taking this huge data set of vector points and map it into a smaller one. A technique that we call anisotropic vector quantization. What it does allow scan it to do is find more accurate the nearest neighbor for a data point. And it also, remember, low latency is important, allows us to do higher queries per second. So we can do more queries in a second. So we built this internal engine and it powers things like Google Search, YouTube, but also a product on Google Cloud, Google Matching Engine. So what this technology can help us with is improve use cases like recommendations, like search, and we can improve through this cutting edge technology, the customer experience that people are having on the platform or even in the future on the Metaverse. Another area of research that we are very, very excited about, and that is impacting a lot of the innovation that we're seeing across the board, is neural architecture search. So the challenge that we have when we go from research to having something in production, to having an ROI or having a return on that research investment, is that the challenge there is that iterating fast through the process, especially when it comes to AI. So how we did this in the past is that we had a research. So if we all think about our research days, or when we were in university, or when we were in college, is that we have to collect data, we have to think about the best approach, we have to develop it, we have to test it, so on and so forth, which is a time-consuming process. So how can we speed up this process, and how can we especially speed up the design of new AI architectures? So given a use case, could be any use case, what is sort of the current best architecture to apply to that use case, which is in the past was a very time-consuming, human-intensive process. This is where neural architecture search comes in. So what it is with neural architecture search, or NAS, is a technique for automating design of neural networks. So this is a AI model designing the architecture, AI architecture for a given use case. So in a typical NAS setup, there's a controller that proposes machine learning models, so sampled from a search space. So this controller generates model architectures. And then these architectures, what it does is they are applied to the use case. So if you do recommendations, if you do image classification, it will then apply these architectures to the use case. It will train it, and it will measure its performance, and it will iterate through that process. So generating new architectures until it finds a given architecture for a problem. This is how now a lot of these state-of-the-art models are designed. How did this all? So what it does? It's the controller gives us the ability to speed up the process of designing these architectures, and we can balance even things like accuracy and latency. Right? If we need to do predictions at the edge, we need to do this with a smaller model, but still with high accuracy but low latency. We can design these type of architectures in an automated way. So how does this all start? And I'll take a quick sip of water. So in 2016, Google researchers published a paper called Neural Architecture Search with Reinforcement Learning. I think there's a talk on reinforcement learning as well during these 2 days, if I'm not wrong. In this paper, they showed the researchers how a recurrent neural network, which is a specific type of neural network, can generate model descriptions of neural networks. They trained this RNN, so recurrent neural network, with reinforcement learning to maximize the expected accuracy of the generated architectures on a validated set that we have. Using this method, they were able to design novel architectures on the dataset, which is the CIFAR-10 dataset, which is a famous dataset. And these architectures are designed based on expected accuracy of the model. So since the paper, the research field has continued and speed up even more. And including reinforcement learning based techniques, there are also now, there has been introduced PyGlove, which is a symbolic language that we can use to help convert your machine learning code into a NAS program. So you can generate machine learning code and it then becomes a NAS program that designs these architectures for you. And the cool thing is that, again, this research has been adopted across Google, but not only across Google, but also by other Alphabet teams. Waymo, the self-driving car arm of Alphabet, has been applying this technology in one of those use cases. And I think the fun thing about this is that when we have these, when we have AI, neural architecture search, NAS, designing these new type of models and new type of machine learning, is what we see is that they come up with very interesting new architectures that maybe we as humans have could never design. So they actually mix layers in the neural networks that we maybe have a thought of, or skipping layers where we didn't think of it. So the designs are very, very interesting for look at. So very creative combination as well of layers. And we've seen is that this has helped us innovate and improve our use cases as well, in this case for autonomous driving. But also we see this used across Google and with other teams as well. So for example, the Google Pixel 6, and we wanted to do efficient energy phase detection. So through NAS, the team was able to generate a model with the same accuracy, but a model that uses 70% less energy. So it's not only about accuracy. We talked about latency and efficiency. And energy efficiency is something that's very important for us at Google as well. We heard in the opening talk as well. So through using this technology, through using this research, the team was able to come up with a more efficient model, but not compromising on accuracy either. And here again is that what the team has done is that they have not only done the research, they have not only embedded the research within the Google products, but also this technology is now available for developers, for customers to use as well, so that other industries can benefit from this technology as well. Through, in this case, for example, the Vertex AI platform, where we have a neural architecture search API and service. So it can help the team with building models faster, designing new architectures, improving existing models in a flexible and scalable way as well. We believe in enabling other organizations through our research as well. So what powers this progress, right? And I want to stop here for a second to think about this, is that the progress in the past 10, 20, 30 years, 50 years has been immense, right? And I feel that it's even speeding up more and more and more. We see, if we look at the AI space, the number of research that has been published is is growing every year, and it's even more impressive every year. But applying that research to actual use cases that we talked about, and applying that research to innovation in the future, like that we talk about today, like Metaverse or Web3, is something that is challenging, and that but we've gotten better and better and better at. And why have we gotten better? It's, of course, the research has gotten better, the technology has gotten better. I've talked about all of that, right? It's technology is now available on the cloud platform, Google Cloud. I talked about some of that technology, so that the enablement is there. But there's also two other things that we all often talk about as well, and that are still important, is that the size of the data is still growing. The quality of the data is improving over time, and we're getting better at using not only structured but also unstructured data, as we talked about that too as well. And so all of that enables also that we get better at applying this research in production type of settings. It also adds a lot of complexity that we talked about. So how do we do this at scale? How do we do this efficiently? How do we do this with low latency? All of these things become more and more complex when the data grows as well, right? The quality of the models improve, but also the complexity increases as well. But also what we've seen, and where we've seen a lot of innovation, and especially we've seen this, we talked about this a lot at Google, is that the computing power has helped, has become so much more efficient, and we have now things like TensorFlow processing units, TPUs, and you see generation V4 here on the slide. These are what we call our TPU pods. So these are like a supercomputer, and this is used not only by research teams to train these models at scale, but also we see this used by organizations and companies to train models for their use cases. And what we, for example, see a lot is happening applied research, or actually applied use cases around large language models. So through the growth of data, through our improvement or innovation when it comes to computing power, we've been able to get better at applying research in production as well. And especially this work that has been happening on TensorFlow, on TPUs, so TensorFlow processing units have been, tensor processing unit has been immense and mind-boggling for me even. So, and it will only, like I said, speed up and continue. So there's so much exciting stuff happening as well. And a lot of this research and technology innovation is, I think, driving a lot of the change that we see in the future. So I just want to do a short recap of what we talked about. So yes, I fully agree with what has been said in the opening talk as well, but that AI is a very important enabler for innovation, that AI is also an important enabler for things like the Metaverse, but also other types of innovations around Web3 we talked about, is that AI will only keep speeding up that innovation. And some of the key areas, and of course there's way more beyond this, but we don't have enough time for that today, is that we see things like around embeddings, a lot of amazing work about similarity search. We see a lot of great work around neural architecture search, so designing new types of neural networks. So there's a lot of exciting things happening, and I hope you've taken or learned one or two things from today's talk. I just want to thank everyone for being here today, and thank you everyone for joining this keynote as well. So I can now, if we have time left, take a few questions. Are there any questions that we have? Okay, there's 3 questions, and I'm looking at my device, my Pixel, because they are shared there. Yes, great first question. So let me first read out the question. Will non-data science people be able to build ML models with new advanced AI and ML cloud tools? Great question. Thank you for asking. Yes. So I feel that is, I haven't talked about that today, but one of the biggest innovations I feel that's happening right now is that we're, through technologies like we talked about today, that are then being used and implemented in solutions, but also things like automated machine learning toolings. So if you look at Google, we have on Google Cloud AutoML, which enables business analysts, folks that are not as technical as data scientists, or even maybe engineers who want to quickly build a use case. They are enabled through this technology to go through the interface and quickly train and deploy these types of machine learning models. And we see this used a lot in applied as well in use cases. So great question. And yes, I see that there's a lot of innovation happening there as well. And these automated tools, automated machine learning tools are enabled through that. Yes.
Hi, Abin.
Erin, let's go for the next questions after a little break. So we'll be back after a short break.
We detected a highly sophisticated and targeted attack on our corporate infrastructure.
I didn't used to think that a foreign military would come after us, and now they obviously are.
This was something that we'd never seen before.
A new kind of problem. It's not just country versus country. All of us are somewhat on these front lines.
It's their job 24/7 to try to break into places like Google.
Hope is not a strategy. You need a team of professionals with exactly the right knowledge and expertise.
It's mildly ominous.
To do the kind of work we do, you need to cherry pick the best of the best.
I might qualify it by saying I'm an ethical hacker, but yes, let's say I'm a hacker.
Definitely consider myself a hacker.
Hacker.
I wear mostly hoodies for some reason.
This is very serious.
The attacker's after something, and you want to find out what they're after.
The attack happens over Christmas.
Santa may arrive late this year.
Someone is always rattling your doorknob to see if it's unlocked.
We're constantly testing our products.
Car companies crash their cars to make sure they're safe. So do we.
So much more is at stake now.
Human rights.
Privacy, professional life, personal life.
The entire ecosystem around an election.
It's not just securing Google, it's securing the internet.
I'm in this battle because I believe we can win.
Hunt them down, contain them, and then boot them out.
Burn it down.
If any attackers try to get in, I want them to have a very bad day.
For the question number 2 from our audience, Erwin, can we use neural deep retrieval architecture for high dimension tabular data with auto-encoder vector representation?
As I mentioned, for use cases, combining different types of data. So could be things like images with more structured type of data that's maybe very sparse. So we see a combination of data, and I think that's going to be the future as well, where you combine different types of data. You see that already happening a lot in recommendation systems, right? You have user data, and you have maybe something like a product that you want to recommend, or an image, or a video. Yes.
Okay, we have another question. Is NAS part of current GCP AutoML?
Another good question. It's yes, that is also the short answer. So a lot of these technology and research drives a lot of the products that we have on the platform as well. And I think we've always been pretty good at that. Is making sure this research lands in products, for example, on Google Cloud AutoML. So yes, it's part of that as well. But you can also use it as a separate service on Google Cloud as well for your use cases that you have. So there's different options, there's different flavors depending on what type of user you are.
So Erwin, the last question from our audience. What is the applicability of Google Pixel 6 for federated learning?
So I don't think federated learning is tied to a specific device, and I'm not very familiar with all the Pixel hardware. So I would divert that question to look at what we have on the TensorFlow federated learning website, or even on the Pixel specs. But I think there has been some work on specific hardware on phones these days with Pixel, but I'm not part of the Pixel team, so I want to be careful with my answer there. So, but it's again a great question.
All right then. Thank you, Erwin, for enlightening us on the research methods at Google and how it has been applied for Google productization.
Thanks, everyone.
Thank you. So Ridmi, what have we got lined up next?
Well, it's time for our second keynote speech of the day with two distinguished speakers. They will share their knowledge and experience on federated learning for telecommunications. It's our privilege to introduce our next speakers. Start with Dr. Joe.
Dr. Joe Sang is a Senior Partner Solutions Architect at AWS. Prior to AWS, she worked at Fujitsu as a research scientist. She was also an assistant professor at Arizona State University from 2005 to 2008. Dr. Joe received her PhD degree in computer science from the University of Texas at Dallas in 2005. She holds more than 30 patents and has co-authored more than 100 journal and conference papers in the area of telecommunications.
Also, we have Subhash Thaluri, who is the lead AI ML solutions architect of the Telecom Industry Business Unit at Amazon Web Services. He has been leading the development of innovative machine learning solutions for telecom customers and partners worldwide. He brings interdisciplinary expertise in engineering and computer science to help build scalable, secure, and compliant AI/ML solutions via cloud-optimized architectures on AWS. So, welcome to AI Forum 2022, Dr. Cho and Subhash. Stage is yours.
Thank you very much for the introduction. Now we're going to talk about federated learning for telecommunications. Their growing importance and attention to privacy as represented by this worldwide GDPR fines. There is 20 times fines in 2021 Q3 compared to the sum of Q1 and Q2. Corporations violating privacy regulations, which we anticipated tightening around the responsible use of machine learning, are expected to face higher financial penalties. If we compare the transformative power of privacy enhancement methods, we can see that there are alternatives, like multi-party computation, zero-knowledge proof, and others. Federated learning by far stands out among these options as the most effective. Today, we're going to talk about what is federated learning, why is federated learning growing in importance, and how to build federated learning operations on AWS. And then we're going to talk about federated learning use cases in the telecommunications industry. Federated learning is a distributed machine learning approach that trains machine learning models on distributed datasets. Let's walk through an example. So imagine that there are 5 banks in 5 different countries, each wanting to fight crime. They'd all like to find a better financial crime model. Each of them has their own dataset. Each of them has its own IT group and machine learning systems. And each of them has already detected fraud patterns to fight financial crimes using that data. However, more international banks discovered that their crime has different patterns, and some banks might uncover fraud patterns that other banks have not. So if all these banks would put their knowledge together, they may discover one global fraud detection model and would fight financial crime much better than any of these individual ones. The problem is that none of these banks like to share their data. They each have sensitive customers and have a natural aversion to share customer data with their competitors. Federated learning provides a mechanism to collaborate. It enables sharing data to train a central global model using the customer experience data from all of these enterprises without sharing proprietary data. The terminology here is simple. On the left side, you see the federated learning clients. They can be on premises, at the edge devices, or on the cloud. On the right side, we have a federated learning server, which is responsible for the aggregation of a global model. The goal is to improve the accuracy of individual clients' machine learning models while preserve privacy. And we will see other benefits as well later. Individual federated learning clients share their local models to a federated learning server that takes those local inputs and aggregates them into global model. The global model is in turn sent back to each of the federated learning clients. As a result, the global model usually performs better than their local models. There are different flavors of federated learning. And based on features in distributed datasets, we can have horizontal and vertical federated learning. In horizontal federated learning, each distributed dataset has the same set of features. In the example on the left side, you can see that both Bank 1 and Bank 2 have the same features, customer ID, age, and zip code. While in vertical federated learning, each distributed dataset has different set of features, but with overlaps than the ability to map to the same record. For the example on the right side, you can see that Bank 1 and Bank 3 have different features, but they have the same feature, customer ID, to map to the same customer. And based on how federated learning clients are interacted, there are hub and spoke and peer-to-peer mesh-connected clients. And based on when to aggregate at the server, we have synchronous and asynchronous federated learning. In synchronous federated learning, the server aggregates a set of local models after waiting a while to collect this set of models, and then aggregate them into a global model. While in asynchronous federated learning, the server immediately updates the global model once a single local model is received. So why is federated learning important? We have observed 4 benefit patterns for federated learning. The first pattern is cross-device, where thousands or even millions of devices, such as mobile devices, collaborate together to train a global model. The benefit is for privacy preservation. And the use case areas for cross-device federated learning include edge ML, retail, and automotive areas. The second pattern is cross-silo, where tens or hundreds of organizations and the companies work together to train a better model. These organizations and the companies have their own data set, their own local models, but they can use federated learning to train a global model that is more accurate than their own local models. The use case areas for cross-silo include inter-institutional collaborations, financial service industry, government projects with highly sensitive data. And the third pattern is intra-region training. Due to data localizations, due to operational challenges or high cost of transferring large amounts of data to a central repository, federated learning can be used to train models across distributed datasets within the same organization. Hence, the purpose of federated learning here is for cost saving. Its use cases area include applications requiring global reach. And machine learning with larger data size and relatively smaller models benefits more since exchanging smaller models in federated learning saves more data transferring cost. And the fourth pattern is hybrid cloud that provides operational flexibility for data. In this scenario, a local dataset can be augmented with other cloud available datasets. It is also used in high sensitivity use cases for efficient bursting. When some companies use the cloud just to burst for excessive capacity and need spike, they don't need to move everything into the cloud. You can leave your own on-prem in your own prime environment and still capture and harvest the learning from that. Federated learning can be applied to different vertical industries, such as financial services, life sciences, industrial AI, public sector, telecommunications, and transportation. There are still many challenges in federated learning. One key challenge is data heterogeneity. For example, one dataset has all the cat images and other dataset has all the dog images. Data heterogeneity impacts the accuracy of global model, leading to more training iterations and longer training time. Many solutions have been proposed to mitigate the impact of data heterogeneity. The second key challenge is privacy preservation. The local models and the global models exchanged between the server and clients may leak private information via reverse engineering. And many privacy preservation approaches have also been proposed for federated learning, such as secure aggregation, local and global model differential privacy approaches. And the third key challenge is federated analytics. Federated analytics provides statistical measurements of distributed datasets without violating privacy requirements. Federated analytics are very important not only for data analysis across distributed datasets before the training, but also for model monitoring at inference. Despite these key challenges of federated learning algorithm, it is also critical to build a secure architecture that provides end-to-end federated learning operations. The architecture must coordinate federated learning servers and clients for model building, training, and deployment. The challenge for building such architecture include memory and computational constraints, cost optimization, and the billing among the server and clients. So how to build federated learning operations? Here we show the steps for federated learning operations. On the right side, we have the federated learning server, which includes a model registry and some computer resources. And on the left side, we have a single federated learning client, but actually we can have many clients here. Federated learning operations need to provide continuous integration and continuous delivery. Therefore, we need a code repository and for the server and the client to agree on customized algorithm, such as here, the global, the aggregation algorithm, and also for them to agree on the global model, such as we can use a model.py, and also agree on the configuration information for the server and the clients to interact with each other. So step 0 is to set up the federated learning server and the clients after downloading the federated learning package and to trigger a federated learning training task. Any change in the code repository once agreed upon clients may trigger a new federated learning task. Then step 1, after the task is triggered, the server notifies clients that, hey, the global model is ready. And then step 2, federated learning clients download the global model from the federated learning model registry. And step 3, the federated learning clients start local training, and the local training generates local models. And then step 4, the federated learning clients upload their local models and the local model information to the model registry. It may include the number of samples in the local dataset, the client ID, the local training and testing accuracy, etc. And step 5, once there are enough local models collected at the model registry, the server aggregates the local models into a new model, new global model, and then writes it back to the model registry. And steps 1 to 5 is a single federated learning training round. And there can be hundreds of federated learning training rounds until the number of federated learning training rounds reaches a threshold. And then step 6 is to deploy and monitor the final global model at the inference sites. And we can see that the federated learning server plays a very important role here. So who can or should be the federated learning server host? It can be one of the clients, it can be all of the clients, it can be none of the clients. And in this case, it can be the private third party, can be the government, can be the clearinghouse and credit bureau. However, billing, trust and access control among the server and clients need to be carefully considered, and the contractual agreements may be needed. Here we compare the federated learning operations with the machine learning operations. Machine learning operations consist of centralized data preparation, training and tuning, and then model deployment and monitoring. While federated learning operation consists of parallel data preparation at clients, and then federated learning, and the model deployment and monitoring. Actually, the model deployment and monitoring can reuse what MLOps has. Now let's see a demo. Here you see 3 windows. The window on the left side is the server. You may see that it has the AWS step functions. And for the window on the top right is for client 1. And client 1 is at the same cloud account as the federated learning server. It simulates the scenario where you have distributed data sets within a single organization. And for the client 2, which is on the bottom right, it is client 2. It is at a different cloud account from the federated learning server. It simulates a typical federated learning scenario where different clients can be at a different cloud account. So in the step function, which is the server, we can see that there are step 0, initialize, step 1, notify, and then step 5, aggregate. Here is the client 1. We can see the directory architecture of client 1 and client 2 are very similar. There's a code repo, which is the code downloaded from the code repository, and local data set, and the models, which are the local models generated, and also federated learning client classes. And also there is a local data processing at each client. In the code repo, you may see that we have a cross-account information, configuration information, and also model.py. In this cross-account information, because client 2 is at a different cloud account from the federated server, so you can see that there are several cross-account roles for client 2 to assume in order to access the services at the server. While client 1, there is no such cross-account role to assume. Now let us start client 1. It is under local data processing, and start client 2. It's also under local data processing. Now let us start the server. It is at the step 0, which is to initialize the services needed at the server. And then the server notifies the clients that the global model is ready. It sends out the notifications to the clients. And here, client 1 received the notification. It is at the federated learning round 0. You can see there is a task token, and this task token is corresponding to a specific notification sent from the step function. And step 2 is download the global model. Step 3 is local training, and step 4 is upload the local model and its information to the server. And then go to the step federated learning training round 1. Now we are at the training round 2. And you may notice that we also printed out the training accuracy and the testing accuracy at each client. And actually, after each federated learning training round, you may notice that those training accuracy and testing accuracy are gradually improving. And at the server side, you can see that there is a condition satisfied, which is to check if the current constraint, here we configure is the number of federated learning training round reaches 8. If this constraint is not satisfied, it will go for next training round. If it's satisfied, it will go to the step of yes, end the training. Now we are at the federated learning training round 4 and 5. Since our federated learning training round starts from 0, so it will end at the federated learning training round 7. Now we are at 6 and training round 7. That is the last training round. Now the training ended, and you can see that the step 6 comes is to download the federated learning trained global model for deployment. Okay, so how to build such platform? So here we showed the reference architecture for such platform. We have a federated learning server on AWS and the federated learning clients on premises and on also another federated learning client on AWS cloud. On the server side, we have AWS step functions, iterate federated learning training rounds. And for each training round, the step functions sends out SNS notification that are queued by Amazon SQS. And each federated learning client has a corresponding SQS. And the federated learning model registry consists of Amazon S3, storing the global and the local models, and also DynamoDB, storing the local model information. And here we also enable DynamoDB stream to trigger AWS Lambda. Whenever a new local model is collected, AWS Lambda is triggered to check if there are enough local models collected. If yes, the Lambda aggregates the local models into global model. And the resulting global model is returned back to the Amazon S3. And the AWS step functions then determine if the federated learning should be terminated based on some constraints. And here we say that the number of training rounds reaches threshold. And on the client side, the on-prem federated learning client uses AWS SDK and CLI to securely access the services at the server. And the client on AWS can use a private link to access the services for secure communication. There are several advantages for this architecture design. First, it uses cloud-native services that have proven security and operational excellence. It's built from ground up for federated learning so that you're able to run customized federated learning algorithms in those cloud services. Second, there is no direct write from the server to the clients. Instead, the clients are able to pull and push information to the server based on their own willingness. The clients will be safe and no internal system to be shared by outside entities. And third, here we have the server use serverless services instead of using a persistently running server, which reduces the computation cost at the server side. Now I will hand over to Subhash to talk about federated learning use cases in telecommunications industry.
Okay, hello everyone. Thank you, Dr. Zhang. Thank you for that first half of the session. So now that we have looked at what federated learning is, and we've also seen a demo on how it was developed on AWS, we want to now look at some of the use cases, and particularly, the application of federated learning in the telecom industry. So the objective here is to really motivate all of you to look at federated learning as a way of problem solving for some of the challenges we have, and we'll talk about 3 different use cases in the next few minutes. So the first one is the application of federated learning for telecom fraud detection. So the use case here is, as you can see on the top left, is a roaming scenario. So how do we detect roaming fraud scenario that communication service providers often face? Here you see that a subscriber who is part of a home network is now roaming in a visited network, and there's a data exchange between the visited network and the home network that happens through file exchange in the form of near real-time roaming data exchange. So the roamer might be placing originating call and terminating calls from their device, and this can take many different type of fraud scenarios, such as international revenue share fraud, roaming abuse fraud, permanent roamer situation, etc. Now, if on the right here, we have seen the concept of federated learning, and we try to now put them in the context of communication service providers. There are, let's say, in this example, there are 3 of them, CSP A, B, and C, and each of them run their own local training for fraud detection. Now, the problem with that is because fraud is a rare event, it is an anomalous event, the number of data points tend to be very less, which means the imbalance in the data is quite high. So typically when, let's say, one CSP runs their machine learning training, they would aggregate home network data and their roaming ADRs, roaming data that comes from the visited network, combine them, aggregate, enrich them, join them with their ground truth data and do iterative machine learning to be able to identify fraud. But because of lack of enough data points, it might be the large imbalance problem leads to poor model performance. So what we propose here is basically, if with the federated server, if multiple CSPs, communication service providers, can take all their learnings, assemble all those local models, and send those local updates to a federated server, and the model weights that are shared by the global model can do a much better job at detecting telecom fraud. So this is one use case in telecom. The next one I want to talk about is personalized customer experience for ride hailing. So you might ask me how this is related to telecom. Let's say you have a ride sharing service. Yeah, there are a number of cars. The idea here is, when a rider is in an active ride, they're probably not doing anything. So here, the CSP might want to have a tablet for which the connectivity is provided by the carrier, and it's a device that's owned by them. And the objective is that that particular tablet being able to detect whenever there is an occupancy, and the data concerning an active ride comes from the ride sharing service. And once a human is detected, they would open up they'll have that tablet available to that rider to have some personalized experience and interaction with it. Now, in this case, there are two challenges. One is the human detection needs to happen through the tablet's camera, which means it needs to take an image without permission. So that leads to privacy issues. Now, this is where federated learning can come in place, where the moment a picture is taken at different timestamps, in order to detect whether a human is present or not in the back of a car, they could, it would do a local training based on, basically a local model that's deployed on each of these tablets. And all of them, they share those weights to a federated learning server. And immediately after the local training happens, the image is purged. So the image does not leave the device and nobody has access to it. And the lifespan of that image is quite short. So in this way, the privacy concerns are addressed, and at the same time, you're able to give personalized experiences to the riders in a ride-sharing service. So that's the second example. The third one I want to talk about is equipment monitoring for rare events. Now, the flavor that this can take in terms of telecom is all CSPs, they have huge data centers and different equipment that are mission critical. So that means, and they're backed up with power, right? And there could be generators that are supplying this power to all these mission critical systems. In this scenario, what happens is the use case here is you have a thermal camera in a generator room that's supporting a data center of a communications provider. And the idea is to detect leaks using heat signatures from these thermal cameras. Again, it's based on image recognition. These images would be assembled. The local training happens at each of the individual sites. All those local training is transferred over to the federated learning server, where a global model can learn better with all the information that's coming from multiple sites, and then have a better performing model that can be deployed at each of these individual sites. So these are the three use cases when it comes to federated learning. And when it comes to closure, like despite the challenges in FL, we are seeing tremendous potential. So this is in the case of personalized federated learning, the increasing regulatory pressure on ML, even in large language models, which is a fast evolving space, FL experiments are showing promising signals. So our call to action to all of you today is, try to look at solutions that can leverage federated learning and federated learning operations. We are happy to co-build with you for the challenges and for different architectures and the use cases. We'd be very happy to work jointly on your use cases. Please do email us if you'd like to work with us.
Great, so stay tuned with us. We have a Q&A sessions coming up next for Dr. Joe and Subhash. We'll be back after a short break. So let's start the Q&A session. The first question is for Dr. Cho. Will federated learning help to achieve strong AI?
Federated learning majorly is for training machine learning models. One typical machine learning model trained by federated learning is neural network. It can be ANN, can be CNN, can be RNN. So if strong AI is enabled by deep learning neural networks, yes, federated learning is able to help.
The next question is down to you, Subhash. What are the applications of federated learning in the metaverse?
Yes, thank you for that question. While when it comes to metaverse applications, I would probably answer this with respect to the back end, where the spatial computing that is necessary to support applications for metaverse. In such a scenario, federated learning, especially learning on the edge devices, can certainly help.
Okay, Dr. Cho, any ML algorithm can be trained as FL model, or do we need specific algorithm for FL?
The typical model or machine learning algorithm is neural network. Yes, you do for some different models, you may need different algorithms. And another popular actually is under research is having XGBoost model to train on federated learning. And some other models are not, right now is not commonly trained in federated learning and is under research.
So Subhash, will model overfitting happen to the local training environment in this process?
Yes, that can certainly happen. Now, the example that we have just talked about that uses telecom fraud detection uses autoencoders, which is for anomaly detection. Whereas, the other examples were around image recognition. Now, that said, model fitting can certainly happen. The local training is up to the organization that's conducting it, and the same standards and protocols that you would follow when it comes to looking at model performance, all that will apply with the enhancement of federated learning server that can make these models much better at a global level.
Last question is for last question is for Subhash again. So AWS already has standard telco data around the globe since it hosts many telco data lakes. Do you have already built FL global mods built using those data that we can use today?
No, not necessarily, because every customer who uses AWS get their own part of the cloud where they're operating in. So that means all the standards and compliance and security are in place. So they own the data. The security of the cloud is the security of the cloud is the responsibility of AWS, but security in the cloud is responsibility of the customer. So that said, all data is with compliance to all the standards. So the access is only available to the customers. So that means we cannot enable such type of cross-learning unless there's mutual agreement in place.
Subhash, for sharing your insightful knowledge with us. It was such a pleasure listening to you both. So next, viewers, we are going to start the first quiz of the AI Forum 2022. So Pragesh, how our viewers can engage with this quiz session?
So Ridme, here's how it works. In a few moments, we'll be asking you an AI and metaverse related question based on the insights shared by our esteemed guest speakers. When you're confident with your answer, head over to our website aisummit.axiatadigitallabs.com and click on the quiz link in the top right-hand corner and enter your answer with your details.
We'll be selecting one lucky winner to walk away with a top-of-the-line Google Pixel Watch and a 256 GB Google Pixel 7 from today's AI Forum sponsor, Google. Hope you all can see the full URL on the screen now. And head over there and enter to stand a chance to win today's AI Forum quiz. Remember, you do have to register for the AI Summit to be eligible to win.
Also, Ridhvi, the quiz portal stays open until 4 p.m. Sri Lanka time today, so don't waste any time if you really have your eye on that Google Pixel 7 and Google Pixel Watch. Now it's time for the question. What describes a digital twin which helps in advancing user experience in the metaverse? Let me repeat that question again. What describes a digital twin which helps in advancing user experience in the metaverse? So the answer choice is choice number 1. A physical digital view integration that assists with analysis, monitoring, prediction, and simulation. Choice number 2, a brain-computer interface with action recognition. Choice number 3, an ultra-reliable low-latency communication tool. And choice number 4, a language modeling and semantic labeling mechanism. Let me repeat that question again. What describes a digital twin which helps in advancing user experience in the metaverse? Your choice of answers are choice number 1, a physical digital view integration that assists with analysis, monitoring, prediction, and simulation. Choice number 2, a brain-computer interface with action recognition. Choice number 3, an ultra-reliable low-latency communication tool. And choice number 4 is a language modeling and semantic labeling mechanism.
Go check your emails. You will get an email with all the details, questions, and how to answer with the link. So while our viewers are busy with answering to that question, we are going to switch gears now to showcase some of the fantastic products that have been developed by our AI analytics team right here at the lab. Let's take a look.
ADL AI, an intelligent video content analytics platform designed to capture and understand the context of infinite video data generated daily by your business. The platform enables enterprises to make better decisions in real time to drive business growth. Translating video content into actionable insights results in increased revenue, improved security, and enhanced privacy. Highly accurate models developed for ADL AI allow the platform to recognize faces, detect emotions, identify anomalies, and count individuals to enable businesses to extract insights for better data-driven decision-making in critical scenarios. As your business grows, ADL AI scales with you. Our software has no limits on the number of registered users, onboarded cameras, or notification alerts. Powered by open source technologies, sophisticated databases, and flexible cloud infrastructure, ADL AI supports the development of new businesses and industry-specific use cases to deliver fully managed analytics services. Automating your video surveillance enables visitor management and attendance monitoring. The system will notify security about the appearance of any person of interest and minimize the impact on the business from security risks. Some of ADL AI's key applications for crowd management include counting individuals, crowd control, and access authorization. ADL AI's powerful facial recognition feature can recognize your customers as they enter your premises, enabling a personalized customer experience. Our software can also analyze facial expressions to generate insights from the non-verbal feedback provided by customers to drive customer feedback and satisfaction. And finally, visual inspection at industrial plants to flag product anomalies for quality assurance and delivery are some of the most significant applications identified for ADL AI. ADL AI, intelligent, AI-driven video content analytics. All your computer visual applications via a single platform. Interested? Get in touch to find out more. Axiata Digital Labs, advancing digital life. Over the years, chatbots have evolved from merely automation tools to intelligent virtual agents that drive your business's bottom line and change your customer's entire experience. Meet ChitChaks, the chatbot. ChitChaks is a cloud-based intelligent bot that simulates human conversations through text and voice interactions. Omni-channel deployment of ChitChaks gives your customers access to ChitChaks on Telegram, Facebook, WhatsApp, Twitter, web, Android and iOS, and lets you increase the number of customer touchpoints. The chatbot supports rich messaging features, including the display of images, GIFs, and videos, along with various text options, including carousels, quick replies, buttons, cards, and menus. ChitChaks delivers top-in-class intent accuracy and query responses, leveraging natural language processing, which helps the bot fully understand the customer's intent and sentiment across multiple languages. Integration capabilities with internal databases enable businesses to personalize customer interactions and optimize customer experience. Powerful machine learning engine analyzes customer interactions to accurately anticipate agent escalation requirements. ChitChaks can generate automated and manually driven campaigns to improve your upselling and cross-selling techniques, which drives promotional content. ChitChaks features 360-degree real-time monitoring dashboards, handling ID management, session management, and more to meet your business KPIs. ChitChaks enables businesses to offer an elevated, automated customer service experience while personalizing customer interactions 24/7, enhancing operational efficiency and saving your business time and money. With ChitChaks, you gain more than just a chatbot. You get a multitasking, intelligent business representative that ensures the best service for your customers. Interested? Get in touch to find out more. Axiata Digital Labs, advancing digital life.
As data continues to change and drive businesses, the private information of individuals and companies continues to be at risk of exposure. Since 2004, data breaches have led to the loss of over 17 billion records, which have cost companies millions of dollars in damages. Do you know what sensitive data you store, where you store it, and who has access to it? Most organizations overlook the importance of securing their sensitive data. The challenges of knowing what type of data you have, where it is, and who's accessing it are made even more difficult by cloud and big data environments. We understand you value protecting your customers' data. However, the data collected can be monetized to your advantage while ensuring the privacy of your customers' data. Introducing Incognito, a data anonymization platform that cares about your sensitive data. Incognito helps you to discover, secure, and monitor personally identifiable information, sensitive customer data that is crucial to an organization's operational success. Whether your data is in the cloud or on premises, Incognito gives you the freedom to manage all your workflows from a central location. Many government organizations and industries have their own regulatory compliance when it comes to the protection of sensitive customer information, like HIPAA in healthcare, PCI DSS compliance in the banking and finance service industry, along with other governing bodies that enforce data standards. Violating these regulations can have serious consequences. Incognito consists of configurable, pre-built data classifiers which automatically detect sensitive data in your data assets. Incognito uses powerful algorithms to anonymize your data regardless of the format or size, enabling you to freely analyze and monetize this data while protecting your end users' privacy. At Axiata Digital Labs, we believe with the right data, you have the power to make a real impact. That's why we keep your data safe so you can focus on what you do best. Interested? Get in touch to find out more. Axiata Digital Labs, advancing digital life. Artificial intelligence and machine learning applications continue to blend with the core business processes of any industry. Yet, businesses around the world face many challenges when it comes to solving business problems with AI. This can be due to the lack of resources restricting the development of skills, time constraints, and cost of creating data-friendly architecture and AI use cases. ADL's AI Factory is a unified platform to answer all these business problems. The platform consists of an experiment bay, which features a data store allowing you to share and store organizational data securely. You can also find solutions for business use cases through the ready-made AI solution template. Train and test your models in your collaborative workspace. Optimize resource usage with monitoring features. Streamline the AI solution building process with AI ML pipelines, reducing the time to deploy models from months to minutes. Data drift and model drift monitoring further ensures the accuracy of consistency of the AI solutions. Get your own AI factory for rapid AI solution development without worrying about the underlying infrastructure. Gain an edge with AI. Stay ahead of your competition. The AI factory will lead the way for you to reduce the skill gap, time to market, and cost, allowing you to scale your ML and analytic work processes. Interested? Get in touch to find out more. Axiata Digital Labs, advancing digital life.
Ladies and gentlemen, what you witnessed were our very own products that were developed here at the lab. For more inquiries on our product portfolio, please reach us out via our website, axiatadigitallabs.com. Without taking more time, let's get back to our speakers. What do we have next, Pragesh?
Well, Redmi, up next we've got a very interesting session on preparing the data architecture for the Metaverse. It's my privilege to introduce our next keynote speaker, Anthony Burhan. Anthony Burhan is the Managing Director for Communications, Media and Entertainment at Cloudera. He is an industry-recognized innovator and an evangelist for the power of data and AI. Anthony was previously an executive industry leader at IBM and held leadership roles in telecommunications software companies in Europe and North America. Hi, Anthony. We warmly welcome you to our AI forum. Over to you to enlighten our viewers on the data architecture for Metaverse.
Well, good morning and thank you all very much. It's wonderful to be here. Wonderful to have the invitation to speak to you today. I'm going to try and say a few words about the Metaverse. First of all, I know you've been talking about the Metaverse over the last couple of days, and everybody's trying to learn more and more about what exactly it is and what the implications are for our industry and for the world more generally. And then I'm going to try and put a spin on it specifically around the telecommunications industry, what it means for our network and for our business. And then even more specifically, what it means for our data. Because clearly we're in an age now where data is powering our business, where data is essential for the models that we build to drive automation and so on. And so what are the kinds of data that we should be expecting, and what are the architectures that we need to support the data, the likely data sets that we're going to be getting? What are the guardrails going to look like, and so on and so forth. So let's get into it a little bit. So first of all, when we think about what the Metaverse is, it is something that kind of escapes definition in one sense. It's kind of a bucket of future information communications technology that we can put a lot of things into. When I was preparing for this, I was trying to think, well, okay, how can I capture the Metaverse in an image? And I found this wonderful little tool online, and I couldn't avoid putting it in here and just recommending it to all of you. The link is there, and I'm sure that the charts will be shared afterwards. But it's a web service called Hugging Face, where you can put in a unlimited text, whatever text you like, and it will, using artificial intelligence, create an image for you. And this is the image it came up with, and I love the image. I think on the one hand, it's a very beautiful image with a human at the center of it, or something that looks kind of human at the center of it, and a whole bunch of kind of organized chaos around it. And I think it's a fairly good metaphor for what the metaverse, what the metaverse is or could be. There's a lot of connections, there's a lot of devices, there's a lot of services, there's a lot of everything that goes into this. And it is a kind of a fusion of all of these technologies to hopefully drive better human experience. And at least that's what I read from the image. But you should try that little service. It's quite an inspirational little tool. It's you know, one of the things about these technologies is that they're already here. You know, I love this quote. I'm sure you've heard it before from William Gibson. He's written a lot of very prescient books. He's got a program on TV at the moment called The Peripheral, which is pretty good. You should go watch that if you can see it. But he said the future is here. It's just not evenly distributed. And what he meant by that was, look, you know, all of these technologies that we talk about, you know, they exist, you know, most of them. So if you think about flying cars, for example, you might say, well, that's future technology, doesn't exist. Well, you know, do a Google search on flying cars. You'll pretty quickly come up with a few different versions of it, and demos, and people getting into cars and then flying them away. And some of them look like drones and so on and so forth. But the point is that, you know, the technology is here. It's just, there's only one or two of them out there, and so it's not necessarily in your backyard, but it's in somebody's backyard somewhere. So and a lot of the ideas that go into the metaverse around, you know, artificial reality, virtual worlds and constructed environments, digitally constructed environments. You know, these ideas have been around for a long time in the world of fiction, if not in other places. So this little graphic, by the way, comes from a report from Arthur D. Little, which is really, really useful. And again, the link is there in the bottom right. A lot of these, many of you will have read some of these novels. If you haven't, you should go back and read some of them. You know, there's, you know, in the middle there, you can see Arnold Schwarzenegger from Total Recall. Again, a kind of a, you know, where you plug into a machine and you go on holiday in your brain. A lot of the ideas in that will really sort of help you to think through what the implications of some of these kinds of technologies are, because a lot of the time when we speak to companies, particularly who have an interest in the future of the metaverse, they're not really going to take you through all of the, you know, the potential side effects, and these novels tend to do that. That's what gives them the tension, I guess. So a bunch of stuff in there that you can get yourself into. So we've seen all of this stuff. These ideas are not new, but they're coming together. And what that also tells you is that this isn't really a story about technology. Certainly technology is important, but what this is really a story about is people and politics and commerce and trade, and, you know, how we work with each other and how the world functions. And so it's about how we can evolve our interactions with one another to be in some sense better. At least that should be the objective, and the metaverse hopefully can realize some of that. Fundamentally, though, we get down to it, you know, what really the core technologies in the metaverse are augmented reality, virtual reality. These technologies that obviously have been around for a long time, but that are maturing now quite significantly. We're starting to see them emerging as mainstream technologies. They're better distributed, if just take on William Gibson's phrasing. There's more of them around, and then the services and the software that are some of the things that are useful. You know, we think about things like virtual meetings. We're having a virtual meeting right now. This wouldn't have been possible, you know, 20, 30 years ago, certainly not at scale and the kind of scale that we're doing right now. But it's still a virtual meeting, very obviously. We're disconnected from one another. Many of us are sitting in our homes right now, and very obviously so. This kind of virtual reality can give us this immersive experience where, you know, we can see avatars of other people. They're very lifelike. They're not just like the sort of the Sims of or Second Life or something like that. They're you know, far better realized versions of ourselves than have previously been the case in virtual worlds. And we're sitting at a table and we can lean in and whisper to people about things and so on, like you could do at a normal meeting. That sort of experience is kind of what we're going after. Businesses like like real estate will clearly benefit. We already see on real estate websites a lot of sort of 3D videos of homes and properties that are up for sale, so that you can do a tour of the property from your living room. There's a more immersive experience becomes possible with VR. Shopping and commerce and so on is another one. Again, going back to the world of science fiction, if you've seen the Tom Cruise version of Minority Report, from, I think it was 2001, again, based on a Philip K. Dick short story from 1956, if I'm not mistaken. There's a sequence in that where the hero runs through a shopping mall and is accosted by a series of digital signage that that recognize him as a person, and that also recognize his vital signs. And he's running away from the cops, so he's sweaty and flushed and so on. And so one of them suggests that he could do with a Guinness right about now. And then he runs into a department store, and they recognize him, and so, you know, how are those tank tops working out for you and stuff like that? And sort of, you know, and this technology is very much in place right now. There are stores around the world that have, you know, mirrors that you can stand in front of in the physical store, and will place the clothes on you and make, so when you look into the mirror, you see yourself with those clothes on and things like that. So augmented reality in action there. And of course, the world of gaming. Gaming is at the vanguard of a lot of these technologies, and as is often the case, gaming is really enjoying a period where it has, you know, it's not just kind of a niche pastime as it has been in the past, and these gaming platforms are becoming useful not just for the games themselves, but also as platforms for expansive worlds and all kinds of applications. The word applications comes with so much baggage, it's difficult to use in this context, but all sorts of different things you can do in the context of a gaming engine. So gaming is another piece. And there's lots of others, right? But these are the sort of the things that sort of are to the fore, and, you know, with the technologies of AR and VR, these are the things that we're seeing. I want to just talk a little bit about Web 2.0 and the sort of the initial internet, because I think it's really important that we consider the implications of privacy when it comes to the next generation of internet and engagement technologies. The internet, Web 2.0 was substantially about ads and devices. And if we think about Web 1.0 as being kind of static web pages accessed on a browser on a computer, Web 2.0 became a much more dynamic environment, a lot more video, and with a wider range of devices and a wider range of services. And the two commercial models that drove that were the device sales themselves, but also advertising. And both, to an extent, were enjoyed something of a symbiosis. They were quite connected together. And the advertising business and Web 2.0 was wildly successful, so much more successful than Web 1.0, but primarily because of this slightly insidious advertising model, which traded identity for services. And so, you know, you look at those services on the left-hand side, you look at, you know, Google and LinkedIn and Bing and Google, Facebook. And there were social networking services and search services and email services and all that kind of stuff. They were really useful for people, but of course they were traded for identity information and so on. And that was then converted into ad dollars. And so that was the model. And there's been a significant pushback against that in the last few years, where we've seen privacy laws being advanced all over the world, not just in, you know, obviously in Europe, where I'm based, we have the General Data Protection Regulation, or GDPR, which is very important. It is evolving. The Digital Services Act just came it became law on the 16th of November, just a couple of days ago, and there are more coming down the line. There's the Data Act, there's the AI Act, and a few more in Europe. But Europe tends to lead the way on these things for various complex reasons. A lot of them to do with international politics and trade, but some of them to do with consumer protection as well, and a recognition that we're entering a new phase. And that's part of it. But that is a reflection of public concern with privacy and with protecting their own data. There was some work done a few years ago, and Shoshana Zuboff actually wrote a book called Surveillance Capitalism, and quoted some of this work around young people's attitudes to privacy and so on. And it's continuing to evolve, obviously. And there had been a suggestion that young people really didn't care about privacy, and that's why all of these things were thriving. And the research suggested that, contrary to that, what it was in fact the case was that they were very conscious of privacy and were just choosing to work around it. And so, the old joke back in the day was that, they weren't on Facebook because that's where their parents were. And, that continues to be the case, that there's a kind of an innovation in those younger people who, as they grow up and so on, they begin to learn more about privacy and managing their own environments and so on. So as we get this to work, so as we think about privacy in the context of the metaverse, and as we get beyond that whole Web 2.0 model, we're starting to see privacy being realized in things like Web 3. And Web 3 is a bunch, again, similar to the metaverse, and it's often used, it's often synonymous with the metaverse, and so Web 3 and the metaverse go together. Web 3 is a bunch of technologies that really advance the interests of privacy and security and control. It embraces the idea of distribution, and that's perhaps, we'll talk about that in the context of the metaverse next, but the idea of distribution is usually not something or distributed architecture is not necessarily something that is talked about a lot in the metaverse, but in Web 3.0 it certainly is. And the idea is that control will be distributed, that it will be broader based and so on, but also that this will be a very private environment, a very anonymous environment. Crypto plays a part in it, and the idea for you to control your own data, to control your own identity, to make sure that to control who has access to it and so on and so forth. It's not necessarily going to happen that way. I'm a little bit skeptical about it, and other people are too. But it is important to recognize that it does reflect the direction of travel. So, all of that managing of individual identity and all of that sort of stuff, it sounds like a lot of work, to be honest. And I'm not convinced that people are going to use all of these kinds of tools, even if they're available to them, and even if they're legally mandated to be available from service providers and so on and so forth. So I'm not sure how that's going to play out, but as I said, it is very reflective of the direction of travel. We are becoming more conscious of privacy, and when I say we, I mean everybody: suppliers, consumers, regulators, governments, and so on. Everyone is becoming more conscious of privacy, and we want to include more privacy and more control for consumers. And that's certainly the direction of travel. So thinking about the metaverse and what the technologies then that it is going to bring, we can draw the analogy between Web 1, Web 2, and the next generation that's coming. And if you look on the left-hand side here, we've got layers of opportunity, if you like, in Web 1.0, Web 2.0 that are analogous of what's coming in the metaverse. And so in the original internet, at the top, you've got web pages and apps, you've got smartphones and devices that run those web pages and apps, you've got platforms underneath that for gaming, retail, and other things. So think about Amazon.com, think about Steam as a gaming platform and so on. Operating systems underneath that. and then the cloud, the hardware, the infrastructure, the networks, and so on, all of that underneath that. And so for the metaverse, it's pretty much the same. It's slightly different implementations, but the same general categories. So you have this idea of an experience continuum, which is the space in which your applications, if you like, your metaverse applications get developed. Lots of interaction with and lots of services. It's a mashup of different things to allow core applications to be delivered. And we've got the human-machine interface, so we've got those headsets, we've got all these different technologies and so on. We'll talk more about that in a minute and how that's realized. And then we have this extended reality, or this idea of taking the events of reality, or the experience of reality, and extending that into the metaverse. So your shopping experience, your banking experience, whether that's a website type experience or whether it's a branch experience. And in many respects, the website and the app tries to reflect how humans would behave in an in-branch or in-store experience, but it's very limited by the human-computer interaction restrictions. Right, you're still typing on a keyboard. Generally speaking, there are some voice interfaces, but even those tend to be challenging. There's some chat interfaces, and again, they're very different. The metaverse begins to make it much more like that branch experience that we had pre-internet, or the in-store shopping experience. So that's a key part to that. And then the world engine, if you like, is that platform that the metaverse operates, the core metaverse that enables other services to be deployed, that can build those things in the higher layers, and then infrastructure is still infrastructure. So there are some uniquenesses to how the infrastructure is going to be consumed. We're still talking about silicon, we're still talking about compute storage and networking, but we're going to see different pressures brought to bear on it, and I'll talk a little bit about that, particularly as it applies to telco in a couple of slides' time. A key message that I want to just dwell on for a minute is that there isn't just one metaverse. If this is kind of like a multi-metaverse, if you like, the multiverse of metaverses. I'm not sure, I haven't got that phrasing right, but we'll figure something out. I think it's highly unlikely that Meta will own the metaverse. I think Meta clearly has been doing an outstanding job at investing in the metaverse and metaverse technologies. But in the same way as nobody owns the internet, nobody's going to own the metaverse, in my view. So once you accept that, you start to think, well, what can these metaverses look like? And so, you can have different DAOs in Web3 terminology, these distributed autonomous organizations that manage the environments. You could have a metaverse for children's content run by Disney. Perhaps it's just Disney content, perhaps Disney facilitated, and it is engaged with by other providers of children's content, not unlike a kind of a Netflix environment, for example, which is more for general video entertainment, but at the same time they bring in productions from other places and they just facilitate they have the platform, they have the environment. Similarly, for BMW, you might think, well, suppliers, customers, employees operating in the metaverse, even the mechanics network and things like that, collectors, all sorts of different members of the BMW ecosystem participating in that. Healthcare, again, major brands like Mayo Clinic, for example, might want to build a healthcare metaverse. And then for the service providers, I've got AT&T and of course Axiata Group, there are uniquenesses there. So AT&T is particularly American. Axiata has its Asian properties in 6 different countries in the telco sense, and operating in those environments can provide a B2B service that has a localized function that is, adopting localized compliance requirements, perhaps along the lines of some of those Web3 technologies that we talked about that are legal in the countries in which Axiata operates, and providing certain levels of assurance that compliance will be adhered to in those areas, and so that other brands and businesses operating in those countries can have a metaverse presence for those for customers in those countries. So there are potentially going to be different metaverses, and this aligns very well when we think about the telecommunications B2B strategies. We're increasingly, historically, telco B2B has been about, volume SIM cards delivered into large enterprises. Today, we're really seeing, in the era of 5G, and I don't just mean 5G technology itself, but I mean sort of advanced wireless technology and wireline technology indeed. Service providers are no longer saying to their enterprise customers, please connect your stuff to my network. Service providers are now saying, please build your applications on my platform. And that means much more than simply here's a bunch of SIM cards or connections that you can use. It means we've got these edge processes, these edge functions. It means we've got these data services that you can get access to. We've got these IoT products that you can use, and so on. We'll talk more about that shortly. So that's the context within which we're thinking about the metaverse. We're thinking, okay, if we've got these services, can we build them out for can we sort of construct a metaverse that contains these products or facilitates these products or is facilitated by these products? There's a connection to them. One thing to realize about the metaverse is that most of the apps are indoors, and that's really important. When we think about the telecommunications industry, apart from, there are a few applications, say, HUDs or heads-up displays in cars and things like that, they will require wireless access. But generally speaking, most of the applications are indoors. These ones that I talked about earlier, the real estate, the meetings, the gaming, the retail, and healthcare too. These are applications that are performed indoors, and so we're really talking about a number of different access technologies. I think a lot of them will be wired technologies. Even with the headsets. If any of you out there is into gaming and likes to play immersive video games, World of Warcraft, or I can't remember the other ones now, but these immersive first player games and so on. If any of you are serious about it and you get some kit at home, I'm sure you will say that you prefer the wired interactions than the wireless interactions, even just talking about Wi-Fi versus USB or whatever the connection happens to be. Because they're just more reliant, they're more resilient, they're more robust. Advanced wireless networks are very, very good now. But when it comes to those, fraction of a second type reactions and things like that, the wired connections are much better. So we've got to bear that in mind. Now you may still have, 5G, 6G backhaul or whatever, wide area wireless network backing off the data. But when it comes to the actual application indoors, it's going to be probably a wired connection. And so then when we consider the different components for the metaverse, and how the services are going to be delivered, you have all of these services on the left-hand side, and you've got your edge devices on the right-hand side, and this is just a very similar service delivery kind of structure. You've got your in-building router, your home router, whatever. You've got a base station or a cabinet. You've got the data center, and you've got your backhaul, your last mile, your cable, your Wi-Fi. And you've got to think about, how the metaverse services are going to be delivered. If you think about those services that we talked about already, and think about gaming and retail and healthcare and so on and so forth, we're going to have a lot of real-time bidirectional streaming. And that's going to put particular pressures on the network at different parts of the network. Not only that, but we'll have to have self-correcting mechanisms and self-healing mechanisms that we're developing a lot of right now in the context of virtualized network infrastructure. And this infrastructure that you see in front of you, some of it will be virtualized, some of it won't be. There needs to be some physical stuff in there, of course, but the point is that the software that manages it is going to be increasingly automated, and that's going to require a lot of data. So we have to think about how we run these applications and where we run these applications. If we've got real-time streaming and we've got a dependency on low latency service delivery, then we're going to have to be very, very agile in our response to network degradations or service degradations. So, you know, that's a really important piece for us. So thinking about it in this way can sort of help us to think from a network perspective. You know, let's divide it up and see where the potential failings. Do we need to run automated service assurance in the base station? Do we need to run automated service assurance even in the in-building router environment? So a lot of companies now have, a lot of service providers have edge analytics inside in routers that are useful for diagnostics and so on. Do we want to go one step further and actually have remedial diagnostics and actually start to fix things and can, you know, auto configure devices to respond to changes in the environment or the demands of metaverse service delivery? And then this is kind of the last slide on the metaverse piece before we actually get into the data piece. I just want to point you to the link on the bottom right. We did a webinar a few months back with an analyst called Dean Bubley, and I believe there was a representative of Axiata on the call actually. And Do in Dubai, and we talked about opportunity enterprise data in the 5G era, and edge is something that, you know, I mentioned it earlier, and it is something that is hugely important for advanced computing generally and the metaverse specifically. So, you know, again, like I mentioned there just a minute ago, you know, putting remedial analytics into the router is something, putting remedial analytics into the devices themselves, you know, is that something that's going to be possible? Certainly it's something that we'll need to think about if we want to have optimal service delivery. And so, but all of these different types of edges can be converted into quite active components of the network from a service assurance perspective. So they're already active in terms of networking and routing and so on, but can they become more active in terms of service assurance? That's a big challenge. So what does all this mean for data? And so I'm going to skip through the last few slides fairly quickly, but I want to sort of give you a picture of the data environment. And so first of all, we've done a little bit of a history of the internet and sort of how we've come to the metaverse. If we think about big data, you know, we started off in 2000 by putting IBM and Oracle software onto very expensive hardware. It was very slow, very, very expensive. And we evolved that so that the software began to be written specifically for the hardware. And so we found ourselves in a kind of an applications or an appliance standard. And that made things more efficient and faster and so on, but it was still very expensive and still relatively slow. Big things happened in 2010 or over the next 5 years or so, where we had significant, there's a number of different things happened. The open source community began to develop and deliver software that was production ready for very large enterprises at scale, and data design, data architecture technologies changed. We moved from structured relational databases into file-based systems and all sorts of other things. And also, very importantly, China's accession to the WTO in 2001 meant that storage and compute costs dropped dramatically over this period of time. And so suddenly we'd moved beyond the space in 2000, 2005, where we were were, may be able to do some management reporting, some compliance reporting, some regulatory reporting. Now we were starting to ask questions about behavior, and we could begin to model behavior. And so that meant, and that happened at the same time as the Internet 2.0 and ad tech and so on, as the advertising business began to take off. So it was a really exciting kind of a time. And that's when Cloudera was founded. Many of you will know Cloudera as one of the founders of Hadoop and the Apache open source ecosystem. And that's where our business came from. But our business has evolved very significantly, as I'm sure you're aware. And by 2015, you had a change again. So having skipped from relational appliances into open source, file-based solutions and so on, now we were looking at the public cloud and what the public cloud could actually deliver. And you had obviously Amazon, probably the leader at that stage, and then with Google and Microsoft coming along, and Cloudera was developing its own cloud technologies at that stage as well. And then if we fast forward to today, we've got cloud native solutions as companies like Snowflake, Databricks. Cloudera has its own cloud services and hybrid services and so on, and there are others. And lots of other tools besides, right? So advances in governance, visualization, AI reporting, and so on. The question is, where are we going to be in 2025 and beyond, and how are we going to support the metaverse? So if we think about this journey to cloud in particular, and I know this experience is a little bit different in different parts of the world. Telecommunications companies are looking at this and saying, okay, well, we should really shut down the data centers, move everything to public cloud, if it's possible within the jurisdiction. And so there are strategic partners that are sought. So it could be AWS, could be Microsoft, could be Google, could be a local partner. But the problem is that there are already partners in place. So we're already running applications on virtualized infrastructure in the data center. You've got customer data and the CRM team running something on Red Hat. There are different applications in different parts of the business running potentially on different clouds. So if someone goes off and buys a customer management system that's compliant or that's certified on Azure, but not on AWS, then that's, you've got to run it on Azure. And so you select Azure. Similarly for Google, for Amazon, for whatever the platform is that the application is certified on. So there are already partners that have decided to operate on specific environments. And we've got to take them with us. Different workloads, different infrastructures support different workloads. This is a really important point as well. We might have certain workloads that require GPU accelerated infrastructure. And so, we'll have that set up there. We may have certain workloads that need to be in jurisdiction, that need to stay in the country. And so we may have that, that'll be a specific data center type application. And then we have other infrastructures that support different kinds of applications. Like I was saying, certain applications commercial applications that you might buy might only be certified on one cloud or another, and you have to buy that capability. And different data sets have different demands as well. So you've got personally identifiable private information, that's important, healthcare data, federal or government data. They'll all have rules around how they're consumed and how they're processed. And so where we see this going and where we think that the infrastructure is necessary to support the metaverse is what we call an open hybrid modern data architecture. The metaverse is going to have so many different data sources from so many different service providers. Some of them are going to be public cloud. Some of them are going to be on-prem. Some of them, the metaverse in essence is a mashup of lots of different data sets. And in order to provide services, we're going to need to be able to manage all of those data sets. And so three key elements to this. There's the data fabric, the data lakehouse, and the data mesh. And they constitute a modern data architecture. So we've got to move away from this idea of saying, okay, we're going to have this big storage environment here. We're going to dump everything in there, and then we'll figure out what we're going to do with it. And that's kind of been the paradigm for the last 10 years or so. So we build this big data lake, and then we'll start building interfaces and integrations and so on. We really need to start thinking about, how our data platform extends to the edge, how our data platform supports AI and automation, These are key questions to being successful in the metaverse. And if we think about in today's terms, why these three things are important, the data fabric is important because your data is all over the place. These are the common complaints that we get. I don't know if I'm compliant. This is a question this is the challenge that we get a lot, because people are saying, it's not just that I'm not compliant or I am compliant, it's that I don't know whether I'm compliant because I can only see certain pieces of data. So your data fabric needs to work across all of your data sets. The data lakehouse is this idea that your platform is much more than simply a data warehouse or a data lake. Or a data warehouse and a data lake. It's much more than that. It's recognizing that your data platform needs to incorporate other data services, things like edge processing, things like data flow, things like AI. Those services need to be part of your data platform that is then exposed to the rest of the business. And then there's this idea of a data mesh, which recognizes that businesses need to treat data as a product. And so businesses all the time create new products, but they don't think of data as a product. They think of data as something that supports their business. And because it's that kind of a model, they're going to the CIO saying, I need this new data model, I need this new data set, and so on, and say, fine, join the queue. And that's a real problem. So in order for businesses to be successful, they need to treat data itself as a product. And that kind of approach leads to different kinds of architectures. So let's look at a quick example. So let's say we've got some data on some proprietary data on Ozone sitting on-prem. We've got some customer data on AWS. We've got some advertising data on Google. And we've got some machine data, some IoT stuff on IoT, on Azure. So if we have all of these pieces in place, they're not talking to each other. They're on different platforms. There could be some redundancy. But we need to, if we put in place a common data fabric, we can begin to unite all of those pieces. We don't necessarily move them, but what we do is we create a logical platform that connects all of them together. It means that we can begin to move workloads between different infrastructures. It means that we can access each of them. We don't even have the edge cloud here represented in the graphic, but that's another place where we can push applications capability into the edge. And then once we have that fabric in place, then we can think about, well, what sort of a feature set do we need to have available in each of these environments? And you start to think about, like I was saying, AI, machine learning, operations support, edge capabilities, and so on. So those kinds of capabilities will significantly enrich what's possible with the data in our business. So I want to leave you with this quote. It's not specifically about the universe, but it is talking about this future data ecosystem, and I think it's really important. We're going to see lots of clouds. We're going to see lots of environments, lots of infrastructure. We're going to have lots of capability in different places, and we need to manage them all. We need to treat them as a cohesive whole logically. This isn't a single platform physically, but it is a logical data platform that supports the business. We need to think about how we manage across these different environments, these different data sets with their different requirements and different restrictions and limitations, and pull them together. Otherwise, we'll be scrambling around, with different governance regimes and different compliance regimes and so on, and it'll become a far less efficient organization. So the metaverse brings forward enormous potential. The technologies in there, they're already there today, but they're coming together in a way that's going to be really, really interesting. And as a business, as an industry, we need to consider how the data from the metaverse can drive automation and new services. And that kind of a modern data architecture is going to be essential for that. So thank you all very much.
That was truly an amazing keynote speech, Anthony. Let's give our viewers some time to absorb what they have just learned. We will be back after this short break for the Q&A session.
Thank you.
PayPal has reached people where traditional financial institutions have not been able to reach. In the US, there are close to around 30 to 35 million users who don't have access to banking.
Not only do we want to power every transaction that happens around the world, but we also want to support millions of people around the world who are underserved by the current financial system. Payment just should be so convenient it becomes like air.
We needed a partner who has those capabilities globally and can help us and scale with us fast enough.
Google scored well across all of these criteria.
I feel they are my team.
Everything starts with the customer. No two people are similar. It changes how you think of a problem, what problems you solve, and how you solve those problems. We want the agility to make sure that we can deliver to our customers the features that they desire the moment we actually come to know of it. Every millisecond matters. I've never been more excited about what technology can do for businesses. Google Cloud is safe, secure.
Okay. Anthony, we have a question for you. How costly it is to get into Metaverse today for a business? Can tech startups convince investors for ROI today, or should they wait for another year?
Well, I think the answer is that it depends on what part of the Metaverse you're looking to get into. I think developing applications for the Metaverse is important. There is a question about when you're going to start generating revenue, and that's a little bit difficult. Don't just think of the Metaverse as one thing. Think about it as a sort of a sequence of technologies that are going to come to fruition over the next few years. And an exclusively Metaverse-driven or VR-driven application, for example, that's a little tricky. Try and have a sidecar business that sort of, if it's going to be in the banking area or if it's in the telco area or something like that, make sure that there's something that can be relevant sooner than the full realization of the Metaverse. So watch your timing and try and get to revenue as quickly as possible. That'll be my advice.
So Anthony, we have got one more question from the audience. Metaverse will need to handle a massive amount of data for AI and ML. Have thought about some advanced data compression or pattern serving techniques rather than sorting all the data?
Well, I did mention a couple of times that edge technology is going to be really important. And edge technology is not just about data collection and data processing, it's also about machine learning and sort of pushing machine learning to the edge so that you can you could basically have as much processing as close to the data as possible is going to be really important. And that's really what we're talking about when we talk about a modern data architecture. You need to distribute your data processing as widely as possible. Compute is going to be available much more broadly than has historically been the case. So we don't just have to bring all of our data into a central location and then start to run those workloads. So it's going to be a much more distributed environment in which we run our models.
Well, thank you, Anthony, for that insightful session on the data architecture for Metaverse.
You're more than welcome.
So Fritmi, let's look forward for some more views on this domain. Who is our next speaker?
Next, we are going to shed some light on the topic of nascent privacy risk of Metaverse. It's our pleasure to welcome Dr. Kanchana Tilakaratne as our next keynote speaker at AI Forum 2022. Dr. Tilakaratne's research interests include cybersecurity and data privacy. He has a strong track record working with industry, receiving many grants from organizations such as Data 61 CSIRO, Defense Science and Technology Organization, Office of National Intelligence, Google, and Facebook. His recent work in unraveling privacy risk associated with 3D point clouds and developing privacy-aware 3D data sharing in mixed reality and Metaverse is funded by Meta. Welcome to our AI Forum, Dr. Kanchana. Over to you.
All right, thanks for the kind introduction and welcome everyone for this session. And you're going to hear about a topic that you probably have not heard about so far. We had many talks, very interesting talks about Metaverse, but no, as far as I remember, none of them talk about privacy in the era of Metaverse. But we had a very good, keynote today about federated learning, which talk about some of the privacy aspects. So therefore, you are probably already familiar with some of the privacy concepts. So let's get on with it. And so far, we had many introduction to Metaverse, and then I'm not going to go through it again, but I'm not surprised if you have heard many different definitions for Metaverse, even within the summit yesterday and today, because it's a kind of big elephant, right? So, you can only describe what you can see. So originally, it was coined by this, the science fiction sort of a long time ago, but I still believe that he really, imagined the, true Metaverse. And today we have Metaverse in many different forms among us, but not in its full repertoire, right? So, and you already have heard many other words like, virtual reality, augmented reality, mixed reality, and then all together we call it extended reality. And so all these immersive technologies is going to be part of Metaverse. And then we also had many talks so far about, there are many different use cases. So it's appealing to many different industries, starting with gaming, and then telcos and healthcare, working from home, for example. My first, real Metaverse-like experience was, 2 years ago, when we were going to organize a conference, suddenly, there was, COVID restrictions, no one couldn't travel. And then we went to Mozilla hubs to organize their poster sessions in conference in more virtual mode, so which I kind of enjoy. But so although we see that this many, different use cases, are we really there yet? Like, can we really experience the true Metaverse right now? Probably not, right? So if we're really experiencing true Metaverse on its full repertoire, you and me would be wearing some sort of smart glass or a smart headwear right now, and we'll be experiencing that we'll be in the same room. But we do experience Metaverse in many different forms, right? But not in the form that we really imagine. It may take several years for us to experience that. And we see there are many different kind of devices on the market that provide certain aspects of Metaverse, some virtual reality devices, some like mixed reality devices like Microsoft HoloLens. And also we see in the market that there are low-cost enablers for Metaverse or mixed reality kind of services as well, so like Sandbox. So although there were like barriers for some time for the success of Metaverse, but we're kind of seeing, so things are improving. So there are billions of money is investing, but one barrier that we see it's not really moving forward is about data privacy. And if you look at the recent academic literature, as well as some of the discussions that are going on in industry, this has become a real concern among everyone, because now people are getting kind of teasers. This will be the likes of Metaverse. You will be enjoying these kind of services, if you with Metaverse. So then people start thinking, is it really safe? What's going to happen with my data? What kind of data that these devices can collect? So So then it has become a real concern in many different industries, and also with many different corporations who are working in realizing metaverse, like for example Microsoft, Google, and Meta. But is this a real concern? Over the years, if you go back like 10 years ago, or people talk about privacy, but people really don't care about privacy as well. So we had this kind of debate for a long period of time. So we talk about a lot, but we don't really act. So we observed in social media that we don't really take any action until there is something happens. Okay, once there is a big attack, or then we're going to come up with a plaster solution and then take care of that. So that's how we evolved up to right now. But things have, I think, changed over the years. Okay, and our community is now much more knowledgeable. So let's have a look at, okay, what really, privacy is in today's context. So in general, so it's the protection of personal information. So when you say personal information, traditionally it is things like your name and your address and then financial details, your health record. But nowadays, it's not just like these things, okay? Your photo library in your mobile phone, your IP address, your IDs of your device, like MAC addresses, okay? Your contact list, okay? And simply, installed applications in your phone, okay? So, for example, in many mobile devices these days, okay, so we all use mobile phones, right? And we have a permission structure within mobile operating systems. But for an application to access what are the other installed applications, you don't need any permission, for example. Okay, you don't need to ask user permission to access that. But just imagine that if someone have access to the apps that you have installed in your phone, okay, just the names of the applications. You can tell a lot about the person by just looking at the applications that you have installed in the application. Okay, so your personal interest can be revealed through that. Okay, your language, your gender can be revealed. So your ethnic background can be easily revealed from that. Okay, so whether you have a disability can be easily revealed through that. But we not really prepared in our society to understand that level of detail when it comes to privacy. But society is keep improving, okay, compared to few years back. For example, so one of these recent surveys done in Australia, so conducted by Australian Community Office of Information Privacy. So people tend to now understand that information like the financial information, biometric information are, they really revealed your personality, and they're really not willing to share them with other people. Okay, so now having an understanding on privacy, why metaverse privacy is a significant challenge. So the primary reason to that is the significant capabilities of metaverse enabling devices that we have today, and there will be much more sophisticated devices will come in the near future, and they can sense the user and they can sense the environment with many different ways. Okay, they got sense audio, video, they have multiple cameras, Okay, not just one camera. They can sense your 3D surroundings. They have temperatures. Some have retina scan, iris scanners. Okay, some even have brainwave monitoring. So there are a lot of sensors packed into these devices. Okay, that means a lot of personal data. So then, with these lot of personal data, and we have two other problems with Metaverse. We lack regulations. Okay, we are still in the phase of development of Metaverse. Okay, and also we have not really understood some of the risks so far. And then also we have extensive use of advanced artificial intelligence techniques and machine learning in delivering Metaverse services. So I'll come back and I'll explain how machine learning or artificial intelligence might be a significant problem to user privacy in Metaverse. So let me go and explain it explain to you in a kind of real example that's applicable to Metaverse. So in many Metaverse enabling services, okay, so you're going to wear head-mounted device, right? So these head-mounted devices can, sense your surroundings in very high details, okay? Especially, let's say, they can sense your environment in 3D form. Okay, but this information is required. For example, if there is a mixed reality service, right now I'm talking in front of my laptop, and okay, in Metaverse environment, you might have an empty desk, okay, but you probably have a virtual screen, okay, but that virtual screen needs to be anchored, into your desk. Okay, it needs to be looks clear, right? It needs to be properly anchored, not like floating on top of your desk and not like submerged into the desk. But to do that, these devices need a highly accurate 3D information of your surroundings. So when a Metaverse device captures such 3D information, so they looks like this. Okay, they were real data captured by us in our lab using a Microsoft HoloLens. So we went in different environments and captured different scenes. And what you can observe here is then what often happens is you're going to segment the scene to understand what kind of objects out there. So in this particular example, there is a wheelchair. Okay, so what happens if an MR device identified that there is a wheelchair at your house? Okay, so you just wanted to experience, a particular MR service. Okay, but the device can identify that there is a wheelchair nearby. So what the device can infer? Okay, device can directly infer that there is a disabled person living in this house. Okay, this is reason that there are no real regulations right now telling the operating system vendors or device manufacturers to, okay, no, you can't do that, okay, for example. And then there is with the recent development in machine learning technologies is inferring such thing. Okay, so object recognition is relatively simple. You can do it on your own device. You even don't need to send your data to a cloud service provider. So if that service provider is malicious, for example, what would happen next? So next, it's highly likely that you're going to get bombarded with, these kind of advertisement, for example. So that's one way of exploiting the information observed in your surroundings. But there are many other ways of exploiting that information as well. Okay, but that's just one example, right? So what are the other, challenges with respect to privacy and also security in Metaverse? So the whole heap of challenges, and Of course, we don't probably have time to go through all of these things today. But it's if you're really working towards developing metaverse enabling applications, you got to understand how do you properly treat the data that you collect from users. So this is one way of categorizing and identifying different different challenges and what kind of protection methods that you can apply for data that you collect. So this categorization was done mainly looking at the data flow from the user to the cloud service provider, and then the services will come back from the cloud service provider back to the user, right? So then there is the user needs to the device needs to capture the environment. Okay, so then there is a lot related to capturing the input, and then this captured data will certainly be first stored in the device, and then there are many data protection related techniques that you can apply in the device, and then from the device that you're going to generate outputs, or let's say different virtual avatars and other things. So then there are output protection related solutions out there, and then there are user interaction with virtual and the real environment, and then itself that like device protection. So there's a whole heap of different techniques that you can leverage. Okay, and you need to. But right now, so I just wanted to give you first some overview of some of the best practices that you can do, if you're developing privacy-aware applications for Metaverse. Okay, so first thing that we need to do is, if we don't need personal information, so then we're not going to take them. Okay, and then so there is this concept called privacy by design, which build on top of these 7 principles, but in a very high level, what it says is, let's take the privacy as a default thing from the beginning. Okay, not just let's not make it as an afterthought, as we have been experiencing, throughout developing like online services for like decades. Okay, but now we're in a society that people really care about privacy, and therefore when we are developing a new technology, right now, we're in the phase of building the metaverse, and we need to consider privacy from the get-go. And so if you consider privacy in every design decision that you take, you're going to end up with a better product than not. And then some other standard techniques that you can use is, you can make your privacy a competitive advantage. To do that, so this question that will people, would like to pay for privacy, for example, but we all buy curtains and blinds when we go for a new house, for example. That means people certainly happy to pay for their privacy when it comes to real world. Okay, but in Metaverse, people will certainly happy to pay for privacy as well. So there are many applications even right now with in social media and in our mobile environment that if they say, we're not going to collect any data, and then that means I need to pay, and then if it is not ad supported, then I need to pay. So there are community that are willing to pay for these kind of privacy-aware services. And so then there are these other standard techniques out there that you certainly can use when it comes to privacy, like anonymity. So it can provide location anonymity, you can provide data anonymity, and then there are other advanced privacy controls like perturbation of data, and so they can add noise to data. And we had a keynote on federated learning, so that's one form of providing privacy as well, but it's a distributed machine learning approach. But on top of that, you can combine that with techniques like differential privacy, and in our real world today, things like local differential privacy is already in use in different applications that we have. So it's not the time to go into these details, but what you need to be aware is there are advanced privacy controls that we really can take advantage of to develop applications in Metaverse. And then privacy always go hand in hand with regulations and policies. And there are many privacy protection regulations came out recently. For example, things like GDPR, very strong privacy legislation, and depending on your location and jurisdiction, so you will find certain applicable legislation to your country, and you always need to make sure that you follow these guidelines when you developed any kind of application. Another thing that we need to keep in mind when it comes to privacy is that users care who the data is revealed to. Okay, when you share certain information, for example, health-related data with your doctor, you don't care about privacy because it's essential that you know that you need to share that medical information with the doctor or the insurer. Okay, and when it comes to sharing certain things with your family, so that's a different story. Okay, so same goes with online services as well, and so this is again coming from that same survey, so that you can see at the bottom of the list what you have is apps and social media industry. So many metaverse related applications in future would would be categorized under these different applications or social media applications. So people are really reluctant to share data. So now I have given you kind of overall, generic techniques that we can use when we develop privacy-aware applications. But now let's take a step back and go back to the Metaverse, okay, and understand some of the specific privacy challenges related to Metaverse, and also see whether these the standard techniques that we have today, are they really enough, or do we need more a different kind of techniques when it comes to Metaverse? So let's go back to the same example. So what happens here is, okay, so the device is going to capture your 3D environment, and in the behind, this is what happens, right? So as a user, you probably don't see it, but these devices collect data. They build a data bank about different data that this device is collecting, and then in most cases that this device will need to share that data with third-party applications, for example, because all of these devices that we have today, most of these devices, some are kind of proprietary, but some are open platform devices. Like if you take an head-mounted device that run, for example, Android. So then many application developers can develop application on top of it. And that means the data is collected in this device is going to be shared with these different application developers. And then some of these developers, for example, can be adversaries or malicious. Okay, so what would happen then is, they collect this data and then they can infer many different things about the user. Okay, and sometimes it's looking at spatial data. So then you can infer the layout of the space. So right now we're probably not really concerned about it. because we are not really using MR capable devices in our day-to-day life. But just imagine that you're wearing smart glass and then you walk around your home, and because you're continuously engaging with the glass, and then at the end, someone else can completely recreate your house in a remote location. Okay, is it something that you expected? Is it something that you want? Okay, so that's, is the debate here. Okay, how do we prevent that? Okay, and on the other hand, so in order to engage with the environment and then provide a better service, so you need to reveal many other personal information to these service providers. So we did an experiment with simply looking at spatial data. So looking at 3D point cloud data collected by these devices. And then we did an experiment of, can we re-identify the space, okay, with high accuracy? And it's quite easy. And then it turned out to be at the end, when the user doesn't have location privacy if they start using MR capable devices, for example. So when it comes to location, we all think about, I need to switch off my GPS, for example, right? But when it comes to head-mounted device, so turning off the GPS will not protect your location. So in fact, it's even worse than a GPS, because the GPS would be able to tell you whether you're at office or whether you're at home. But when it comes to location fingerprinting using 3D information, we can also tell that you're at home, but you're at the kitchen, or you're at the living room, or you're at the bedroom. Okay, and then obviously what we do is, we go back to remember our standard techniques like, we can anonymize it, or can we perturb the data? Can we add noise on top of that? Or we release, only certain amount of data. Those are the kind of standard techniques that we know when it comes to controlling privacy. Okay, and so what we observed is this basic generalization kind of technique is not really going to solve the problem. Okay, because our machine learning techniques these days is so advanced that, even if you, for example, sanitize your environment, you're going to add noise, okay, into your 3D point cloud data. And even the noisy environment can be still pre-identified with the modern classification engines. And so there is a point that the machine learning model failed to identify that, I don't know this particular space, I can't really localize the user. But then the input is also almost like useless. Okay, so in a privacy domain, what we call is, then the utility is almost like zero. So there is always privacy utility trade-off when it comes to privacy-aware techniques. And so what we have observed, the basic techniques is not going to work in Metaverse. So then with that in mind, sir, I'm going to share some of the work that we are currently doing with Meta at the University of Sydney. So what we want is, we want to bring the notion and control, notion of user control into the Metaverse. So when it comes to, even right now in social media, there are a whole heap of privacy controls, okay, provided by all the platforms. Okay, user feel that you have the option to, okay, I'm going to share this picture with my friends and maybe another picture with friends and friends. Okay, and also you have the option to pick what information that you're going to make public, what information that you're going to make private. But when it comes to current metaverse enabling devices, okay, for example, scanning your environment, so there is no such control. But certain applications probably don't need this much accurate data. It depends on the actual functionality of the application and also users' context as well. So take this example. So there is a wooden chair in your home, maybe your ancestry wooden chair, which is a quite unique one, right? So if the MR capable device can have an accurate 3D fingerprint of that wooden chair, it's going to be very easy for the device to re-identify your space, for example. And also you are really concerned that I don't want to reveal that chair. Okay. For example, if there is an adversary, by revealing an accurate information of certain object, so the adversary can infer many different things. For example, if you have a Harman Miller chair, okay, if the adversary can infer the brand, and adversary can then infer the cost, okay, then adversary can put you into a bucket, for example, people who buy this kind of chair probably have this much salary, for example, and looking at the sales and others, you can even localize to some extent. So you can put certain tags for the user depending on what you can infer from an object. So then as a user, let's say you have a kind of dial in an metaverse environment of, I don't want this object to be released. Okay, I need very high privacy for that particular object. Just imagine that you go to your room and then you scan the environment. So then it will tell you, okay, these are the identified object. You click that, and then there may be a privacy dial in your and slider, which we call like a privilege slider, and then you control, oh, this is what I want. And then what we're going to do, the challenge is, so you need to release certain level of information back to the developer, but you can't, you also need to preserve certain amount of geometric information such that the MR service can function properly. And in general, so the idea would be like this. So then let's say you have this unique environment, and then maybe with the user's input, or you might be transported into quite a generic environment. So like you have this unique chair and a table, but you have a standard office chair and a table, but they all both with similar dimensions, for example. So that allows the device to interact with the real environment properly, but it does not reveal the uniqueness of your environment. So that's kind of the direction that we want to go with this kind of research right now, what we are doing. And some of the things that we have done so far is we studied different privacy preserving transformations, okay, to do that kind of transformation. So sometimes it comes down to generalizing the 3D space into, for example, planes, okay? And then the planes can be generated with many different techniques. And then sometimes it comes down to conservative release of different environments. Okay, if the device wants to anchor a virtual pet on top of my table, and then the device will only get access to accurate information only around that particular area, but then you also have this kind of privileged area. Then when you go beyond that particular anchor point, the information that the third-party application going to get will be much lower than the anchor point, for example. And we always keep track of privacy utility trade-off. right? So if you otherwise, whatever the privacy techniques that we are going to develop is not going to be useful. So that's one of the important things that we need to remember. And so then also we kind of work out a method that can we really early detect it, because it's really difficult as a user to determine should I make this particular environment private or not? Okay, for example, if you have we often as users we feel that the bedroom is more private environment than external. But when it comes to adversarial inference, so if you look at the objects in your kitchen might reveal more information about you compared to the objects that you can see in the bedroom. So with that, so we have identified that even users will struggle to control their privacy. So then, so device should, in a way, should be able to assess that this environment is going to be very easily re-identifiable, and are there enough uniqueness in this particular object, for example. So we studied different scans of different kind of objects. Some are computer generated virtual objects that we're going to use in Metaverse, and some are real objects that we captured through Metaverse capable devices like Microsoft HoloLens and some even with mobile phones. Today we have LiDAR scanners that are capable of capturing 3D information in many modern smartphones as well. And so what we observed is, we can develop metrics to early detect whether a certain environment is going to leak, how much information, and then give an indication back to the user. We suggest that you should provide, or you should set this level of privacy for a particular environment, for example. So with that, I want to, remind you that there are many other challenges when it comes to private and safe metaverse. So we only touch based on kind of potential work in progress solution for input protection, but there are many other things that we need to work on in the future. And then it comes down to policy regulations and standards. There are standards currently in development related to Metaverse, like ISO standard and IEEE standard as well. And then we need many privacy enhancing technologies. Some are specific to Metaverse, for example, the one that I described earlier. And then we also need to work on user awareness. And finally, I want to leave you with this thought. Okay, so I know that most of you who are listening to this talk, you all have some role to play in future building Metaverse. Okay, so let's not make the same mistakes that we did in the past with online services. For example, when developing social media, very at the beginning, we had zero privacy concerns, and then always it was like an afterthought. But the world has changed now, and we need to develop Metaverse with privacy by design mindset. Okay, and then we will end up with a better environment, and then also our users will accept Metaverse much better if we develop a privacy aware and safe Metaverse for everyone. All right, so that's all from me today, but I'm very happy to take any questions that you may have.
Questions already lined up. We will get back to the Q&A session for you after this short break.
Audio is a really powerful medium because it's so personal and engaged to who you are.
It is the most intimate and the most connecting medium. And what we're seeing today is that there's this new technological revolution taking place, and that opens up a whole new interest and explosion of audio.
Spotify is definitely more than just a music company these days. Recently, we expanded very substantially into podcasts.
I'm Alex Bloomberg, and this is Without Fail.
Our mission at Spotify is to connect 1 million creators with 1 billion fans. So that's very exciting. It's also a huge challenge.
The problem is bigger than just the number of fans that we have. It's also the amount of content that we have.
We have a huge catalog, 130 million audio files. The scale is growing so fast. At peak, we're seeing 8 million events per second, 500 billion events per day.
Data is basically the core of running our business, and if we're not able to get the latest insights about our users, we're not able to see the key statistics about our business, that's a problem.
We were reaching the sort of tipping point where the current system wouldn't scale anymore.
And that's where Google Cloud comes in. Google Cloud takes care of a lot of the complexity of our business.
We don't need to worry about the infrastructure. We don't need to worry about all the details that aren't core to our product. It's intuitive and it makes scaling effortless.
And that frees us up to do Spotify-specific things. Being creative, being innovative, experiment faster, and get results way faster.
Google understands engineering culture, and they've really brought that to the cloud platform.
It's been a massive improvement in our ability to make our employees at Spotify more productive.
In addition, I think one of the most powerful parts of our partnership has been our engineers and Google engineers sitting together in the same room to solve some of our most difficult problems.
Because they're able to access petabytes worth of data at their fingertips very simply.
Moving to Google Cloud and their platform really freed us up to accelerate our development, and we kind of skyrocketed.
It basically unlocked infinite capacity.
Building the audio network of the future, it takes that intimate connection really to the next level, and that we believe will help us lock additional innovation in the audio space.
We have a very strong belief that we can, together with Google, build the best cloud for us.
So Dr. Kanchana, I'm going to give you the first question from the audience. What sort of challenges we may face in the metaverse with respect to privacy and security? Will AI help to sort these issues?
For example, because the devices that we're going to use for metaverse, they have advanced capabilities to send user as well as user surrounding. So with that, there can be many privacy challenges. So some of the challenges that we went through during the talk, like location re-identification, okay, tracking the user, and then inferring the user interest. So these are the challenges. And so AI is a double-edged sword when it comes to privacy and security. And in this case, so when we have advanced machine learning and AI capability, it's not good for the privacy, for example, because user might be sharing his accelerometer data, okay, but with an advanced AI technique, machine learning model can infer something else from the accelerometer data. For example, users' handedness, okay? So, and then user behavior by just looking at accelerometer data. So, but AI can always use for the good as well. For example, when it comes to security, we can certainly take advantage of AI. But, so therefore, AI can be used for both. Okay, it can also help develop better techniques in terms of protecting, but it can also be used by adversaries to, more sophisticated attacks.
So, Dr. Kanchana, we got one more question from the audience. What might be the possible metaverse cybersecurity challenges regarding user-to-user communications and data accuracy? Are regulators ready for this metaverse?
So I guess the question is more user-to-user communication. So security in general is ready for metaverse, but what's we're not yet ready is the adversarial attacks that may come in metaverse. For example, different malicious behaviors, fake misinformation. When it comes to metaverse, we have no idea yet. Okay, so therefore we certainly have some techniques that we can use from other domains and reapply when it comes to metaverse. For example, when it comes to security, so there was another question as well. So okay, so you can secure the user trajectory by proper encryption and proper data protection techniques, but it's hard to prevent someone else learning about user trajectory by looking at certain other information. So there are, again, the question is, there are many challenges. Okay? We are very at the beginning of addressing these challenges. But if we start looking at privacy and security from the get-go, so I'm confident that with the knowledge that we have as a community today, we'll be able to develop the private and safe metaverse in the future.
So we have another questions.
Mm-hmm.
Like virus guards for personal computers, shouldn't we have software applications where users can install in end-user devices to make sure personal information will not be shared to service providers?
So that's a good question. So that's at the end right now are responsible of the operating system vendor, for example. So right now, you have access permission control system developed by operating system vendors with all devices. So that's quite similar to virus guard, so which in a way that it protects the third-party developers accessing the raw information. So they can only access it through the approved APIs for that particular device. So that in itself acts as a protection layer. But when it comes to metaverse, the challenge is the current access permission structure that we have is too generic. So let's say right now you can give permission to the camera or not. But when it comes to modern cameras, camera can do 100 different things. So with access to the camera, one can also identify objects. One can also sense the movement because you can capture images with high frame rate. But that's not something that the user wanted, but user doesn't have that level of control. So certainly the access permission methods that we have needs to be further improved when it comes to metaverse-like devices. But the virus guard-like software can, it will protect user when it comes to security. But when it comes to privacy, I think a lot depends on the operating system vendor and developing better access control mechanisms.
Thank you very much, Dr. Kanchana, for sharing your profound knowledge with us. So,
thank you. You're welcome.
Thank you once again. So isn't it wonderful, Pragesh, because we rarely get this kind of opportunity to listen to great knowledgeable speakers and industry experts, especially in AI domain.
Of course, Ridhmi, and we are not done yet. Next is our panel discussion on virtual Homo sapiens, where will the human race end up with the metaverse. Let us introduce our distinguished panelists, starting with Anthony Berhan and Dr. Kanchana Tilakaratne, who you have already had the privilege of listening to as part of our keynote speeches.
Joining them, Shiv Malik, who is the author of 2 books, the co-founder of the Intergenerational Foundation think tank, an award-nominated broadcaster, and a former investigative journalist for The Guardian. After 4 years advising the Web3 projects Golem and Streamer and co-creating a revolutionary framework for monetizing personal data, he co-founded Pool in 2021 and currently leads the project on its mission to bring data unions to the world and ensure people have control of their data and a genuine stake in the digital economy.
We also have Sherry Ang, who is the country director of Google Cloud's business in Singapore and Malaysia. She is responsible for leading revenue and go-to-market strategy and operations for Google Cloud, and working with teams across Google to help customers in all industries reimagine their business through data-powered innovation.
Let me have the privilege to invite Professor Paul to guide and moderate today's panel discussion. He is not a new face for us in ADL, as well as the viewers who joined our very first AI forum last year in 2021. So global technology entrepreneur, ambassador at TM Forum, AI Big Data Analytics, CX, Smart Cities, and innovation, none other than Professor Paul Morrissey. He's passionate about education and seeks to enable people of all ages through the delivery of free lectures and short courses at many multi-territory universities and open forums. He's a globally renowned figure in the world of telecommunications and media. Let me warmly welcome Professor Paul and our dear panelists to start the panel discussion of the AI Forum 2022 Day 2. Professor Paul, over to you.
Thank you very, very much. Can everybody hear me? Just put your fingers up. Oh, great. Okay, I'm very, very proud to be able to host this session today. And the exam question that we have is, you know, how do Homo sapiens and the human race, and where do we end up in the metaverse? Well, let's move back a little before we move forward. The metaverse is just really another incarnation of how humans interact with each other when they're not face to face. So we could say, you know, telephony was the first incarnation of the metaverse. We've all been in an incarnation of the metaverse in the last couple of years. We're virtually talking to each other. Great example of where we are now. But then let's think about what happens when we move into the future. Where does it go from there? Let's start giving ourselves some intellectual challenges about, you know, how do we then talk to each other? How do we interact with each other? So let's look forward. Oh, tell you what, let's not look forward. It's not just about looking. It's about feeling. It's about tasting. It's about smell. The metaverse enables us to look at all those senses in a different domain. So let's just think about where we end up before we decide where we've come from. This immersive technology is where we really want to make ourselves known and where we are. So there's a few things that will drive the metaverse. Data, of course, is one. Infrastructure is another. But bringing that technology all together, do we go to a place where Ray Kurzweil calls the singularity, where our technology actually is outstripping and out understanding us as a human race? So that could be dystopian or utopian. We have to put some rules around that before we start thinking about where we're going next. But it is interesting to think about. So where are we today? I've gone historical and I've gone future. Where are we today? Currently, most popular shared platforms, which we call metaversal, are games, and they're largely based on Web 2 infrastructure. They're centralized and generally are not interoperable. You can think about Fortnite, Minecraft, games like that, where actually there are 100 million daily users using those games. So gaming is probably ahead of us. But in the shared world of platforms, where people can be looking at interoperability, things like Second Life and Altspace, there's around 40 million monthly users. So they're way behind in adoption, but there's no doubt that they're going to start catching up if we give them the environment, and a safe environment, as the doctors just talked about, to actually exist in. Facebook have rebranded as Meta, we all know that. And that is just one giant tech company that is putting billions of dollars into the future that we've just tried to describe. So when we move to Web3 platforms, the metaverse actually takes on, in my opinion, a new type of interaction. We start looking at people in different ways. We're looking at tokenization. We're looking at interaction and interplay. And these are things which we're only just touching the edges of. They'll become more mainstream and accessible over the next couple of years, and they will have no doubt massive benefits. We won't all be wearing goggles. As I said, we'll be actually immersed in this environment. Remote surgery, for instance. I mean, just take that as one example, where you are in a different place and controlling a robot to actually interact with an operation. That puts a whole new spin on network operations and the responsibility of network operations and the ethical responsibility of network operations. What do? Do you give bandwidth to that operation, or do you give it to a financial transaction? These ethical decisions are huge in our environment. We'll talk a little bit about that later. So the exam question of where will humans end up in the metaverse, I think we could go on for 5 hours. We've only got an hour and 15 minutes. So let's contain ourselves and let's see what we can talk about. But today's panelists are going to talk about that landscape and try and give it a bit more clarity. And we're going to look at, what's the role of the humans in there? How do different industries use the metaverse? It's not just about gaming. What are the risks and opportunities? Doctors talked a little bit about the cyber attacks, the adversarial attacks. What happens when we have quantum computing coming into this environment? Do we have quantum security? That's a whole new topic. So here to talk about that, we have our 4 distinguished panelists. I'm looking forward to this as a debate, a discussion, an interaction. And I'm going to hand it over now to our panelists to introduce themselves. So first of all, I'm going to introduce Anthony. Anthony, could you just give us a little bit of background about yourself and what you're going to talk to us about today?
Certainly, Paul. Pleasure to be here with you all this morning, and really looking forward to a fascinating discussion and great introductory comments, Paul. It really sets the tone. I obviously spoke a little bit earlier today, so people have seen me already, but just a couple more words about, where I come from. So, I've been 25 years in telecom, and most of that have been in data and AI. Apart from that, I do have a legal background, and so I've done a lot of work in privacy in particular. And so that's obviously something that Kanchana was talking about earlier. Very, very interesting presentation there as well. That's going to be really, really important. I've also done some academic research on, I finished an MSc there a few years ago on the politics of technology. And one of the initial comments that I made in my presentation was that all of this technology isn't new, along the lines of what you said there. Really, this is a human story, and it's about how we behave with the technologies that we have and how we evolve our interactions and our communications. with one another, and that fascinates me. So when I talk about politics, it's not about sort of left versus right or political parties and all that sort of stuff. That's not what I mean when I say the politics of technology. I mean, it's about how humans organize themselves to take advantage of the technologies that we have and to make life better. To help fix the problems that we have, whether that's, inequality or climate change or, these different challenges that we face. Can we evolve as a species with the technologies that we have developed to become, in some sense, better and leave the place in a better state than we found it for our children and the next generation. So that's very important to me. So so background in telco and data and AI. So that's what I get paid for, and then in my private life, I think about those other things and how we might make them better.
Thank you, Anthony. I wish I got paid, but anyway, we'll move on. I'd like to introduce Shriv next. Shriv, could you give us a little background, painting of yourself, and we'll move forward from there. Great to have you on, by the way.
Hey, hi, Paul. Good to see you again. So I am Shiv Malik. I'm the CEO of Pool Data. What we do, very briefly, is we work in the sort of zero-party data space, which is essentially about getting people to positively opt in to monetizing, sharing their data, and building out the infrastructure necessary for that. In particular, in regards to this sort of conversation, what we're doing is building out a digital backpack, if you want. It's a data wallet, so it allows you to both pay and store your data. Of course, that data has to come from somewhere, and has to, if it wants to be read at scale, it has to be well governed, well structured. So those are the issues that we're kind of working with lots of other partners, these institutions called data unions, who are cropping up at the moment and helping people to actually structure that data and monetize it and share it. I'd like to take that question really and make it a bit more normative in a sense. And, where do we want to end up, if you want, with the metaverse? And will we kind of ever get there? So I would like to see a decentralized metaverse in many senses, where, it isn't just controlled by a couple of big players. And I mean that both in the infrastructure sense and the kind of consumer front ends. Both of those things are deeply important. But having worked in the smart city space for a year or two, you can see just how difficult it is to really deliver on those visions unless you've got those basic primitives in place. One of them is obviously how people bring data to the metaverse, because without data, how are you ultimately going to be known? How are you going to actually have services provided to you unless that data is delivered, if what we call sort of first party? So, it's sort of Google and Facebook saying, right, we have all this consumer data on people, we'll share it with various partners to ensure those services. I mean, sure, Sherry will like to have a response to that. Or you could do it another way where people bring their own data that they're storing and that they permission into the metaverse. That's the vision I think I'd like to see, perhaps many of the other panelists as well. So that's one of the primitives. And there are a few others. How do things get rendered in a decentralized way? That's probably very, very difficult. How is the rest of the cloud computing delivered in a sort of decentralized way? That might be very difficult. That hope that we can end up with, as sort of Anthony said, that kind of better future and technology delivering a better product. That I might be a bit pessimistic about at the moment.
Mute, Paul.
Sorry, thank you, Shiv. I'm on mute. That's a really interesting environment you're describing there. And I think Web3 is going to bring us into that very quickly. So it's, if we look at the last generations and how things have changed from, Web 1 to Web 2, Web3, I think, is coming all over us. And we need to start thinking about that and get regulation involved in it. So Sherry, do you want to give us a little bit of thought around yourself and what you're playing in this environment?
Thanks, Paul.
So I believe we're standing on a really, really exciting times. Our whole industry is on the cusp of a very major shift. Currently, I lead Google Cloud in Singapore and Malaysia. And in that capacity, I really have that privilege of working with government institutions, private organizations in accelerating digital transformation, and really get to see, firsthand innovation at its best, organization orchestrating ourselves in solving some of the biggest societal challenge, and also addressing some of the promises that we're going to talk about today at Metaverse conversation. From my perspective, I've spent about 25 years in tech MNCs, started my journey with telco, and just as Shiv and Anthony has said, it's really an evolution of human interactions with technology. I started, putting wireless network in 2G, 3G space across Asia. And it's very, very exciting to see this new space emerging. For me, I look at the future with this lens that it's going to be a very exciting tech-enabled world where 3Ds are going to play a very, very key role. One is digital, and in the arena of digital, we are seeing the breaking down of boundaries of that was put in place in the past by geographies or industry boundaries. So digital is going to create a very big shift, and we're seeing that in the metaverse, for example. I think a lot of the speaker talks about data and AI. The role of machine learning is going to increase with the capacity, the volume and variety of data that are coming as we interact in the digital space. And I really like what Shiv said, it's going to be a world of democratized environment, of a decentralized view. We also at Google interact with a lot of startups, that are building on various types of innovation. And recently, Google published, along with Bain, as well as Temasek, a e-economy report. And as much as we are seeing the onslaught of geopolitical, economic, macroeconomic conditions, we're still seeing a lot of promise where venture capitalists are willing to put money and funding behind the whole arena of Web3. And Paul, you rightly said that in your introduction, we're going to see a lot that is going to be evolved in terms of investment into Web3, driving the innovation that is going to allow and lay a strong foundation and infrastructure for people to build innovations. And the Web3 infrastructure is going to be very different. It's a primarily blockchain-driven arena. And at Google, we're really excited to be focused on how can we help, be a catalyst in creating that digital infrastructure, in also empowering the Web3 developer so that we can see more creativity, more solutions that are brought forward for this new promise.
Well, thank you very much. We're very excited by that, and thank you for joining us today. Okay, finally on our panel, we have Kanchanjunga, and we just heard your discussion, Doctor, but could you just give us a little bit of an elaboration of where you think all the security, privacy is really going to end up in the universe? It underpins everything we've got in the metaverse, in my opinion. So, as I said before, quantum security is something which baffles me. It's in my mind all the time now. Looking at a few startups in California actually working on it now. So, could you just give us a view of yourself of where security is going to go in the metaverse and what your thoughts are?
Yeah, sir, it's an honor to be in this panel, and Paul, sir, I've been working on, privacy and security for some time. And then I remember, let's say 10 years ago, I was trying to build a decentralized social network, for example. So going down the path of Shiv earlier mentioned that, okay, we want to decentralize everything. But at that time, there were couple of startups as well. Myself tried to build a startup around that, had an application that can they directly share content with other users, directly to the other user's phone without any central storage. And there are many startups were trying to do the same thing, but it never really materialized. Okay, so at the end, so still the big tech companies, managed to keep their control over social networking domain. But I still believe, and most of my work as well is that, okay, we need to bring the power of computation from this central node to close to the user as much as we can, when very close down to the end user device. So because of this, sometimes it could be financial constraints that, okay, everyone develop these applications to earn money and to develop business around that. So therefore, if we, let's say, I still feel that achieving full decentralization will be a big challenge. Okay, but then one of the alternative that we can do is to bring the control closer to the end user device and provide the control, as much as control, back to the end user. So maybe it's a centralized service, but the amount of data that goes out from the user's control, user's environment, user's protected area is going to be very minimal. So, so I would like, in future metaverse development to be, adapt to that kind of strategy. Okay, so right now it's quite open, and when it comes to privacy and security, we have not thought about what to do, because many startups and tech companies are still scrambling with making it work. And so then privacy and security has proven to be an afterthought in the industry. But what I was saying even in the keynote before is as well, so we can't go on and on like that. So we need to bring that into the picture from the get-go. And so right now, I think we all need to wake up and then start thinking about security and privacy in metaverse domain. And we, for example, what Paul mentioned about quantum crypto, for example, many modern day encryption methods might not be, useful. They're kind of breakable when it comes to, quantum computing. But there are, other academics and researchers and other organizations working on quantum safe like for security technologies, for example, quantum safe cryptographic algorithms, for example. Those things, they're kind of horizontally applicable across all different domains, not just metaverse, but it will be essential for all other domains as well. And there will be such technologies that we certainly need to adapt throughout the internet. But when we also need certain technologies specific to metaverse. Okay? So that's what we got to start thinking about, because there could be certain security challenges, adversarial attacks that are unique to metaverse that we have not yet seen or not have experienced. Okay, some of these things, okay, right now it's hard to imagine as well. Okay, but we have different forms of metaverse with us today. Okay, with like augmented reality and mixed reality forms. So I think we need to, leverage what we have right now and further investigate what could be the challenges, security challenges in the future. Yeah.
Great. Thank you very much, Doctor. That was a real insightful view of where we are with this. I'm particularly interested in quantum security. I think it's an area which is amazing. We all tend to think of the metaverse as something we can play around in, but there is an industrial metaverse as well. What that plays in, the space that plays in. We're not looking through goggles. We're actually seeing these things in front of us when we're decoupling something like an engine, and somebody is working on it, and they've got a holograph of the engine next door. I'm not going to pinch your thunder here, Anthony. So I'd like Anthony to talk a little bit about the industrial metaverse rather than everything we think about, which is the playful metaverse. Over to you, Anthony. You're on mute.
Yeah, the perennial challenge of our age. The industrial metaverse is a phenomenal thing. I just want to, before I go into that, I just want to respond to just some of the things that the other panelists said just about decentralization. Absolutely. A couple of times. I think the idea of decentralization is intrinsically attractive to all of us. As human beings, as individuals, we want our own autonomy, we want our own freedom and so on, but our experience has been a little different. And, if I can take just two examples, just first of all from the energy industry, and our decisions on, say, nuclear power versus solar power as sort of centralized and distributed power structures. That nuclear power is obviously something that's very highly intensive and a strong, heavy engineering type exercise, requires extraordinary amounts of capital and government support, whereas solar is entirely the opposite in all of those categories. And we have chosen nuclear over solar historically. We're trying to reverse that now, and it's challenging to sort of get away from that. In the internet itself, then of course, if you go back to the origins of the internet, if you go back to the Whole Earth Catalog and the Well in sort of the 60s in California and how all of that began, there was a real ethos of, I guess, libertarianism. It was certainly, individual autonomy and freedom and so on that sort of was trying to drive a highly distributed resource structure as computing came of age, as it were. And over time, that developed into a phenomenal and a wonderful a creative experience around in the 1990s in particular. But of course, we've ended up with a very centralized internet in that, for many people in the world, Facebook is the internet, period, or Google, Sherry, is the internet. There are one or two or three major islands in the internet, and that is the extent of our internet. So it's become a very centralized thing. And as we move into the metaverse, I can't really see a change happening that would facilitate that kind of innovation that says we're going to go back to a decentralized space. And hence my comments earlier on in my presentation when talking about Web3, that I was a little bit skeptical about whether that kind of autonomy could be realized given where we are in the current moment globally. So anyway, that's my just 2 cents on decentralization. But to go back to your question, Paul, on the industrial internet, 100%. Again, as I mentioned in my presentation, I think we're going to see many metaverses. We're going to see industrially focused metaverses and brand focused metaverses potentially. I think we're not going to see a single metaverse controlled by a single company or a single entity or even some committee or something like that everybody subscribes to. I think we have some fundamental protocol level standards that are important. We have the ITU that will continue to be relevant, the International Telecommunications Union, we have the GSMA and a couple of other organizations like that help us to define fundamental standards that are important for interoperability at a relatively low level. But fairly quickly, once you elevate above that, you're going to start to see diversification. I think, I mentioned a couple of the industries earlier in my talk. I was talking about, maybe Disney and children's entertainment or or telcos indeed for regional or localized metaverses, and I think that they're important. But if I can talk about three specific applications just a little bit. The first one is collaboration, and I think that that's really important. We've been moving towards collaboration for a long time, and we're getting better at it. This is a fantastic experience, right? This here today, us speaking, hundreds, maybe thousands, I'm not sure how many people are watching. Potentially the entire world could be on YouTube watching this right now. So, I'm not sure what that would do to the Google service, sure, you can tell me, but the scale is just eye-watering. It's just, so the potential for our collaboration today is great. It's video, it's audio. Back in the 80s and 90s, we developed video or voice conferencing. There were lots of attempts to try and do video conferencing, in the 90s and 2000s. It was very weak. Chat groups and chat forums and all that sort of stuff, came of age in the 2000s and so on. We've been trying to do more and more integrated communications and trying to make those communications more effective, more reliable, more intimate. And today we have, pretty good stuff. The immersive metaverse will take that on a step further. And I think that's going to be, I don't like this idea of a killer app, but I think that that's going to be something that drives a lot of innovation. A lot of enterprises in particular will invest in improved collaboration. So I think that that's a really important one. Gaming, I think, is really interesting in terms of where it's going, not just because of the metaverse, but because of some of the other things that have already started to happen in terms of in-game commerce, in-game advertising, and games as a platform environment, not just for actually actively playing games, but just for hanging out, just for being a place where you can go and meet people, where you can experience, you can have different kinds of experiences. You can go shopping, you can not just for digital goods. And so I think we're already starting to see the gaming environment, whether that's, metaverse with a set of VR goggles or something, or just simple, PlayStation type engagements, where you're already starting to see very rich experiences beginning to happen. I think the first tweak I had of that was when Google bought, or Amazon bought Twitch for, I think it was a couple of $1 billion, like 10 years ago, something like that. It's phenomenal. This is a streaming platform for people who watch other people playing games. And it still blows my mind that it was $2 billion back then. It's probably significantly more than that now. But the point is that games aren't just about playing games. Games are a social experience. And within that experience, you can, there's a lot of different things you can do. And then the third thing is retail. And, retail, we're already seeing a lot of retail businesses exploring and experimenting. You've got Adidas, Hilfiger, Gucci, HSBC, and the banking side, JP Morgan. They're already established. They already have established metaverse environments. They're trying to figure it out. I'm almost certain that their metaverse presences are going to be completely different in 2 years' time. It's very much an experimental phase. All of those brands, I didn't check this, but I'm willing to bet that all of those brands had a significant presence in Second Life as well, 15 years ago or whenever that was. And so, and they're not there anymore. I haven't checked that either, but I'm willing to bet that they're not there anymore. So, these new technologies, they come on board, and we experiment with them, we try them out, we see what might work, and we evolve a kind of a model that might be suitable. But I think every enterprise is going to be thinking about how they can accelerate their digital transformation, to use 2022 language, using the tooling of the metaverse, how they can improve automation, how they can use AI to improve customer experience. And if the metaverse can help them to do that, then they're going to be in for that.
Thank you, Anthony. Lots of things to think about there. As always, when you leave it all on the table. Doctor, can we talk a little bit about what the metaverse is, or what students and academia are looking at in the metaverse? Are they excited by it? You know, not just for the gaming, by the whole domain. So I'll leave you to talk to us through that a little bit.
I think they are, but before I get into that, I would like to add maybe education could be another industry as well, because education and training. So the last 2 years, I know we kind of accelerated, leapfrogged like 10 years, like in terms of education and teaching, in terms of remote teaching, right? So now we're teaching like myself teach now over 200 students every week doing lectures, live lectures. They're not all in Australia, so they're in different parts of the world. So, right now, I guess the main challenge there is the fairness. So everyone doesn't have a MR capable or like a virtual reality kind of device with them. But 10 years ago, we also did not expect that everyone has a laptop. Every student has a laptop. Nowadays, every student has a laptop. So we might come to a time in future that everyone has a VR headset with them. So then, we will have real opportunities in education and training with Metaverse. So I'm really excited to, really experience that in education and teaching. Now, comes back to, what we are interested in. We are interested as academics. Yes, there is significant interest in all different domains. So I talked a lot about privacy and security earlier, but academics are really interested in performance and developing new technologies to really realize Metaverse when it comes to, whether it's better networking technologies and, there are a lot of work going on in academia to reduce latency in Metaverse kind of applications, because latency is probably the most critical thing. Probably capacity can be improved, it can be handled even in the current context, because we're not really overloaded networks with Metaverse like applications yet, but the latency is even right now a problem. So there are a lot of work going on, with distributed computing and edge computing, and how edge computing can be supported in terms of delivering Metaverse-like services. And then there are a lot of other work in human-computer interaction domain. So they're really interested in Metaverse, and while also developing devices that can interact with the real environment, and also certain devices that can interact with virtual environment. For example, you mentioned smell earlier. Probably you didn't mention, but also taste as well. So I have seen, academics working on devices that you can, in a way, teleport the taste into a different environment. So at CI researchers, there's significant interest in HCI community in Metaverse. And then we have, this machine learning and AI development that kind of keep going, and it's kind of, in a very exponential, we have seen exponential growth over the past few years that not really attached to the Metaverse, or they're not really talking about, we are doing this for Metaverse, but Metaverse is going to get benefit from the development of machine learning and AI. For example, if you go look at academic, let's say computer vision conferences, there are a lot of work in 3D point cloud analysis these days. So that's all at the end is going to, support the development of Metaverse in the future. So, and then security and privacy has only started, we started thinking about it probably 2-3 years ago. And it's very early stages when it comes to security and privacy. So,
okay, that sounds great, actually. And thanks for giving us that insight. That I did mistaste out. You're right, but all of our senses will be exposed in the metaverse, I think. So, based on that, Shriv, can I ask you about the place of data, and particularly what you were talking about, that zero-party data and how we as humans have control over our data. The data at the moment, I think it's right to say that the institutions that are collecting our data are really only custodians of it. They don't own it. I know they do act sometimes as if they own it, but they don't. They are custodians of it. But I think what we're talking about here, and what I'd like you just to expand on, is the reversal of that ownership back to its fundamental source, and how you see that moving forward.
So I'll take that first, and then I just wanted to add something back to the kind of that conversation that I opened up, a can of worms with the decentralization stuff. But okay, so for me, I think control is really important, and there's a lot of discourse, interestingly, kind of Europe and Germany, especially driven by kind of the German discourse about a real worry around the ownership of data. Right? So it's all about who controls it. And it's actually very difficult to kind of, in a sense, own data from a theoretical perspective. You just copy and paste it in lots of different places. It suffers from that in that regard. So the problem is that ordinary people don't really have control of their data because they have no mechanisms to control it. And they don't have their own, as I said, sort of digital vault. Now, where we're getting to, interestingly, in Europe, so in March 2024 is kind of D-Day, or kind of Data Freedom Day, if you want, for this kind of reckoning that's been a long while coming. And what they've said is that they said that all the major platforms, the kind of gatekeepers, as they're known in this new piece of legislation called the DMA, it's a really large piece of legislation, and this is just one part of it. They've said that 450 million people in Europe will now get updated GDPR rights for data portability. So today, if you want data portability, you have to kind of email, and then you have to wait 30 days and say to whomever platform you want to go to, and they will eventually send you a file over email. And all of this was written back in kind of 2016, before GDPR got implemented, and that's how things work then. What the update is, now you can do it in real time. So in the way that you sign in with Google or Facebook or Microsoft or whatever it might be, you now just use that OAuth system to say, right, I want my data in real time, and I can port it to any other third party I choose. That's a real game changer, right? And it's a bit like open banking systems, if you're familiar with them in Europe. And actually there's a commercial equivalence in the US, because people have realized if you can get people to swap out their data suddenly and move it from one platform to another in a really consumer-friendly way, i.e. just a couple of clicks of a button, suddenly the whole economy grows. And yes, it might not benefit one player, but it will benefit everyone else. So that's really, I think, going to be a massive game changer for the metaverse, for those basic primitives about data control. Just to come back to that other discussion about kind of, again, what we want to see. I think, Twitter has been very salutary at the moment in what's going on with Twitter, right? It's perceived by its own users to be an open and common space for sharing information, right? As a kind of metaverse primitive, it is very basic. People just have pictures and that's it. So it doesn't really qualify for that, for sure. But how people want that public space to be treated versus how this now very singular owner, Elon Musk, is now treating it, I think will give you a great insight into those debates as to how we should treat the metaverse, right? And how consumer reactions, and expectations will really bristle up. And I think that's been the story for the last decade against the people who actually, in law, and in terms of making the decisions, actually kind of, vie up against that. And so, for me, just one last thing on that is to say, for me, the first experience of that was really the Huffington Post, right? So everyone was sold on a dream that, if you contribute towards this common space by providing content and writing for it, you could reach the world. You can really get your voice out in a way that you just couldn't before because it was kept by, major newspapers. And then, of course, I think it was in 2011 or maybe 2010, Arianna Huffington then sold the Huffington Post, and her investors made, I think, 300 million at the time. And everyone who contributed felt cheated. And my fear is that we end up again with the same thing again and again and again. And the metaverse is just a new frontier for that kind of long con. And so you really need to start right from the beginning on the ethics side with basic principles and actual forms of common control. And that's the bit that I fear that we're not going to get, because the technology doesn't lend itself to just that. It's much easier to deliver the metaverse through centralized servers and, a small team of dedicated professionals who are really well incentivized than, big, and I come from the Web3 community, than big web sprawling, decentralized communities because the protocols are just so complex to deliver. So anyway, that's, I guess, sort of that take on decentralization again, keep coming back to it. So apologies, Paul. I know you want to move it.
No. This is a great, as you know, this is a topic that consumes me a lot. But we also need, go on, Jeff, go.
Well, I was just going to say one thing, the weak spot is in fact the data, right? That's actually why I'm working in that problem space, is because without the data, none of this really functions. Without people actually coming with that kind of rich digital story, right? You certainly don't get more than one metaverse, right? So if you want competing metaverse, people have to come with the data. And I think for me, that's the weak spot in there. I can't see how decentralization really works except with people saying, no, I'm going to gatekeep my own data. So, now I have some leverage at this table.
Do people care enough, Shiv, if you don't mind me asking? I mean, do people care enough to manage their own data, or?
No. They don't care enough to manage their own data. No one wants to. I don't want to manage my own data. I mean, I've got too many things going on in my life for that, right? Right. So it needs to be super convenient, incredibly well incentivized. It needs to actually give you something rather than just being another managerial task in your life. So, I mean, that's why, we can talk about sort of data union primitives, but there are lots of them around. Honey is a good example, right? Or kind of a basic version of that. Share your information and we'll give you real-time discounts and coupons. We'll actually get our AI to work for you, right? And, they've got 17 million users, and I think they sold out to PayPal for 4 billion. Again, because PayPal are interested in the data, right? And that sort of aspect of it.
But it's interesting. I read a paper the other day where somebody was hypothesizing that everybody in the world has got about £10,000 worth of data a year owned by themselves. So that economy is just untapped. But let's move on, because I don't want to, we've got to draw this to an end sometime. But one thing that we haven't talked about is the technology enablement of this. So Sherry, could you talk to us about, how at Google you are looking at not only, the collection and sort of articulation of this, but actually putting it in place. And I love the fact that you are telecom biased as well. So, those two technologies need to be interlinked to make sure that anything we do works, but this in particular. So over to you, Sherry. You're on mute, Aldous.
Thank you, Paul. It's a very intriguing discussion. I wanted to kind of like jump in on many different fronts. Before I go on to the technology first, I just want to respond quickly about the role of data, right? I think with Web3, the technology, of course, and I'll talk briefly about that shortly, but it's also the changing business model that is enabling, the user who generates the data basically to actually get an opportunity to be able to monetize, in that sense, the data that they contribute to the entire economy. So I think there's quite a bit of a interesting change from that perspective that's happening in the market. From a technology front, I guess one of the key enablers of the metaverse experience is coming from the baseline. Of course, the devices, the AR, VR, ambient computing, and the kind of devices that enable us to enjoy those experiences is going to be core and critical, and we see a lot of improvements as we speak. But underlying at Google Cloud, we're looking at how do we empower and enable Web3 technologies from being the critical baseline infrastructure where organizations build their metaverse or their digital or virtual experience in that sense. So we've been dedicating basically Web3 teams to go out there and support our customer in building and deploying products, primarily on the blockchain-based platforms. Of course, this is leveraging on kind of like a global cloud infrastructure that can then cater to the high computing requirements and the latency that is needed in the virtual experience, right? We talk a lot about being real time, having that immersive 3D experience, being able to move across the physical and the real time, physical and the virtual experience. So that global infrastructure from a cloud computing to be able to provide that low latency across the world is going to be super critical. The other very important layer, I think we talk a lot about that, is at Google, we look at, how does BigQuery, very, very popular tool that Web3 developers use, and Looker provide the ability for data, AI, and machine learning. And here we're talking about, high capacity, high compute requirement, machine learning capabilities that are actually driving significant improvements and adoption in industrial use case, as Paul, you alluded to that earlier. For example, let me give a very good example from a healthcare perspective. One of our partners, Zulik Pharma, has just announced their presence in the metaverse, primarily coming from the perspective that they believe the labor and human intensive pharmaceutical environment will get a lot of efficiency. They call it the metaverse efficiency, out of bringing some of their enablement training as well as experimental work into the metaverse environment. So in that sense, Google Cloud is really looking at how do we provide that massive scalable, very, very important. Dr. Kanchana talks about secure infrastructure that is low latency. And in the Web3 environment, it's a very complex ecosystem. And we're looking at multiple fronts of different ecosystem working together, and which is why the whole concept of collaboration, as Anthony rightly pointed, and openness of the platform with an ability to adopt open source technology and ultimately that is scalable and secure. So in the Web3 arena, we look at many players, right? All the way from layer 1 or layer 0 to start, where infrastructure like Google Cloud is providing the computing, the telcos, for example, are continuously enlarging their capacity for connectivity, or even, more efficient, cost-efficient connectivity, for example. We see new players coming in to build layer 1 infrastructure or foundations. How do they build the different nodes and programming to enable, layer 2 to build services, on the blockchain. There is a huge, because of the need for capacity building through collaboration, through different parts of the player bringing there are different values into the whole ecosystem to make this whole metaverse comes to life. I think the API layer is going to be a very, very play a very significant role. And at Google, we are really looking at how to make the API management and exchanges as seamless and as easy as possible, so that we can allow many, we use the word democratize, citizen innovation and creativity, for example, with the API management through APG. We're seeing how people can bring data in and out in a very seamless, secure, as well as speedy manner. Then of course the whole world is exploding with creativity in layer 4, where we are seeing a lot of users in the Web3 world. We call it the D-apps, the new type of digital wallets and browsers are all over the place. It's a very, very exciting world that we see that a lot of things are still forming. I'm always saying that we are looking at, every one of us participating in the creation of the new world that we're going to very soon enjoy and live in. So I think complex environment forming would be the word, and it's an environment that we look to, openness and collaboration.
Well, that's great, and I think that's music to Shiv's ears. If we're going to have real-time APIs where we can take data out, and the European Union will be applauding you. Okay, so I think we've talked a lot about a lot of subjects here, but one that I think we've left on the table is the ethics of this environment. How do we look at instilling ethics into a metaverse that is, a bit of the Wild West at the moment, as far as I can see? How do we take on the trolley problem, for instance? I think I gave a little example of the trolley problem before when I'm saying, as a network provider, and you have to be able to give bandwidth to one thing or another, who makes that decision? We're putting it into machine learning and AI at the moment, but those decisions need to have some ethical content in it. I'm one, I think that most of these large organizations need some sort of philosopher in their sort of use case analysis. So I'm going to throw that around to all of you. What are your thoughts about, I'll start with you, Anthony. What are your thoughts about how we instill ethics into this environment? Because as we move forward and we move towards, dare I say, general artificial intelligence, transhumanization, if you like, we have to have this human ethical component in our technology.
Yeah, I love this topic because it really brings us back to first principles in terms of what's really important. And I've said it a couple of times. This is a people thing. Just getting into this, we talked earlier about the importance of taste and smell as being representative of the real world, and sort of trying to transpose that. There's a book I want to just plug. It's called Smellosophy, and it's a fascinating read. It's by a woman.
Did you write it?
No, not at all. No, that book is still in draft form and won't come out for another 15 years. No, when we think about the real world, we think about sight and we think about sound, first of all, and our machines, our computers and our sensors prioritize those things over everything else. But our lived experience is very different. And so most of you, I'm sure, will have had the experience of a smell triggering a very vivid memory in your head of your grandmother's kitchen, or, something at school, or, and it's the smell that triggers it. It's not the words that describe the event or a picture, it's the smell. It's a strange kind of a feeling when that happens. It's a very not just a deja vu sense, but almost a sort of a time travel sense. So these are very important parts of what it means to be human, and making sure that we recognize that when we try and recreate virtual worlds is going to be really important, because it will always be that element of the unreal about virtual reality ad infinitum, I would hope. But on the ethical problem, you mentioned philosophy. I'll drop a couple of philosophers' names. Ludwig Wittgenstein had this theory of communication as a form of life. And what he meant was that, life in and of itself isn't self-contained, right? That we have to relate to the outside world. And it is our communication, our communicative capacity that actually represents life. And there was a philosopher of technology called Langdon Winner that took that on in the 1970s, and he talked about technology as a form of life. And really you can see those kind of theories in our thinking about the metaverse and you know what that means. Because when we think about the metaverse and virtual reality, we're talking about creating an environment within which we express ourselves as human beings. And you know, there'll be a lot of talk about commercial stuff, and there'll be a lot of talk about technology stuff, but really it's about what it means to live. It's about consuming services. It's about engaging with other people. And so, you know, and all of these things we've been doing, you know, since the dawn of man, and today, and over time, we've developed an ethics of society. We've adopted a humanist ethics that allows us to interact socially with people, and we've translated that into politics and laws and all that sort of stuff. And so we have to see those ethics kind of translated into our technology, into our technical realization of the world as well. It's a real challenge.
It absolutely is, and thanks for that, and thanks for the reading material. I'll put that in the chat, please.
It's your homework, Paul.
Yeah. Well, I did that as an exam question. Okay, Doctor, what about your thoughts, ethics within the academia, and how we're going to push that into teaching, and we'll teach people about what this is all about?
Yeah, sure. What I would like to add there is, you know, in Metaverse, there are many decisions. You know, the computers are going to take many decisions, and algorithms are going to decide what to do. Like as your example, okay, how the spectrum management, so it comes down to that level of detail. So algorithm will decide which spectrum that you're going to use, for example. So then, so there are a whole range of work these days now on, you probably have heard around ethical AI, explainable AI, responsible AI. So, if you all remember, so maybe 4 or 5 years ago, when deep learning suddenly was producing remarkable results, people really struggled to explain why, how. Okay, but now we can't keep going on like that. So, if we want to move on with proper, you know, developing an ethical solutions, we need to understand why this particular AI algorithm, you know, ranked a certain user ahead of another user, for example. Okay, why a certain algorithm decided that, okay, this is a malicious content, not the other one. Okay, and so there are research going on in that space, and I think that will lead us to better developed, you know, a more fair metaverse in future. And then the second thing I want to add is, so when it comes to ethics, I think we need to back it up with proper regulations. For example, when it comes to, you know, regulations like GDPR, I believe in Europe significantly improved in terms of how companies make decisions, how companies treat user data, and how they're going to communicate with users about what they're going to do with their data if they're going to collect data. So we need technologies like responsible AI technologies plus proper regulations.
Okay, I couldn't agree with you more. And that starts inside as well as outside. So Sherry, I've got to ask you this question. You know, the chief ethics officer, how do we deal with ethics at a shareholder board level? Do we have an independent chief ethics officer? And if so, do we give them the ability to dictate our ethics?
Yeah, Paul, I think I'm going to disappoint you a little bit with this response. I think the whole possibility of metaverse, right, really falls into the realm of how new frontier technology will transform society at large. when you're talking about new frontier technology of the scale that is going to have major impacts on different facets of society, unfortunately, it's not a simple question. It's not a simple equation. And I would say in the fronts of ethics, we absolutely have a lot, I would think that technology has far advanced, in a stride, but from a arena of ethics and regulatory framework and governance, there's still a lot of work just because of the complexity. So I would advocate, given the complexity and the scale of collaboration that is needed, there has to be increased conversations between governing officials, the governments, the different types of agencies, and we're not even talking about like one arena of a technology council of ITU, for example. We're talking about technology council, we're talking about cybersecurity agencies, we're talking about central banks, financial and fiscal policy, because those will all have a hand into how capital is allocated. And when you start to define how capital is allocated, what's acceptable practices, that would then drive in down to how the real world economy is going to react. Where do we build services and solutions? It's going to be a very complex conversation and collaboration.
I completely agree with you. This is complex, and can regulation move at the speed of technology? And I think we all know the answer is no. So do we need to pare back that with our technology? I happen to sit on a UK House of Lords committee, which is looking at governance in Web3 and the Metaverse, trying to make at least some basic understanding of safety and transparency. But I know this is a subject very close to your heart, Shiv. So, the ethics of where this data lies or this privacy lies, and how we actually instill that into the Web3 economy. Do you want to just take a few minutes on that?
Yeah, you put this all on my shoulders, Paul. Thanks. No, I'll try and stick to the metaverse aspects of it. And I'd say, look, this isn't, I think, the trolley problem is interesting, but actually it's the trolling problem that will probably arrive almost certainly first. If we look, let's try and again, search for things that look similar to what we'd like, or not we'd like to see, but we think it might end up like. So gaming communities are very, I think they're actually pretty developed forms of the metaverse. If you've done multiplayer gaming, you've got people speaking to you in a headset. You're talking back to them. You're in this wonderfully, amazingly rendered world. If you've ever kind of played Call of Duty or these kind of shoot 'em up games, right? These things are absolutely stunning. Often delivered, again, as Kanchan said, it like at the edge, right? So people have got their game console in their house. It's right there, they're literally touching it. So that's very interesting. And how does it play out in terms of ethics? Well, I guess, yes, there's lots of people who, you get sworn at and you get trolls and, people butt up against each other. There are good reputation systems, or not good, but there are reputation systems. So a centralized party can just kick people out of there. But in the end, people think, well, it's just a game, right? So how far can this really affect the rest of the world? And it's kind of how we thought Twitter and Facebook would be, people just sharing cat memes and isn't this funny? And then suddenly, of course, information flows start to affect an election outcome, or election outcomes around the world, or people put out a tweet and it affects, stock prices by billions. You're like, oh, hang on, this does have serious effects. So, one other element to say to that is that it's now taken, we're like on year 12. If we take 2010 as the starting point for when social media should have been on every politician's radar, we're still 12 years later. We haven't really got anything comprehensive, certainly not in Europe or America, on how social media should be regulated because it's incredibly thorny. I fear it'll probably be the same with the metaverse. People go, well, let's just, these are startups, let them be, let the space develop. I've seen it with we've all seen it with Web3. And I've advocated for some of those arguments, like, let's not have too much regulation. So I think I agree with the rest of the panelists in that sense. We certainly need deep ethical protocols that are actually agreed by everyone from the get-go. Let's not make the same mistakes that we did with social media and also Web3 and the crypto community. Let's start off with signed up protocols because they'll take a couple of years to develop anyway. They won't be great. They may not be brilliant. They might be, they'll almost certainly not be fully comprehensive, and don't let the perfect be the enemy of the good, but we'll have something, right? Something to start with. And I think that I'd certainly advocate for that. And the only last question would be, is it industry-led and it's just sort of self-regulated, which actually would still be better than Web3 at the moment, or the crypto community, or is it from government top down? And at the moment, I'm sort of equivocal, but maybe the other panelists will have thoughts on that.
We're getting towards the end, but I would like to throw that around. Where is it led from? Where are these governance rules led from? And that was probably my question to you, Sherry. Do you have that ethics officer inside the organization? And if so, where do they report? Because that's important. I think, that's a self-regulated environment.
I think, Paul, maybe two perspectives. One is from a Google perspective, just like sustainability, innovation, ethics and AI and data privacy and protection is embedded into everyone's responsibility from day one we onboard to the company. It's trained because you don't want to kind of like put it in the arms of one person. Of course, we set very clear policy, but it should be embedded and built into every single one. For us, every Googler's responsibility to ensure that we hold ourselves to the highest standards of ethics when it comes to data protection, privacy, AI. So that's one. In terms of the metaverse, I would say that because it's at very nascent stage, I think just like Shiv put it, right, I think that it requires a lot of conversation between industry and the governments and some governing, technology body. Unfortunately, the conversation and the dialogue is required to get everybody aligned into providing a safe and secure environment where innovation can thrive. We know the dangers when you let things run on its own, with speed. That is sometimes a consideration for, what is sustainable. To build a sustainable, immersive, enjoyable environment where industry and economics can thrive. I think that dialogue and alignment across industry and governing bodies needs to be in place.
I agree. I completely agree. Yeah, Shiv, give us a quick response to that.
Sorry, this is almost a little bit. It's not quite a response. It's just actually, Paul. Do you want to come back to me? I'll make another point.
Yeah, I'll come back. I do. I'm very much, Sherry. The thing is, it's hard, but that doesn't mean we shouldn't try. And I know myself and my universities, and I'm sure Doctor in Sydney there. The universities are trying to put these ethical concerns all over the place. I'm going to move on to a couple of questions. So if you want to come back in, Shrew, then please do, or Anthony. But I'm going to move on to our questions now because we've had a very intense debate here. I've really enjoyed it, actually. It's the light is happening in England. So do you want to come back, Shrew, quickly?
Yeah, I was just going to say this, which is, it's on obviously on the topics of ethics. All of this is, as Sherry has said, like it's very early stage, right? So you're asking yourself constantly, I guess, what do you want to see, rather than what should be the case, because this two are so closely connected, right at the beginning. And maybe it would also be this, which is an appeal for a commons that can be creative and unbounded, right? Because as soon as you want to sort of commercialize a metaverse, we have now the tools from blockchain and Web3 to say, okay, well, look, this skin that you've got is now an NFT, and we can sell that. Great. The other way of looking at it is, well, why not just have a million things and a million options? Because actually, it's all generative. We can totally do it. There's, there's a place called Decentraland, and the way that it's divvied up is it is a metaverse in that sense, and you create your own little plot of land. But you have to kind of pay for the privilege to be in that space. Well, actually, that's just a construction. It's like taking all the wrongs of the world and social construction and saying, fine, let's just import that into a digital sphere, and let's say, okay, now you have to pay to be into this club, right? And you're like, great, okay, we're just back to square one again in terms of those kind of equity, ethical issues, right? Because obviously, how we run these social systems butts up against or ethics all the time, or pure ethics.
Yeah, so I don't think we're going to solve this problem on this call. We haven't got time. We've only got 5 minutes left. Mind you, we could do, but I'd really like to just throw a few of the questions out from our audience out there. Some really interesting ones, and anybody can jump in and say what they think about this. I'm going to combine 2 of the questions. Humans have 5 basic senses. Do we think we will have more senses in the metaverse?
No.
I'll give you an example of this. Let me give you an example of this. A very good friend of mine, who I've had this discussion with many times, and he did a podcast for us. Chris Lewis, who is blind. And when I first started talking about the metaverse, he said, "Can I see in the metaverse, please, Paul?" Now that was a really, really interesting question. And I said to him, "Well, at the moment you can't even see through the goggles." Because you can't see. And he said, no, but I consume the world through other senses. So, make sure that we don't disadvantage people in that case. So I thought I'll just throw that out there. Is there more than once? Is there another sense that happens? But the next question is something which, sorry, Shiv, you were going to say?
No, I was just going to say time would be the other sense. That might get screwed around by the metaverse in really interesting ways. Yeah.
Very good. Doctor, yes?
Yeah, I was going to say that we probably might not add another sense, which probably impossible, but our sense will be sharper in metaverse. Okay, right now we can see 10 feet away, but in metaverse we might see 100 feet away, and then we can see tiny vibration in 10 feet away with metaverse.
Exactly, and that's what Chris said to me. My other senses are much more attuned to the world that I live in, and I would have to completely learn that all again if I go into the metaverse. So that was one question. I'll ask one more question, which is really interesting, and thank you very much whoever put this in. Humans grow old. One day we're going to die, but can we exist in the metaverse beyond that? And will it become overpopulated? Anthony.
It's fascinating. I mean, look, it's already a problem in social media, right? Because people have very complex and integrated presences on Facebook and other places. I've started to see, I'm not that old, but I'm starting to get older, and I'm starting to see older friends beginning to pass away, and obituaries on LinkedIn and things like that. So, and you start to see, okay, well, how do you manage that sort of that end of life thing? So, will it get overpopulated? Well, I mean, technically no, but will it get complicated to manage the removal of identities and presences? Certainly, aging data is a challenge, but I don't think it's going to be an insurmountable problem. We will have to address it, and I think we will. Just one other point, just on the previous question. I think to back up what Kanchana said, it is a superpower, right? The metaverse is a superpower. It's not really an extra sense, but it means that we can see further. My glasses are a superpower, right? If I didn't have these glasses, I wouldn't be able to see as far as that screen. My iPad here in front of me means I can see all the way to Sri Lanka. That's a superpower. So these technologies, the metaverse, are superpowers. They enhance our senses.
Great, yeah. So Okay, anybody else want to chip in on the overpopulation of the metaverse?
I wouldn't say overpopulation of the metaverse, but I agree with Anthony on the point of how our senses are sharpened, and I think metaverse will provide an opportunity for accessibility that otherwise physically we can't. Just for example, right? Degree partnered recently with Decentraland to run a race or a virtual race, for people of all sorts of disabilities, and they can actually participate and experience that through the avatars, and get a sense of what it means to be in, a marathon, for example. And I think that's beautiful, a work of inclusion.
Great, yeah. Shiv, yeah.
The economist J.K. Galbraith had a book called The Affluent Society, which was all about what are we going to do when there's so much stuff in the world, right? Because we've cracked productivity in all sorts of ways. We might not be there in the physical world, but from the metaverse's perspective, no, we should have full digital abundance. That was the point that I was kind of making before, right? What are the constraints on digital abundance? Very, very few, just electricity and imagination, really. And some devs.
Great. So, that leads us probably towards the end. We've got I did want to talk about transhumanization. Where does this take us with AI? But I'll leave that for a different conversation. If anybody wants to think about that, here is a good book, which is AI Ethics by Mark Koeckelberg. Really interesting view. Really interesting view from a philosophy point of view. But anyway, I'm not plugging that book either, Anthony. Okay, well, I'd like to end this by thanking the panelists here. What a fantastic discussion. Really had my brain working and my metaverse working. So thank you very much and for sharing these thoughts with us. And in the words of William Shakespeare from one of his plays, Julius Caesar, and I'm sure William Shakespeare would have loved to be in the metaverse. So to the audience, thank you for lending me your ears.
Wow, it has sparked a true debate on the topic, isn't it, Pragesh?
Definitely with me.
Thank you, Professor Paul, for moderating the discussion, and thank you to our great panelists, Anthony, Dr. Kanchana, Shiv, and Sherry, for sharing your expertise with our audience.
Thank you very much.
And now it's time for the round 2 of the AI Forum quiz. If you missed the first question, don't worry. We are going to go over how it works. In a few moments, we are going to ask you an AI and metaverse related question. If you've been listening carefully to our speakers and panel discussion, you'll be able to answer it quite easily.
To submit your answer, for those of who have registered for the AI Summit, you would receive an email shortly with all the instructions. You have time till 4 p.m. Sri Lanka time, and we'll be selecting one lucky winner to walk away with the latest Google Pixel Watch and 256 GB Google Pixel 7 from today's AI Forum sponsor, Google. Now it's time for the question. How can blockchain and artificial intelligence complement each other to ensure trust in metaverse? You need to pick the incorrect answer from the following options. Option 1, combination of blockchain and artificial intelligence can help enable trusted digital analysis and decision making on vast amount of data. Option number 2, blockchain enables to create secure data sharing and makes artificial intelligence explainable. Option number 3, AI helps to provide effective personalization for users using blockchain. Option number 4, regulating trust between devices that cannot trust each other. Make sure to select the incorrect answer. No? What's next?
Well, Redmi, now it's time for our Geeks Hangout. This exclusive session is designed to help you develop your AI and machine learning skills. And it is hosted by Shimei Lee from today's AI Forum sponsor, Google. If you signed up for this exclusive session, you would have already received an email from us with the link to this exciting breakout session. Head over there now, but don't forget to join us on this main cast at 4:15 p.m. to find out the lucky winners from today's AI Forum, as well as the winners from day 2 and day 4 of our podcast series.
So, now geeks are heading to Geeks Hangouts, and there are people who are answering the question also busy with it.
Yes.
Now we are going to show you another one of our incredible AI products that have been developed by the AI analytics team at ADL. Let's take a look.
Hello, Amarka.
Hi, Dinu.
Thanks for joining me. So today's objective for us is to talk a bit about AI Factory. I hope you're up for it.
Yeah, let's do it.
So my first question is, what is an AI Factory and what's the story behind ADL AI Factory?
Okay, the AI Factory, the buzzword came very recently. I mean, when I say recently, it's a product of COVID-19. So if you have heard Moderna vaccine, they have developed that vaccine within 3 months. So they have used AI Factory concept behind that. So this rapid development, which normally take 10 years of time to develop a vaccine, they have developed in 3 months. So think about, I hope you all have heard about self-service BI. Let's take for an Excel. Previously, everybody has to go to a person who know the Excel or who know these spreadsheet calculations and get their analysis done. But Excel and the self-service BI tools which came lately, platforms has revolutionized it, reduced the time. Everybody can do their own analysis. Even kids now do their own analysis by using, best example is MS Excel. So AI Factory is same concept. It democratized AI. So what happened? Self-service AI, anybody can build their AI models and put it to the production, get the result short time. So it save cost, it save time, and not only that, it's lower the skill barrier. So that's AI Factory for me in a nutshell. So ADL AI Factory do the same. It save the time, it lower the skill barrier, and we can put into the production our models in a few days of time.
Is it like a typical factory? So like, what are the components in ADL AI Factory?
Of course, let's assume this as a car factory, right? In a car factory, we bring raw material. In this case, it's data. In a car factory, it's rubber, it's nut and bolts, those sort of stuff. Then once we have the raw material and when we process it to some usable component like tires, like nut and bolts, then it's all about putting them into the together and build a car. So in AI Factory, also same, that we have a raw material which is data, then we process it and we created some usable artifacts using this data. So those are available in the shelves. So any user that who comes to the AI Factory can drag and drop these component, and then in order to build a machine learning model, they need tools. Like in a car factory, you need a different type of tools, you need spanners like that. So here we have a specific set of tools that are geared to AI development. So these tools and the raw material, we can build a AI model within a short period of time. So in ADL AI Factory uses the same concept that as I use in a car factory. So what we do is AI Factory, we can put into all the usable data artifacts as a feature store, and those are available in the shelves. Then all the available, all the required, all the state-of-the-art tools available in the ADL AI Factory. So anyone can take these tools, take these features and build their own AI. So some of the notable component: AI solution store, dataset store, then personal workspace, which already have inbuilt tools that require to build AI models. And not only that, it capable of tracking our experimentation, tracking our model development and how things went and what are the parameters that we have used. So all the measuring component, tracking the experiment, tools, these are the kind of AI factory that we are talking about, ADL AI Factory. So one thing I would like to mention, not like in a car factory, in the AI factory there's an experimentation component. So because of that, we have two components largely: experiment bay and the production bay. Experiment bay, where we do the experiment, get something done. Then once we are happy with the model, we put it to the production bay to put it to the production. So that's AI factory, ADL AI Factory.
Right. So you mentioned about an AI solution store and a dataset store. Can you explain what they are exactly?
Those are very nice two features that we incorporate into ADL AI Factory. So we thought, what's the day-to-day life of a data scientist, data analyst? So when a business unit head or different type of stakeholders come to a problem to solve by data analyst, what they first do is they Google it. They find if someone has done this already, because they want to save the time and they want to get if something has been performed somewhere else and copy it and start development on top of it. So AI solution store and dataset store are the same. So imagine there is a company, this is a large conglomerate, and two different churn models are being developed by two different people, but nobody knows that these two people are developing churn models. So they can't share their codes with each other. So likewise, AI solution store consists templates, all the common templates that where someone can just clone it, start developing on top of it and customize it for themselves. Not only that, if someone build a model, for example, churn model, they can publish it to the AI solution store with their author name and everything. So if someone wants to build another churn model, they can just go through it and contact these people and then clone this particular code base and start developing their own model. Maybe not from this kind of a scratch, they can start from level 3, level 5, where they do the small customization and get it done. Then I will come to the dataset store. So this is very valuable asset because we all know most of the people, most of the data scientists, data analysts, they build their models, maybe their own private environment, maybe laptop, maybe their environment given by the organization. So they create data sets that are local in their nature. Once the model is put into production, this data, that which valuable asset, that clean, cleansed, labeled, annotated data will be lost. So what happened? Another person wants to build, or another person wants to test another algorithm with the same data set, that's not available. So here what we do is, anybody who create a data set which is valuable for someone to test, someone to try it out, someone to use it, they can publish it in the dataset store and available for anyone else in the organization. Not only that, if there's a very precise data set which can be anonymized and can sell to someone else in the industry, maybe in the region, so they can subscribe it and they can monetize it.
Interesting. So what are the business benefits an organization can gain from AI Factory?
Okay, so in AI Factory, when we build a model, there are two types of models. One we call weak AI, other one called very complex superpower AI. So it's like that we use a normal car to travel somewhere else and we drive a Formula 1 kind of a power car. So these are two different skill sets that we need. So in AI Factory, there are power users, there are low code, semi-code users. So the different type of users can use ADL AI Factory. So I will take you a virtual tour what is AI Factory and how a person go through the AI Factory process. Then it will help you to understand what are the benefits that we can get out of it. So let's assume I am a data analyst. So I am a low code user. I'm not going to build a very complex AI. This is a very weak AI, but when I say weak AI, that doesn't mean that they are not usable. That more and more weak AI models will get benefit for the organization. So if I am a data analyst, so let's assume that my boss comes to me and asks, can you build a churn model? So they want to identify the customers who will churn in next month. So now I am an analyst and I am an AI Factory user. I will log into the ADL AI Factory. The first thing I do, I will search a solution if someone has already done a churn model in the AI solution store. Definitely there will be templates, common templates, and maybe there are very developed production grade ready code bases in the AI solution store. So I find some template or maybe a code base. I contact the author. So I did have a chat with them and okay, how you build and what are the intention behind that, likewise. Then once I'm happy with the code base, I just clone it. So then I have the code base to start with. I'm not going to write something from the very beginning. So I'm going to start with the level 3, level 4, level 5 like that. Then I need a data set. So again, instead of creating a data set by myself, I will go to the dataset store and I'm finding, okay, are there any interesting feature collected data sets available in the dataset store? If something is there, I will clone it and data sets available in my prior workplace. If not, I have to do the annotation and create the dataset. I can publish it if someone wants to in future use it. So let's assume now both are available in the AI solution store and dataset store. So what happened when both of them are cloned into my environment? I have saved maybe weeks of time. It's just a couple of hours, datasets and the code base is readily available. Now what I want to do is it has to be customized for my purpose. I will start with AutoML because those are embedded in this particular templates, most of the code bases, and start training my model by myself, going through that several iterations. The good thing is ADL AI Factory, all these experiments are being tracked. Their KPI, their metrics, that how much time it has taken and how much memory it has got, how much CPU, everything matters in AI world, because when there is hundreds of AI models going to be live, so these minor memory components will add cost too, because if we're going to the cloud, that's with the nature. So now all this been tracked and we can go back and revisit, okay, what was the model that performed well using minimum resources in the AI factory. So if I'm happy with the accuracy, now it's the matter of putting it to the production. The good thing is ADL AI Factory, it's a few mouse clicks. You just click, 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 and it's go to the production bay. And it's readily now it's available for the prediction, inferencing. And that's a day-to-day operation in AI factory user for a data analyst. So it's that simple. So benefit for the organization, we can build so many weak AIs within a short period of time, ready to market for these build models, and it save time. Again, I'm repeating, and it save cost, and it lower the skill barrier. And not only that, we can track everything all together because all those are inbuilt. The one thing that people are missing, especially in AI world, the code standardization. So if I am a user, if another user comes into the picture, they have different code standards. So this is not going to work with the organization because they have to maintain it later. So AI Factory, what it does is, it maintains these code standards. So whatever comes out in experiment and put into the production will be an enterprise grade productionable code basis. So that's all about AI Factory. Anyone wants to revolutionize their AI use, like everybody using Excel sheet or everybody using PowerPoint, this is another platform. Anybody can build their own AI. Instead of going the gut feeling, use your AI, then you are with your own benefit. So that's AI Factory benefit.
A common topic these days is AI democratization. So how can this be accomplished by ADL AI Factory?
So as we talk through, this session, so it's all about AI democratization. So as I said, BI is being democratized, data democratized by using different type of tools. So AI Factory is all about AI democratization. Anybody can do their own AI, build weak AI and put it into production. So let me take it very simply. Again, I'm taking the Excel metaphor. So Excel has enabled anyone to do their own analytics spreadsheets, building charts and do some graphs and do the analysis, mining insight. So same thing equal to the AI Factory, which democratize AI. So instead of calling it AI Factory, I would like to call it self-service AI. So for a kid who coming out of the education can start developing their AI using these platforms, and maybe intern can build very groundbreaking AI models or can be generate so much revenue. So this type of platform makes sure whatever we build is maintainable. Otherwise, everybody comes and develop models and which are not maintainable. So this democratize AI usage as well as is make sure it is maintainable. So AI democratization comes with the headache of maintainability, but making use of AI Factory will make sure that whatever we build is maintainable and anybody can build it using the simplest way that we have presented in the AI Factory.
Thanks, Amakar. So finally, how does the future look like for ADL AI Factory?
Actually, that's very interesting and very exciting because maybe you have heard, and maybe all the people listening to this heard about ethical AI. So it's all about whether AI doing the right thing. Previously, it's all about we are putting an algorithm, say input some data and getting something out which is not explainable, and sometimes it discriminates some kind of categories, some people, some races, like guys. So can we explain these models? So these are the things now discussing in the world right now, and people are afraid of AI. That because of that, does AI have some kind of human element of it? Some kind of biasness happens? Can someone select in an interview based on their different type of categories? So these type of features we are going to include explainable AI, the error analysis, then causal machine learning. These are some buzzwords you can go and read it about. So these type of interesting features will inject into our AI factory. So whenever someone want to build a AI model, especially when we democratize it, all the people can build their own AI. This has to go through a very careful process which will not have any discrimination, and AI fairness come into the picture, explainability come into the picture. So these code bases will enable by default anyone who are going to use it. If these gates are being failed, nobody can put into the production. So this is the future it should look like in AI factory ADL. So that's interesting, and we are looking forward to add more and more components like this in near future.
Thanks, Amalka. It's been a very productive session, and looking forward to many more productive sessions like this in future.
Thanks, Dino. Enjoy a lot it. Hope we can help any organization with AI. Looking forward to it.
Hope you all find something interesting and want to learn more about how our AI products and platforms can help take your business to the next level. So head over to our website www.axiatadigitallabs.com for more information. Also make sure to follow us on social media to stay updated. Now, let us have the pleasure of listening to another great speaker, Pragesh. So we have the Chief Technologist, AI, Asia Pacific, Dell Technologies, Aruna Kolluru here with us, and she will talk about convergence of metaverse and digital twins with real-world example. Aruna is passionate about technology, business, and exploring the new possibilities with emerging technologies. She works with organizations to help visualize the art of possible, define use cases, architect and build solutions with AI, ML, DL, big data, and other technologies. She worked in various roles including cloud platforms technologist, big data technologist, middleware technologist, Java architect, and pre-sales specialist at IBM and Oracle before joining EMC and Dell Technologies. She has over 20 years of experience in the industry on varying technologies including AI, blockchain, deep learning, computer vision, IoT, big data and analytics, information management, middleware, and enterprise architecture. Welcome, Aruna, for the Day 2 of AI Forum 2022. Take it away.
Thanks for having me. Pleasure to be here. Along with my role, I actually do a couple of other things as well. I'm a member of the National AI Center in Australia, which is trying to advance AI in Australia. And I'm also advisor for Responsible AI Institute, again, for responsibly building AI, building frameworks. So today, I would like to talk about the convergence of metaverse and digital twins, and along the way, we'll actually touch on a few examples. So before we go into the convergence and the applications, let's briefly define what metaverse and digital twins are. I saw a few speakers talk about the origins of metaverse and the 1992 cyberpunk novel Snow Crash. Just want to touch it again, right? Metaverse is a shared imaginary place that is made available to public over the worldwide fiber optics network and accessed using virtual reality glasses. In it, we actually, developers can go build their buildings, parks, signs, as well as things that do not really exist in reality, such as large overhead lights or special neighborhoods where rules of this three-dimensional space we have is ignored, and free combat zones where people can go and hunt and kill each other. Here, I would like to bring up an example. I was talking to a defense organization who was trying to build AI models to detect objects in the war zone. So they deploy these models. They want to deploy these models on drones so they can send a drone and find more insights. But the challenge here is that it is hard to get the images to train the models so that they have, what they have done is actually created a metaverse of the war zone. They're using a drone in the metaverse to take pictures of the war zone, and they are using those pictures to train the model in the real world and put it on the real drone. I thought it was a very interesting use case. While gaming and retail and to an extent education industries are early adopters, Metaverse is being used by a lot of other industries for some very interesting use cases. Coming to a digital twin is a digital representation of a physical object, process, or a service. A digital twin can be a digital replica of an object in a physical world, like a city or a machinery, or even large items like buildings or even whole cities. Digital twins can be used to monitor existing products and reduce maintenance burdens. Prototyping can be done with digital twins, reducing product defects and shortening the time to the market. Monitoring staffing levels against output or aligning to a supply chain within manufacturing or a maintenance requirements are examples of digital twin use. Monitoring and simulation can improve performance. They can reduce the risk of accidents and downtime through failure, low maintenance costs, and also ensures production goals are not impacted by scheduled maintenance, repairs, and the ordering of replacement parts. Digital twins can offer continuous improvement by analyzing models and testing them in real time. So both digital twins and Metaverse are powered by a range of technologies, while AI, Edge, 5G, AR, VR, IoT, all these technologies are considered as different pillars. But we need to think of these technologies, how we can work together with all of those in tandem, so we can actually get to an outcome, right? So if you think of any outcome, not just in the AI space or Metaverse space, all these technologies, like you need to capture the data from the sensors, you need the edge solutions there, and then you need to bring in the data to a centralized location where you actually need 5G to transfer the data, and then you need to train the models for AI, and all these technologies should work together in tandem to get to an outcome. And Metaverse and digital twins are a couple of examples of that. I would also like to mention here that Dell is a founding member of the Digital Twin Consortium, creating standards and guidelines to build digital twins. I would like to share a reference here. McLaren actually uses digital twins to design the cars. Generally, it takes about 5 years and $1 billion for the R&D for a new model of a car. With digital twins, McLaren was able to produce their first virtual product in 2 years and in less than $500 million. And the time frame for certifying went down from 18 months to 3 days for 150 different variants. And a new model is generated every 10 minutes. This is actually a significant improvement in the cost, efforts, and most importantly, the time, right? They were able to do much more in much lesser time. Also, the most important thing, or like a most interesting part, I would say for me, is McLaren car, when they're racing, they have about 300 sensors on each car, creating a digital twin and understanding the race. All the data is processed and analyzed at the edge. Then the data is actually sent to the race engineer to instruct the driver on what to do. You can imagine the latency that is required. So it processes the data and the race engineer is actually telling the driver what to do, right? So it actually takes less than 22 milliseconds for the whole round trip. You can imagine how important the edge technologies are in this space. When companies interconnect two or more digital twins, we spoke about individual digital twins, but when you can really interconnect those digital twins, you can simulate the complex relationship among different entities and get richer behavioral insights from even more sophisticated use cases and greater value. So an organization might, for example, connects its employee twin and the digital twin of its customers, retail stores, inventory sales, and customer process flows. In this way, it could actually achieve outcomes like simulating an end-to-end impact of business and market changes on a retail store, or optimizing store layouts by responding to the shift in the customer preferences, and assessing different compensation and staffing models by sales, employee performance, and characteristics of a local store, and also enhancing next best product recommendations within the store, and like borrowing patterns and inventory levels. When these twins interconnect with each other, they become smarter as the dependencies and the correlations get incorporated into the modeling, which actually makes it much smarter and gives us more value out of these twins. Digital twins and Metaverse, right? To understand how digital twin works in Metaverse, it actually helps in designing new products with less effort, resources, and time. Digital twins are used to validate process, and whether it's a manufacturing process or a production process, and then the performance of the digital twin actually captures the data from the production and operations and analyzes it actually to provide actionable insights for informed decision making. The combination and integration of these three types of digital twins are known as digital threads. They can be woven into other products by collecting data at every product and production lifecycle stage. Engineers and developers synthesize physical, manufacturing, and operational data to create a digital twin. All this information, along with AI algorithms, is integrated into a physics-based virtual model, and by applying analytics to these models, the relevant insights regarding the physical asset is obtained. The consistent flow of data helps get the best analysis regarding the asset, making the digital twin act as a live model of the physical equipment. So the convergence of the Metaverse technology and the digital twin can bring realism to the virtual world and experiences beyond our imagination, creating exact replicas of reality or even things which are not in the reality as well. So as the lines between the digital and the physical worlds become increasingly blurred, digital twins are widely expected to serve as cornerstones for Metaverse and their interactions between the metaverses, which really empowers users to interact and innovate within immersive digital worlds. But to facilitate this kind of real-time processing and time-sensitive decision-making really needs for digital twins to reach to their full potential. So digital twins require the processing of droves of real-time data. And that's exactly where AI comes in. Once sensors and IoT-enabled devices actually collect the data, it is uploaded to an IoT platform to be processed and then further analyzed by AI or machine learning algorithms to determine future scenarios. And again, adding AI, natural language processing, and computer vision, and these digital twins will transform the enterprise metaverse through a wide range of use cases. Now let's actually look at how these technologies are used in different industries. Retail. Appealing customers have become the key in retail sector. Digital twin applied in Metaverse can play a very key role in mounting the retail customer experience by creating 3D virtual models of showrooms and products, delivering customers a real-life experience. The digital twin also helps with better in-store planning, security implementation, energy management in an optimized manner. It could be used also to in marketing for product placements, immersive marketing, and NFT-based loyalty programs. It can also be used for product try-ons or product testing as well. There are plenty of use cases in commerce and supply chain as well. By using this high-fidelity digital twins of brick and mortar stores, companies actually can be better showcasing their products and services to prospective customers. This really allows companies to provide an immersive and a convenient, immersive and actually convenient opportunity for brands to meet customers where they are, really enabling them to shop from the comfort of their own homes. The goal here is to remove friction from the sales process. Instead of needing to come to a store to check out for a laptop, customers can now visit a metaverse location, or which is like a digital twin, where they can converse in real time with a live associate. With the help of natural language processing and advanced neural network architecture, the prospective customer will be guided through a personalized sales journey with virtualized environment, rendering in products in real time based on the customer's data or the voice input. Even better, the sales teams can quickly pull up data and use augmented visualizations to compare product offerings, give demos, and better communicate with their customers. While much of the potential of digital twins is yet to be realized, they're simply very powerful, and they actually present use cases for business of all different sizes. The next one is actually healthcare. Medical sector has benefited from digital twins in different ways, right? In organ donation, surgery training, and making other medical procedures less risky. Digital twins with data from IoT can play a vital role in healthcare by improving patient monitoring. It can provide preventative measures for the patients with personalized healthcare. So the metaverse is a paradigm shift in healthcare that evolved, and it really involves everyone needs to be, it really needs everyone to be involved in it. This is because it changes how medical infrastructure is built, how startup costs are covered, and how data security and privacy is handled. The immersive parts of the metaverse are a great way to train the medical staff. Some ways that metaverse is changing is how doctors are trained. Simulation training, in which, for example, trainees get a close-up look at the surgeon's procedure while using tactile haptic controls is one example. And then we have interactive training modules that can make it easier to learn key ideas. For example, VR can take a learner inside a human body and show a 360-degree view of a patient's illness. Digital therapeutics are really becoming more popular very, very quickly. With VR and AR in tech and in metaverse, this type of therapy can be used for cognitive therapy, support groups, psychiatric evaluations, rehabilitation, and even physical therapy with help of these haptic sensors. Surgical procedures already use high-tech tools like robotics, so the metaverse is expected to be a useful tool that will help with complicated surgeries and improve care for patients. It also has, metaverse also has caused a lot of buzz and speculation about what it can do in almost every part of the surgery. Surgeons will work on surgeries together with a virtual operating room with the help of other consultants and specialists. Surgeons will be able to see patients' vital signs, pictures, medical history, and other important information on the screen. And then new technology that works with the metaverse can give quick test results in real time to help patients do better. Another area of healthcare that will benefit from the metaverse immersive visuals is radiology imaging. This is because the metaverse will make possible new things in radiology, like more ways to see them and manipulate the images. Viewing dynamic images, more details can really be viewed by the doctors so that they can figure out what's wrong and what's not better. And it also makes it easier for the doctors to work closely together on 3D medical images. So healthcare is one industry which has a lot of potential with metaverse as well as digital twins, or a combination of them. So many organizations are creating immersive real-time simulations in manufacturing for production lines, manufacturing plants, and factories to identify issues and improvements in the design and production process. Companies have already begun to leverage digital twins to reduce design validation time, accelerate production assembly, and audit end-to-end manufacturing operations, all without interrupting the real-world supply chain.
consumer solutions with things and tools will come to you. Medical exoskeletons will help people walk again. Cars will be gateways to hyper-connected, intelligent lifestyles of their drivers. Underwood Group's future lies in expanding human reach to bring about next wave of change. Smart, connected cars will help people with limited mobility get around. Medical routes will come to you when you need the most. We need to become the world leader in smart mobility solutions. How do we get there? How do we transform our company to move people in new ways? We need to create like one of the that technologies delivers. Collaborations with technologies is central to mobility to build. Its end-to-end solution and flexible IT helps us build a digital twin of our manufacturing processes, so our engineers can imagine the future much faster. As a leading mobility innovator, we are building the first of its kind that actually to manufacture our futuristic products. So, what does manufacturing look like? Combines physical and virtual delivery, and this digital twin will multiply operations. Our manufacturing will also build open collaborative innovation hub where we can explore mobility ideas in real time. Nowadays, spaces people technologies is our global and experiences we deliver to the church will drive human progress.
Yeah, this is a very interesting case, right? Like Hyundai has actually built a meta factory. Automobiles, digital twins in automobile sector can create a virtual model of physically connected vehicles. It captures the behavioral and functional data of the vehicles and helps in analyzing the overall performance and connected features of the vehicle. So digital twins help in delivering very personalized customer service for customers. And in future, Metaverse can be a platform for the automobile expos, virtual shows, and their digital twins can help users to have real experience of automobiles through digital twins. So moving into the Hyundai use case, at the Hyundai Motor Corporation, they built an innovation center in Singapore. Engineers use 3D digital twins to reimagine the future of physical mobility, both meta-mobility and mobility of things, as well as how they can transform manufacturing in first ever meta factory pilot, which is actually a facility which is powered by Dell Technology Solutions. From the Metaverse comes the Meta Factory to accelerate its innovation and the efforts to achieve this vision. The company opened its innovation center in Singapore as a global open innovation hub. This hub combines 5G, AI, Internet of Things, robotics, edge, and cloud computing, and all the other advanced technologies like 3D digital twins. As virtual proxies, digital twin enables engineers to simulate products and processes in the metaverse without the time and cost or the risk associated with the physical design process and process validations. This hub also provides the world with a human-centered smart manufacturing platform, which is again the first Meta Factory, metaverse-based digital twin factory that will be verified through a small pilot electric vehicle production facility and then adjacent test track. So researchers and engineers can interact with their 3D virtual simulations in real time, either shoulder to shoulder or over great distances. So Dell Technologies' customer relationship with Hyundai is changing the face of automobile development, design, and experience delivery to customers. Using our integrations, including Dell PowerEdge rack servers, Dell Unity XT storage arrays, data protection, and ProDeploy, Hyundai has taken the innovation to a next level. They have imagined and created sleek bodyworks or wheels and drivetrains, multiple smart mobility solutions that move customers emotionally through the creation of the Meta Factory, a digital twin factory based in the Metaverse. All this is delivered through the infrastructure and powered by Dell Technologies. So operating this lab and Meta Factory requires a flexible IT model backed with a wide range of sophisticated technologies. These include powerful computing workstations or displays, software, servers, storage, and a range of technologies to better use and share data to drive innovation. The facility added an OpenStack cloud computing platform as well.
We believe that anybody, wherever you are in the world, can contribute and participate in the conservation and protection of the reef.
The Great Reef Census is an approach in which everyone can help us capture sort of a snapshot in time around reef conditions.
We're working with the citizens of the Great Barrier Reef on their data model. So being able to use analytics to help analyze these photos automatically.
Then those photos can be used to update maps that help better understanding of the reef and conserving the reef.
The goal is to create lasting positive impact.
What we're developing here is absolutely scalable to the Coral Triangle in Southeast Asia, to the Caribbean, to the Red Sea, to the Pacific.
We're at the frontier of a new era of conservation with people power at its centre. Become a citizen of the Great Barrier Reef at citizensgbr.org.
We are working on the Citizens of Great Barrier Reef. So these Citizens of Great Barrier Reef is an organization, it's a non-profit organization which uses people power to scale conservation efforts for Great Barrier Reef and the reefs around the world. The organization actually uses leading science, innovative technology, and truly cooperative approach to drive significant conservation outcomes. The citizens team brings diverse range of expertise from those that have been connected to the reef for thousands of years and those across the world who have collective passion to conserve and protect it for the future generations. Over the past 2 years, we at Dell Technologies have been working in close partnership with the citizens of Great Barrier Reef to amplify its conservation efforts using technology. Dell Technologies worked to understand the scientific requirements and developed a deep learning AI model, really analyzes every pixel in the image to classify the coral and reef infrastructure in under 10 seconds. Humans then verify the accuracy. So the platform we have built enables every citizen scientist to go and select a segment of the picture like you're seeing on the bottom right corner, select that category and say what kind of coral it is. So we are actually giving the power of labeling or really identifying how much of coral is active and how much is not. And even though it's called a Great Barrier Reef, it has 3,000 small little reefs. How do we actually get to understand which reefs really need conservation or prioritizing which reefs have to be conserved? This efforts are in addition to what the government is doing. We are able to touch more reefs with the technology. So you can actually see the power of technology and how the 21st century conservation is changing the way we apply technology to it. Again, AI is based, this solution is based on AI, but we are actually planning to see how we can build a digital twin of the whole thing, right? Like really capturing the data of from the different sensors, create a digital twin, and in future maybe a metaverse as well, where people can experience Great Barrier Reef from their own backyard. So Dell Technologies has everything you need, right? Expertise and guidance. We have validated solutions which are actually tested and validated for different kinds of solutions, whether it's metaverse or AI or digital twins. We have validated solutions which have been tested in the lab. And then we have solutions customized for your own environment, right? We can build the solutions for your environment, for your problem. Please reach out to us if you have any questions. And with this, I would like to pass on to questions. Yeah, back to you for the questions.
Stay tuned with us. We have a Q&A session coming up next for Aruna. We'll be back after a short break. Welcome back. So we have the first question for Aruna. Aruna, since AI models need a lot of data to train, how we can build a digital twin model for a new object?
AI models need a lot of data to train, and how do we build a digital twin?
Sorry? I would like to repeat the question again. Since
yes.
AI models need a lot of data to train, how we can build a digital twin model for a new object?
Sure. So digital twin is actually not just a model. Digital twin is capturing the data from the live object, right? For example, you can think of it as a plane, right? If the plane is a real physical object, a real physical plane, which will have a lot of sensors, and we'll capture all the data from that, and we'll create a digital twin of that, right? And then we actually use models which we have actually got from earlier to impose on that and see how we can simulate that. There are different kinds of digital twins. One is actually simulation twins, which really see how you can simulate a particular process or an object or something and see something when something might fail. And then we also have process twins, right, which are really capturing the data from live and actually giving us the information of something failing in real time. So there are two different things, or you can actually have multiple kinds of digital twins. AI will play an important role because you're looking at those patterns and finding those models, creating those models. But it's actually one part of the whole digital twin.
Thank you, Aruna. We have one more question down to you from the audience.
Sure.
What are the advantages McLaren had in Formula One by having the digital twin over other competitors?
Sure. Like you have seen on the slide, they actually reduced the cost by half, and more importantly, the time by half. Right. So when they actually needed like 5 years to create a new model of a car, with the digital twin, they're able to do it in 2 years. Right. So it really reduces the time of that innovation cycle. So if something is going wrong, they can actually change the models and create more. So that's one part of it. The second thing, as I said, they have this digital twin of the car, which is actually connecting all the data from the sensors, which are more than 300 plus sensors on the car, while it's racing live, and analyzing that in real time in an edge data center and giving back the insights to the driver. So they actually give back the insights to the race engineer, who instructs the driver on what to do, whether he has to brake or what he has to do, right? So it has to be really quick. You can think of how quick the Formula One race car goes, and then analyzing the data and instructing the driver needs something really, really powerful. And this digital twin, which is processing at the edge, processes everything under 22 milliseconds. The whole round trip is 22 milliseconds. They're able to understand more about the live condition of the car so that they can make those decisions.
Thank you, Aruna Kalluru, for the insightful session.
Pleasure to be here. Thank you so much.
Thank you. We have our last keynote speech line up next.
Yeah, with me. So our final keynote for the day is by Ashmita Kapoor, who is going to walk us through how to build a scalable Web3 infra with GCP. Ashmita Kapoor is an app modernization specialist for Google Cloud, helping SEA customers to realize and fast-track their digital transformation journey. Talking about Kubernetes and containers is her passion, and she comes with an experience of working with multiple customers on serverless PaaS and fast technologies. Hi Ashmita, we warmly welcome you to our AI forum. Over to you.
Hey, thank you so much for the introduction, and good afternoon, everyone. I'm here to talk about how Google Cloud is helping in this entire Web3 area. Right? In cryptocurrency, when I talk about Bitcoin, it just took the world by a storm. And after that, there has been so many more who have joined this club. Ethereum, the Elon Musk famous Dogecoin, Tether, there is just no end to the number of cryptocurrencies available today. Then there are NFTs, DAOs, DeFi. But do you know where it all started and how all of this has come together? What really happens in the back end? I am sure you have heard of Web3, but is that another word in the mix, or are all of these related? In the next 40 minutes, we will take a journey on how all of this has evolved and how we at Google Cloud are helping Web3 organizations solve the many challenges that there are. Do you remember how the web was for us initially? It was like a huge Wikipedia with information available for us to consume. Decentralized, open, and as anyone could build on it freely, but mostly it was read-only, as only few folks had the skills to publish content. This is what we termed as Web 1.0. There were web pages which were created, a way for users to navigate across the internet.
Then came in the era of Web 2.0. That is where we are right now, the world of the social media. Web 2.0 became a two-way street. Content was available for us to consume, but in return, we provided our data as well. Now, this data was used to personalize what is being shown to us. Like, for example, my Facebook feed would be very different than what you see. The promotions and the ads that are given to me will depend on what I have been surfing on the internet. Web 2.0 was a world which was based on monetizing on personal data. The openness was lost, and the privacy had become a question. This is an internet era which has been dominated by companies that provide services in exchange for the data that we provide. But we did sign up for this. We did sign up to share our data to them. But that is not what the problem was. The problem was that who got control of this data and how they were using it. With Web 3.0, we aim to solve just that. Going back to the world of decentralized and removing the need of middlemen. Web 3 is about giving back the power to the hands of users. The users here has direct control of the digital entities and data. Anyone is allowed to participate without having to give up their data for monetization. Now think about all of the various industries that Web3 can make a difference. Now, when I want to send money to someone or receive, there will be no more need of an intermediary or a middleman. Say when I'm trying to claim an insurance, it will be all driven by machine and nobody having to come in and say, okay, why you should get that claim reimbursed or not. You get supply chain traceability. Or even very simply, when you want to rent or buy a house, imagine all of the hidden costs and hurdles that you have to go through just to get one. Web3 will aim to remove all of that and make the world a lot more open and work towards our privacy. This technology is quickly living up to its name. There are about 80 Web3 unicorns today and $930 billion in the total crypto market cap. 30 million MetaMask monthly active users, and there has been a 65% Web3 developer growth. Approximately 4.2% of the global population is owning crypto assets today. I hope you are too, at least I am. Now, at a high level, Web3 is composed of unique use cases like NFTs, which are non-fungible tokens. These are digital assets that you can own a part of the internet. Then there is DeFi, decentralized finance, a blockchain-based form of finance that does not rely on any intermediary, like banks, brokerages, exchanges. Then there are cryptocurrencies, the most famous Web3 use case that there is. These are decentralized digital money. Then there were created DAOs. These are distributed autonomous organizations, a group organized around a mission that coordinates through a set of rules enforced on a blockchain smart contract. All of these use cases are enabled with the use of blockchain and smart contracts. Now let's try and understand what a blockchain is and how it works. Now, when I talk about a blockchain technology, it's basically a protocol that allows to store data across a network of nodes. In a peer-to-peer network, you can store these data, execute transactions. It's like a distributed database, a distributed ledger. It enables us to secure way to record and keep track of the info without having to have a central ecosystem. Now let's just quickly understand how this works. Now say A wants to send 5 Bitcoins to B. A's wallet will produce a digital signature for the transaction which is based on A's private key. Now this will prove that A does have 5 Bitcoins to send to B. Now this transaction is represented as a block. If you see the way the block has been designed, it makes it immutable. There are 3 basic areas in a block. You have the data, that is, say 5 bitcoins are being sent from A to B, and the digital signature, the hash of the block which defines, okay, this is this data along with the hash of a previous block is the signature for this particular block. Now you would say, why do you need a hash of a previous block? Whereas the name suggests, blockchain is a chain of blocks, right? So that particular block, this new transaction which has come in, needs to add into the chain of blocks. So therefore it needs the previous hash as well. Now, the moment you change any of these two, whether the data or say the hash of the previous block is tampered, no more it's the same block, because a block is immutable in nature. This is the way that it ensures that security is maintained. Now, this particular block which has come in as a new transaction is then broadcasted to every node in the P2P network. Now, to be able to process this transaction, all nodes need to come to a consensus. Now, there are two popular methods to this. You have the proof of work or the proof of stake. Once the node reaches the consensus, the block is then added to the chain and B gets the money. If you do not know what proof of work or proof of stake is, just go and read about it. And there's one particular thing for you to notice. Try and see which is more sustainable in the environment today. Bitcoin uses proof of work for a consensus algorithm, whereas Ethereum is moving towards the proof of stake. Now, this entire way of working makes it irreversible, composable, completely auditable, and in a completely decentralized distributed ledger. Next comes our smart contracts. Now, a smart contract in a developer lingo is called if then else, right? All of the developers who are today have definitely coded that. Now, these are self-executing terms of agreement directly written into code, which is deployed on the blockchain network. And they're executed when the conditions are met. Let's take a simple example to understand what smart contracts are. We've all used vending machines, whereas you've given a money, the machine itself checks whether the money that you've put in and the snack that you've selected is can be given to you for the money that you've given, right? So if the amount of money applies to the snack that you've given, then it will give you the money, else it will not. So this is a kind of a smart contract that there is, which has no middleman in between. Now, who can write a smart contract? Well, anyone can, with two particular things. One, you need Ethereum, because you need Ethereum to deploy these smart contracts, and you need to know the smart contract language. Next is the DApp, or the decentralized applications. Now, once I've understood what a blockchain is and smart contracts, I'm sure you want to start trading now, right? Will you start coding to do that? Now, like a lot of you here, you might not be a very code-friendly person. So a decentralized app basically helps you with that. Just like any traditional application that you see today, a decentralized application is a front end, right? Just like a traditional app, but it uses the backend code as the form of a smart contract. The difference between a dApp and the regular traditional app is that it is non-custodial. It is not owned by a single organization. What you see here are many examples of dApps that exist today. Uniswap is one famous which uses to swap tokens. OpenSea helps you to acquire NFTs, as I said, a part of the internet. Now let's see how all of this comes together. All of this together makes a Web3 construct, a Web3 architecture. I've of course not spoken about all single items here, but only touched an upper layer. Now, as you've heard me, I'm sure there are a lot of questions that come in mind. There are a lot of challenges that you would have thought of immediately when you talk about Web3. Now let's look at few common challenges that there are. Number one, network. Now, since we said that they can be anywhere and they are not owned by one organization, there is a need to have a fast and a reliable global network so that the nodes can interact with each other. And say if I'm an NFT organization, I need to reach to my gamers, right? And they can be wherever they are. and I need to reach to them and them to access my app, the dApps that there are, in a very, very low latency. Second is security. As everything is anonymized, and again, there is no central ecosystem, security becomes a key. Being a distributed ledger, the data needs to be stored or in transit when they are being processed. They need to stay encrypted and private at all times. The third is developer experience. Now, Web3 is a growing market, right? There's innovation that is needed. So more than ever, the developers need to be able to have the flexibility that they are able to innovate. So you need a platform, you need a platform as such that is able to maintain you to release fast without having to worry about infra maintaining or security, right? Just because I'm releasing fast, I don't want to sacrifice on security, but I would rather want to shift left. Then comes data. There's huge amounts of data that being processed. So you need to, at any given point, need to know in a real-time manner, look at, say, an historical chain analysis, a smart contract insights, transaction details that are happening, or detect fraud very quickly. And the last and for all is where you're deploying all of this. Where are your nodes? Where are your applications being deployed? Infrastructure is a key. And scalability is now important more than ever. And you need to scale on demand to be able to match unpredictable volumes rather in compared to the other traditional apps that we have. Now let's see how we at Google Cloud are helping you solve each one of them. And we'll also take a look at how we've helped different companies achieve all of these 10x visions. Now, the reason that people choose Google Cloud in this era is because we are able to provide you a massive, scalable, and a secured infrastructure with low latency across the globe. Now let's look at each challenge and what the solutions are. First, infrastructure. Now many Web3 applications and node infrastructure today are running is something very common, and you all have heard of containers. And they run on GKE because that's the best place. They run these nodes and applications on GKE as containers, and you would ask, why containers? Because we could have run it on a compute engine itself, right? On just another VM. I don't need to containerize my applications and run it. Well, yes, you can still run it on a VMs because Google Compute Engine does provide you the ability to scale on demand. So you will be able to meet the unpredictability demand that you get. And the nodes are all either CPU intensified or memory intensive ones. So you can choose what suits you. But the reason I talk about containers is because it assures you, along with GKE, that the containers are immutable, they are portable, and they are able to individually scale horizontally and vertically, right? GKE gives us the ability to be able to scale your app as well as your node, not only horizontally, but you are able to scale vertically as well. With GKE Autopilot, we take it one level up. We tell you that you don't even have to manage your nodes anymore because Google becomes your SRE. We at Google manage your master nodes as well as your worker nodes, therefore be able to give you 99.95% SLA of uptime. And availability is again a key in the blockchain world. We are able to help you reduce node provisioning time or having to maintain the nodes and the application time. Customers have tested GKE at a record-breaking 15,000 nodes for a single cluster. And we are 3.2 times faster when it compares to competition. But then you would ask me, GKE is only available on GCP. What if I have a regulation and I cannot go on the cloud? I need certain aspects to run on-prem. So in this scenario, if you have a need for adopting a multi-cloud or a hybrid strategy, Anthos gives you the capability to take the same GKE on-prem or on other clouds. Now, the reason why Anthos is popular in this area is not just being able to give you Kubernetes engine, but it also helps you able to manage all of these clusters wherever they are deployed from a single control plane. You are also able to do security governance, infra and service management across multi and hybrid cloud. Now, this is about infrastructure. Now, you've deployed your application, but there would be bugs tomorrow. Is there a way that we can maybe troubleshoot it very quickly, or maybe look at metrics, have alerts, just like a normal traditional environment, but you have to be quicker when it comes to blockchain. Now, if there is a bug, with the help of Anthos, all of the logs and metrics, wherever they are deployed, shift to a central control plane. Now, you're able to traverse through your logs or look at your monitoring, or even define service level indicators or service level objectives for your nodes or your applications. Now, but these are a lot of things that it can do. But the best part here is that as Web3 tries to solve the openness, all of Anthos that you see on the slide here, everything is based on an open source technology, therefore conforming to the need of being open. Now, once you have a reliable and a scalable infrastructure, developers can now focus on innovation. But how do we even think about security here? Now, with Software Delivery Shield, Google Cloud is able to help you in this. Now, the first and foremost thing, let me start with the cloud workstations. Now, say if I'm a new developer being onboarded in an organization, I need an environment to code. What Cloud Workstations does is helps you to able to create this environment, scale it up and provision it as and when you need, with all of the configurations already built in that the developer will require for them to code. Now, as soon as a new person comes in, you just provision it and give to the developer. Now, no more the security people or your backend infra team need to worry about that. I need to ensure that this developer is using what's organization-wide allotted for, whether the configurations are consistent. They don't need to worry about that anymore. Next is when they start coding. Now, Cloud Code will help them to able to create and deploy and build or unit test their applications within their laptops or within these workstations with real-time security feedback. Now, why is this important? The reason behind today, when we code, we deploy it for our dev and ISIT environments, and then we realize that there is an error, and then we ask the developers to fix it again. This increases the loop. Now, the entire idea is, because we want innovation to be faster and apps to be released faster, we want this loop to be reduced. Cloud Code Protect will help you to give real-time feedback so that you can check if there is a problem while you're unit testing in your laptop. Now, while you're doing this code, you also have access to assured open source softwares, which are verified and tested by Google. Now, I've coded it. I've checked it into a source code repository. The moment I do that, Cloud Build, the serverless CI platform, the pipeline gets triggered, which will check out your code, build it, and create a container to store it in an artifact registry. As soon as I store it in the artifact registry, it triggers a container analysis. Now, this container analysis will scan your container from bottom up. It will scan all your OS layers to tell you if there is a vulnerability somewhere. Now, once I've done that, now this container needs to go and deploy into a Kubernetes engine or our serverless place, Cloud Run. Now, Google Cloud Deploy helps us to deploy that as well as promote from dev UAT to prod. But how do you assure that these containers, what they're getting deployed, are verified by the organization? Now, binary authorization helps us to do that. Now, as we are deploying these containers, we sign these containers with the organization's key. Now, as part of the pipeline, we will verify whether these keys is the one that the organization has been signed. In case if they are not trusted, in case of the verification fails, the image does not get deployed. Now the infra is ready, the application is deployed. Now the nodes need to talk to each other, or the application need to be accessible across the globe. Now Google Cloud provides us with a premium tier network which is globally accessed. We have 33 regions, 100 zones, and which is completely 100% carbon free since 2007. We also have 16 subsea cables which are shark free. One of the major differentiators when it comes to, and the reason we say it's premium tier, is because of our edge pops. We have 146 edge pops across the globe. Now, what do we mean by that? Now, this is where we connect Google's network to the internet via peering. Now, why do you say that's relevant? Even more in the blockchain world, because this enables to keep the traffic on Google's private network rather than on the internet. Now, this helps us to ensure that we give you better reliability, better performance, and more security. Next comes data. Now, the amount of data has increased, so we need more real-time intelligence and stream analytics. I'm sure all of the data enthusiasts that there are have heard about BigQuery. But there's a particular problem in blockchain to solve for. In blockchain, you need to execute all kinds of query for which you need to index every single block from the genesis. Genesis is the first block. This means that you need to get access to a node, which can be either operating on your own or you're using a third-party provider. Then by using the API, you'll query and index all the historical data. Then you will listen for all of the new blocks that are coming in and the transactions that are being called for, like we looked at how blockchain works, as they are being finalized. And then, of course, you need a proper DevOps process to ensure that it's operational and healthy. It's too much of an hassle, right? Now, the good news is that all of this data is available as part of BigQuery today. Our BigQuery provides public data sets that supports 9 different chains, including Ethereum, Bitcoin, Polygon, Dogecoin, and a lot of others. We have worked with the open source community and our friends at Nascent to develop an open source ETL repository to index this data. And for the costing, you only pay for when you're using BigQuery. Apart from this, BigQuery is able to provide you real-time historical chain analysis. Now, every Web3 companies now do not need to parse blockchain data into data warehouse anymore. This reduces time to market. Now, data is sorted. What about visualization? Right? You need to keep in track of all of the insights that are happening. Now, that's where Looker comes in. Coinbase, our partners have been using, or our customers have been using Looker embedded analytics for a few years now to power custom insights as part of their trading UI. Now, these insights, like the balance of trading activity at any point in time, help to provide end users with better knowledge of what's going on in the market, and thereby ultimately encouraging more trading, and for Coinbase, more fees earned. So, network sorted, security got an idea of, dev experience got an idea of, data sorted, security we have to still come to. Now, infrastructure, one portion is where you're storing all of this data, right? You need to get quick read access across the large volumes of data that there are, right? Now, how do you do that? And the major one thing that we need is that as the application needs to scale, the infrastructure where GK is scaling, your backend where you're storing this data, that also needs to scale, right? And Spanner solves all of these problems. Now, Spanner is a globally consistent, fully managed database, providing you with traditional benefits of just another SQL database, with transactions, high availability, schema changes without any downtime. The best part is that it scales horizontally from 1 to thousands of servers. Cloud Spanner has relational semantics with schemas, enforced data types, strong consistency, and ACID transactions across rows. And one of the good parts of Spanner is that you don't need to relearn a lot of things because it's not a custom SQL query language. It's just standard SQL. It gives you 4 nines of SLA or even 5 nines of SLA depending upon how you choose to deploy it. Either it can be regional or it could be multi-regional configurations. Now, internally, we've battle tested Spanner with a lot of our customers, and it's like the default database for our for our developers internally itself. Okay. Now we've looked at the major things. We come to the most important section, and that is security. Google Cloud by default provides encryption by default, right? So when you're storing all of this data in the database, or even when you're using GKE or GCE, the data that is being in transit or the data that is being stored, not just in the database, say it is being stored in my storage, my object storage, my persistent disk, which is block storage, or my file storage, they are all encrypted by default. But as I was explaining you how blockchain works, there are a couple of things that I mentioned. Use of private keys to sign, right, a digital signature. Now, a lot of employees which are being onboarded need to access all of these things also, right? So there are a lot of security aspects that you need to keep in mind. Now, the first and foremost is key management. Now, these keys that we are talking about needs to be stored somewhere. So you're able to manage these keys on GCP using KMS, or a customer managed key also is possible. With cloud identity, you can talk about the value of governing the different people who need to access the environment and ensuring by giving them the least privilege access. So say if I need to access GKE for deploying my container, I only get access to GKE, not to the rest of the product and suite that GCP has. And this really is important, especially in the global distributed workspace, right? You need to be able to give your employees the flexibility to work from anywhere, and cloud identity becomes very, very important. Next is DLP. Now, all of these systems are very, very critical. So you need to be up top or to understand or detect if there is a data loss. Cloud HSM is a cloud-hosted hardware security module for signing or executed transactions. And Cloud EKM helps us to even extend, like Anthos helps us to extend on-prem our GKE engines. Cloud EKM helps customers so that they can support several external key managers, which requires the key storage to be in a certain jurisdiction, say because of some governance, they need to be stored on-prem, or they need to follow some specific key standards, which therefore they can't store it on the cloud, right? Now, this is about the integrities that there are, but overall, there are so many hackers, right? Just in our traditional world, even in the Web3 world, it's open to so many attack vectors. With more and more anonymity that we're trying to bring in and no central ecosystem, security becomes very, very important. And you need to be up top it right at any point of time. Now, Badger DAO reveals that it was hacked for $120 million. And they hired cybersecurity firm Mandiant to do that. Mandiant is our recent acquisition from Google Cloud, which helps us to improve threat, incident, any organization to improve threat, incident, and exposure management. So you will know as soon as possible if there is a threat that comes in for that organization. So this is about GCP solving these challenges, but let's see how did we ensure that customers are using all of this. Right? Let's look at the experience with our customers and what they have to say. Now, Dapper Labs, I'm sure you've heard about the NPA Top Shot NFT. Now, the first blockchain application, they were able to reach 1 million users. And they did that by using GCE. They deployed a high-performance execution node on Google Cloud Platform. Chainstack, another customer of ours, deploys their enterprise smart contracts and app dev platform. It's running on GKE today and across multiple blockchain protocols. Hedera, the developer network focused on decentralized applications. It makes best use of the premium network tier that we provide. Theta Lab ingests from 60,000 to 200K transactions per day into BigQuery for all of the real-time analytics that I spoke about. Blockchain.com built Ethereum Blockchain Explorer with Cloud Spanner and saved 30% with costs. Block.one and other distributed ledger technology make use of the secure encrypted virtualization that there is. Now you see the slide talks about something called as confidential compute. Now all of our compute engines, whether just as a VM that you deploy or they are behind GKE, they have something called as confidential compute. Now what this means is that now not only you're encrypting the data that you're storing in a PD, on a block storage, file store, on an object store, or in a database, but the in-memory data that you have in your RAM, confidential compute helps you to encrypt that as well. So it gives you another layer of security that there is. Now, these are not just all, but we are working with so many other blockchain customers and they're choosing GCP to build. To mention two more, Axie Infinity, they power their Axie blockchain validators and game engines on GCP virtual machines and Kubernetes engine. Nascent is a leader in the data analytics. They are able to scan more than 0.5 petabytes of data in a single day to serve customers world-class insights. Now, this has been only, I would say, 30% or 40% of what we're doing to help customers. These are something that GCP already had, which Web3 customers are leveraging to deploy their blockchain or smart contracts or dApps. Now, we understand that blockchain also needs a different way of working, right? And just to make sure that the developers are getting maximum needs, what we've recently announced is a blockchain node engine. Now, while self-managed nodes are often difficult to deploy or require constant management that I've spoken about, blockchain node engine is the fully managed node hosting service that can minimize the need for node operations. Now, Web3 companies who require dedicated nodes can relay transactions, they can deploy smart contracts, they can read or write blockchain data with the reliability, performance, and security that they expect. Ethereum will be the first blockchain supported by blockchain node engine, enabling developers to provision fully managed Ethereum nodes with secure blockchain access. Now, let's just delve deep into it. Now, manually, when you're deploying a node, it's a time-intensive process, right? What do you basically do? You involve provisioning a compute instance, then you install an Ethereum client and wait for the node to sync with the entire network. Now imagine this network is huge, right? And the number of nodes that are participating in this network can be so many. So syncing a full node from the first block can take several days. Google Cloud's blockchain node engine is aiming to make this process faster and easier by allowing developers to deploy a new node with a single operation and specify the desired region and network. Now, this is just so many things that Google Cloud has been doing, and there are so many things that the larger parent company, Google or Alphabet, has been doing. That's all that I had today. If there are any questions, I would like to defer to that. Thank you.
Thank you. So stay tuned with us. We have a Q&A session coming up next. Vashmita will be back after a short break.
As data continues to change and drive businesses, the private information of individuals and companies continues to be at risk of exposure. Since 2004, data breaches have led to the loss of over 17 billion records, which have cost companies millions of dollars in damages. Do you know what sensitive data you store, where you store it, and who has access to it? Most organizations overlook the importance of securing their sensitive data. The challenges of knowing what type of data you have, where it is, and who's accessing it are made even more difficult by cloud and big data environments. We understand you value protecting your customers' data. However, the data collected can be monetized to your advantage while ensuring the privacy of your customers' data. Introducing Incognito, a data anonymization platform that cares about your sensitive data. Incognito helps you to discover, secure, and monitor personally identifiable information, sensitive customer data that is crucial to an organization's operational success. Whether your data is in the cloud or on premises, Incognito gives you the freedom to manage all your workflows from a central location. Many government organizations and industries have their own regulatory compliance when it comes to the protection of sensitive customer information, like HIPAA in healthcare, PCI DSS compliance in the banking and finance service industry, along with other governing bodies that enforce data standards. Violating these regulations can have serious consequences. Incognito consists of configurable, pre-built data classifiers which automatically detect sensitive data in your data assets. Incognito uses powerful algorithms to anonymize your data regardless of the format or size, enabling you to freely analyze and monetize this data while protecting your end users' privacy. At Axiata Digital Labs, we believe with the right data, you have the power to make a real impact. That's why we keep your data safe so you can focus on what you do best. Interested? Get in touch to find out more. Axiata Digital Labs, advancing digital life.
Welcome back. So we have questions for Ashmita from the audience. Ashmita, the first question is, what are the measures taken in GCP Cloud to avoid information breach in Web3?
To answer this question, actually, it's just not with Web3. Even in the Web2 world that we are in today, we have so many organizations deploying their applications. Information breach or data breach is the most important thing that we always have in our top of mind, right? There are various things that I have already mentioned. Google Cloud out of the box provides encryption, right? And these are keys which are managed by us. So nobody has access to keys, even the developers who are developing these products or us who are even talking about these products to other customers. Not even the storage, but the encryption is in transit, the data in transit as well. Apart from that, you have cloud, I spoke about cloud identity, KSM, you can utilize all of these to ensure that even if you are bringing your own key to encrypt the data, it's safely put in place. Then is about the traffic that is coming in into Google Cloud. You have Cloud Armor, which gives you out-of-the-box WAF capabilities so that you can ensure all of the geo-listing that you can do and the traditional WAF rules and policy that you can put in right there. You even have reCAPTCHA, which is out-of-the-box available by us to help you ensure that these processes and transactions are happening in a secure way. So I would say whereas security becomes very key in Web3, but it's just not Web3. Any application, data breach is the most important part, and there are so various areas, whether they are on runtime, whether we are something we are deploying. There are best practices that we always work with our customers that they are ensuring that there is no breach that there is. Yeah, thank you.
Advertising is the core revenue generator for most social media platforms. how will Web3 impact those advertising and media?
I was expecting this question, right? Because this is like a very, very common question to ask that, okay, I spoke about Web 2 and it was all about data monetizing of data, and Google does that. So we have ads, right? You have YouTube, you have ads. These were the ones, along with others that there are dominating the internet industry today. Well, I won't look at the question in this way that, okay, what now, right? But we look at it this way. Web 1, Google helped move with all of the innovations that was brought in with search and ads. We've been able to come here, and Google has always been a pioneer in the evolution, or always been there to be contributing into the entire evolution of the World Wide Web that there is. And Web3 is another interesting area that we kind of we look at. Rather than looking at what will it do with our ads revenue, there are so many areas that we can leverage, from NFTs, with working with customers, with their DeFi, or all of that I spoke about, right? Being hosted with a blockchain node engine. Now we can host these blockchain nodes right out of the box, right? So these are various other areas that we are looking at, and we are mostly looking at being an innovator and contributing to the community, rather than thinking about what will happen to Web 2. All of our different products, Google Pay, YouTube, then there are other non-Google, right? As part of the alphabet, there are so many various ways that we have been trying to work with the community in different industries, right? All of the 10x visions, we're trying to have different new 10x ways to solve all of those problems. I spoke about insurance, I spoke about housing, helping agricultural industries use Web3 technology, right? So these are the areas that we're kind of trying to contribute more, rather than looking at it, right? What about the Web3, Web 2 section there?
Well, thank you, Ashmita, for the wonderful session and for joining us today with our AI Forum.
My pleasure. Thank you so much for having me here.
So we'll take a short break and come back to announce the winners of our podcast series for Day 2 and Day 4 and today's AI Forum. Stay tuned.
we detected a highly sophisticated and targeted attack on our corporate infrastructure.
I didn't used to think that a foreign military would come after us, and now they obviously are.
This was something that we'd never seen before.
A new kind of problem. It's not just country versus country. All of us are somewhat on these front lines.
It's their job, 24/7, to try to break into places like Google.
Hope is not a strategy. You need a team of professionals with exactly the right knowledge and expertise.
It's mildly ominous.
To do the kind of work we do, you need to cherry pick the best of the best.
I might qualify it by saying I'm an ethical hacker, but yes, I'd say I'm a hacker.
Definitely consider myself a hacker.
Hacker.
I wear mostly hoodies for some reason.
This is very serious.
The attacker's after something, and you want to find out what they're after.
The attack happens over Christmas.
Santa may arrive late this year.
Someone is always rattling your doorknob to see if it's unlocked.
We're constantly testing our products.
Car companies crash their cars to make sure they're safe. So do we.
So much more is at stake now.
Human rights,
Privacy, professional life, personal life.
The entire ecosystem around an election.
It's not just securing Google, it's securing the internet.
I'm in this battle because I believe we can win.
Hunt them down, contain them, and then boot them out.
burn it down.
If any attackers try to get in, I want them to have a very bad day.
Imagine a technology partner invested in your dreams, where we take the time to understand your aspirations and give you the opportunity to transform them into reality through disruptive innovation. We are Axiata Digital Labs. We are a team of IT professionals, data scientists, cloud solutions specialists, creative design engineers, spanning 7 global offices. We are enriching the lives of over 500 million people. We have successfully delivered projects globally, specializing in digital telco solutions, mobile money, fintech, IoT, AI, machine learning, data analytics, and self-care solutions. Using our expertise and domain knowledge, we have helped challenge the norms of industries and rewrite the rules of engagement. We provide our customers with agility. We provide them future-ready products now. Axiata Digital Labs, advancing digital life.
PayPal has reached people where traditional financial institutions have not been able to reach. In the US, there are close to around 30 to 35 million users who don't have access to banking.
Not only do we want to power every transaction that happens around the world, but we also want to support millions of people around the world who are underserved by the current financial system. Payment just should be so convenient it becomes like air.
We needed a partner who has those capabilities globally and can help us and scale with us fast enough.
Google scored well across all of these criteria.
I feel they are my team.
Everything starts with the customer. No two people are similar. It changes how you think of a problem, what problems you solve, and how you solve those problems. We want the agility to make sure that we can deliver to our customers the features that they desire the moment we actually come to know of it. Every millisecond matters. I've never been more excited about what technology can do for businesses. Google Cloud is safe, secure, reliable. We could leverage them and go from just being a repository of data to creating information from that we could use to take our business to the next level.
We are helping millions of customers, making them part of the economy. It's just amazing.
We are here to change the world. That's what we are trying to do with payments.
Now, moment of truth. It's finally time to announce the winners for day 1 and day 3 of the podcast series, as well as the winners from today's AI Forum quiz.
Our sponsors for day 2 and day 4 podcast series, One Lexicon, are giving away a gift pack which includes Samsung Galaxy Watch 5 Pro, JBL Charge 4, and Samsung Galaxy Buds Pro 2 for each lucky winner. As you know, today's AI Forum sponsor Google is giving away a brand new Google Pixel Watch and a 256GB Google Pixel 7 for the winners of today's quiz.
I feel jealous of the winners, Pragesh, after seeing the gift list. Anyway, without further ado, let us announce the winners of the day 2 podcast series. First, let's roll out the red carpet. So, the day 2 of podcast series winner is Sahan Disanayaka from Sri Lanka. Congratulations, Sahan.
Thank you, ADL. Thanks for the opportunity.
Who's next, Pragesh?
Next, we have the winner for our day 4 of the podcast series. And the winner is Tilan Madhumadeva from Sri Lanka. Congratulations, Tilan.
Actually, I would like to thank you for ADL and organizing committee for giving me this valuable opportunity. Thank you very much.
You're welcome, Tilan.
You're welcome and thank you. So now it's to announce today's quiz winners of AI Forum Day 2. So the winners of the first quiz is... The winner is Ching Wei Yong from Malaysia. Congratulations, Ching Wei. We have another last winner.
Yeah. Next, we have the winner of the second quiz. And the winner is Rashni Kavisha from Sri Lanka.
Thank you so much for giving me the opportunity.
Congratulations, Rashini.
Congratulations, Kavisha. So, well, now, dear ladies and gentlemen, we hereby mark the end of our second AI Summit 2022. Thank you for being such a wonderful audience, and special thanks goes out to our distinguished speakers and panelists for making these sessions fruitful for the past 6 days. We would also like to thank our sponsors of the podcast series, Dell Technologies and One Lexicon. Also, Huawei and Google for sponsoring this year's AI Forum.
Last but not the least, we would like to thank Impressed Events for bringing a liveliness to the forum with this amazing virtual background. And thank you for all the countless people in Axiata Digital Labs and Axiata Group who helped with the event marketing, organizing, and much more. So we couldn't done it without you all.
That concludes the remarkable Axiata Digital Labs AI Summit for 2022. If you missed out on any of today's sessions or want to share these amazing sessions with your friends and colleagues, head over to our YouTube channel for all the videos.
Yes, and Rithmi and Pragesh had an amazing day taking you through the AI Forum. Hope this will be a new beginning for more AI-powered future. Thank you so much for the amazing audience, and see you all in our next AI Summit at the lab. Good night.
Good night.
Audio is a really powerful medium because it's so personal and engaged to who you are.
It is the most intimate and the most connecting medium. And what we're seeing today is that there's this new technological revolution taking place, and that opens up a whole new interest and explosion of audio.
Spotify is definitely more than just a music company these days. Recently, we expanded very substantially into podcasts.
I'm Alex Bloomberg, and this is Without Fail.
Our mission at Spotify is to connect 1 million creators with 1 billion fans. So that's very exciting. It's also a huge challenge.
The problem is bigger than just the number of fans that we have. It's also the amount of content that we have.
We have a huge catalog, 130 million audio files. The scale is growing so fast. At peak, we're seeing 8 million events per second, 500 billion events per day.
Data is basically the core of running our business, and if we're not able to get the latest insights about our users, we're not able to see the key statistics about our business, that's a problem.
We were reaching the sort of tipping point where the current system wouldn't scale anymore.
And that's where Google Cloud comes in. Google Cloud takes care of a lot of the complexity of our business.
We don't need to worry about the infrastructure. We don't need to worry about all the details that aren't core to our product. It's intuitive, and it makes scaling effortless.
And that frees us up to do Spotify-specific things. Being creative, being innovative, experiment faster, and get results way faster.
Google understands engineering culture, and they've really brought that to the cloud platform.
It's been a massive improvement in our ability to make our employees at Spotify more productive.
In addition, I think one of the most powerful parts of our partnership has been our engineers and Google engineers sitting together in the same room to solve some of our most difficult problems.
Because they're able to access petabytes worth of data at their fingertips very simply.
Moving to Google Cloud and their platform really freed us up to accelerate our development, and we kind of skyrocketed.
It basically unlocked infinite capacity.
Building the audio network of the future, it takes that intimate connection really to the next level, and that we believe will help us lock additional innovation in the audio space.
We have a very strong belief that we can, together with Google, build the best cloud for us.